So welcome to this Java Full Course 2025. Over the next few hours, we are diving deep into everything you need to know to become a Java Pro. This isn't just another tutorial. It's your roadmap to mastering one of the most in-demand skills of the decade. So what's on the agenda, right? So let's break it down. We'll start with Introduction to Java, where we will explore what makes Java so powerful and why it stood the test of the time. Then we will move on into how Java programs work so you can understand what's happening under the hood. Next, we will cover the building blocks of Java, variables, operators, and control flow with if-else statements and loops. You will also learn how to control execution with break and continue statements. And once you have understood the basics, we will cover some more topics like strings, arrays, and multidimensional arrays. But that's not all. We will explore methods, method overloading, Java classes and object, and OOPS concept to help you write clean, reusable, and object-oriented code. Following that, we will learn about recursion, then exception handling to make your programs reliable and error-free. And we will cover many more topics like that. All of these with hands-on examples so that you can also try those examples parallelly. And because we want you to be job ready, we will wrap up this session with top Java interview questions so you can walk into any Java interview with confidence. By the end of this course, you won't just know Java, you will think in Java. So without any further ado, let's get started. Hey everyone, welcome back to another video by UpGrad. Today we are diving into the introduction to Java. Yes, the language behind some of your favorite apps and games. You have probably heard of PUBG, right? Well, believe it or not, Java is one of the key languages behind it. Well, in this video, we'll start with history of Java, dive into what programming languages are, and then explain what Java is all about. You will learn what Java is used for, the cool features that make it stand out, and different components of Java that make up the language. We'll also talk about Java syntax and show you how to write your first program in Java. Stay tuned till the end of this video as we will share some valuable strategies to kickstart your Java learning journey. But before we begin, make sure to subscribe to the channel and hit the bell icon to never miss any update. Now, let's get into the history of Java and find out how this language, which started way back in 1995, is still so relevant today. And trust me, this story is a lot more interesting than you think. Did you know Java was actually created by accident? Yep, it all started around 1992. James Gosling, who's the guy behind Java, was working over at Sun Labs. He and his team were originally trying to build a set-top box, like those devices that connect to your TV. To make things work, they began cleaning up another programming language called C++. But during that process, something unexpected happened. Instead of just modifying C++, they ended up creating a completely new language. And guess what they called it? Oak. Why oak, you ask? Well, it was named after an oak tree that stood outside James Gosling's office. Pretty cool, right? But here's where it gets even more interesting. When they were all set to roll out Oak, they hit an obstacle. It turns out a company had already registered that name. So what do? Sun Microsystems marketing team jumped in and renamed it to Java, inspired by their favorite coffee beans. And that's how Java got its name. So yeah, programming language named after coffee. How's that for a backstory? Fast forward to January 2023, 1996. That's when JDK 1.0, that is Java Development Kit, was officially released. And this wasn't just any release. It was a start of something big. Java quickly started gaining traction because of how versatile it was, and the best part? Since its first release, Java has only gotten better with a ton of new features added over the years. Today, it's used in everything. Windows, apps, web apps, mobile apps, enterprise solutions, and even smart cards. And as I mentioned earlier, Java also plays a huge role in games like PUBG. So, from a little accident invention in the 90s to being everywhere today, Java's journey has been nothing short of amazing. Now, before moving on to Java, we need to understand how programs and programming languages function, setting the stage for understanding Java's role in the broader landscape. So imagine your computer is like an assistant. You give it tasks and it gets them done in the blink of an eye. But here's the catch. Your computer doesn't understand English or any human language for that matter. It only speaks binary, a language of zeros and ones. So how do we as humans communicate with this machine? That's where programming languages comes in. Think of programming language like a translator. You write instructions in language like Java, Python or C++, and the computer translates those instructions into binary, its native language, so it can execute them. For example, let's say you want your computer to perform a simple task like adding two numbers. You write that instruction in Java, and then behind the scenes, Java translates that into something your computer can understand. Now, how does Java come into play here? Java, as we mentioned earlier, is designed to be platform independent. What that means is, let's say you want to write a program in Java on your laptop and you want it to run on a different device. You don't need to rewrite the entire program with Java's help. Your code can run on pretty much any device that supports Java without any changes. This is why they say Java is write once and run anywhere. Here's how it works. When you write a Java program, it first gets translated into something called bytecode. Think of bytecode as Java's own universal language. Now this bytecode doesn't run directly on your computer. Instead, Java uses something called Java Virtual Machine, that is JVM, which is like a translator for each type of device. The JVM reads the bytecode and translates it into the machine code specific to your device, whether it's laptop, phone or even a server. So you have understood about bytecode and JVM. Alright, now let's answer the big question. What is Java? If you have been exploring the world of programming, you have definitely came across Java. And there's a solid reason why it's so popular. Java is one of the most widely used programming language out there and is known for being super versatile and reliable. So what makes it so special? First off, Java is what we call a multi-platform, object-oriented and network-centric language. That's a fancy way of saying it's designed to work across a lot of different devices and systems. From mobile apps to huge enterprise systems, Java can handle it all. It's like the Swiss Army knife of programming languages. It's fast, secure and reliable, making it perfect for pretty much anything you want to build. One of the coolest things about Java is its principle of write once, run anywhere. This means that when you write a program in Java, you don't have to worry about which device or operating system it's going to run on. You write your code once and it can run on Windows, Macintosh, Linux, you name it, without any changes, it can run. This platform independence is a huge deal, especially when you're working on projects that need to run on different devices. Now let's touch on Java's object-oriented nature. This means Java helps you create reusable and modular code. Think of it like building blocks you can use again and again. It makes your code scalable and easier to manage. We will dive deeper into object-oriented programming into our upcoming tutorials. Alright, so whether you're developing web apps or mobile apps or even large enterprise systems, Java's got your back. Its extensive collection of libraries, basically pre-written code that you can use, makes the development process a lot smoother. From small mobile apps to big data applications and server-side technologies, Java can do it all. Now let's talk about what Java is used for. And trust me, it's everywhere. So Java is highly adaptable programming language used across multiple industries. In web development, Java powers dynamic websites, e-commerce platforms, and enterprise applications. Popular frameworks like Spring and Java Server Pages, that is JSP, use Java to create websites that can grow and handle a lot of traffic. When it comes to mobile apps, Java is the main language for building Android apps. Developers use Java with Android SDK to create feature-packed apps that run on millions of phones. In the enterprise world, Java is used for building robust systems like CRM software, ERP systems, and financial management tools. Java also has a huge presence in scientific research, data analysis, and even machine learning. Thanks to its powerful libraries, it's a go-to for artificial intelligence applications like natural language processing and deep learning. Alright, now let's talk about what makes Java such a standout programming language. There are a few key features that really set it apart, and I'm going to break them down in a way that's easy to understand. First off, one of the coolest things about Java is its platform independence. This means that a program you write in Java can run on pretty much any device or operating system. How does that work? Well, Java uses something called JVM, The JVM acts as a middleman between the code you write and the device or operating system you're using, and converts it into something your computer or phone can understand. Now let's talk about how Java is object-oriented. Java follows something called object-oriented programming, which basically means it organizes your code using objects and classes. This helps you reuse code easily and makes your programs more organized and easier to manage. Another thing you're going to love about Java is its memory management. Normally in programming, you have to keep track of how much memory your program is using and then clear it out when you're done. But Java handles that for you with something called garbage collection. It automatically cleans up memory when it's not needed anymore, so you don't have to worry about doing it yourself. Then Java is also great at handling errors. Things don't always go smooth when you run a program, right? Well, Java has a built-in way to catch and handle mistakes when they happen. This feature called exception handling makes sure your program doesn't just crash when something goes wrong. Instead, it lets you manage the problem and keep things running. One more amazing feature of Java is multi-threading. This feature basically means that Java can run multiple tasks at the same time. Imagine trying to watch a video while downloading a file in the background. Java makes that possible by allowing your program to do several things at once, which makes it faster and more efficient. Now, when you start using Java, you will see that it comes with a huge standard library. This is a collection of pre-written code that helps you do all sorts of things, like connecting to the internet, working with databases, or even just reading and writing files. It saves you tons of time because you don't have to write everything from scratch. Then there is security. Security is another big deal with Java. It's built with some really strong security features that protect your program from harmful things like viruses and unauthorized access. Java checks your code to make sure it's safe before it runs and creates a secured environment for it to work in. Lastly, Java is super dynamic. This means you can change parts of your program while it's running. You don't have to stop everything to update your code. Java lets you add new features or fix bugs on the go, giving you a lot of flexibility. So this was about the features of Java. Now let's understand components of Java. First up, we have the JVM, that is Java Virtual Machine. This is super important because it is what allows Java program to run on any device or operating system. The JVM takes the Java code you write, which gets turned into bytecode and runs it. It also handles things like memory management and garbage collection behind the scenes, making sure your program runs smoothly. Next component is JRE, that is Java Runtime Environment. Think of this as the package that includes everything you need to run Java programs like JVM, runtime libraries, and class libraries. However, it's important to know that JRE is only for running Java applications, not for writing or developing them. Lastly, that is the third component is JDK, that is Java Development Kit. This is the complete toolkit you'll need if you want to develop Java programs. It comes with JRE plus tools like Java Compiler, Debugger that help you write tests and fix your code. So this was about the components of Java. Now let's have a look at the syntax of Java. Alright, let's break down the Java syntax. So when you're writing a Java program, one of the first things you'll notice is the main method. This is super important because it's the entry point of every Java program. You will see it in every single Java file you create. The main method looks like this: public static void main string arguments, as you can see on the screen. Now, I know that it might look a little confusing at first with all these keywords like public, static and void, but don't worry, you don't have to fully understand them right away. We'll cover what those mean as we go further in this tutorial. For now, just know that the main method is where your program starts running. One more thing to remember: every Java program has a class name, and this class name has to match your file name. Inside this class, you'll always find the main method, and that's where the magic happens. Now let's look at how we can actually do something inside the main method. One of the simplest things you can do is to print text on the screen. For that, we use this line, system.out.println, and inside the double quotes, hello world. Inside the double quotes, whatever you write, it will get displayed. Now, there's also a method called print, which is similar to println, but there's a small difference. While println adds a new line after your message, print just prints the message and stays on the same line. So if you use print and want everything on one line, that's your go-to method. So as you can see on the screen, system.out.print hello, system.out.print world. If we write this program in Java, it will print hello world in a single line. But if we use println instead of print, then it will display world in the next line and hello in the previous line. Lastly, Java doesn't just print text. You can also print numbers, variables, and pretty much anything you need. We will cover that in more detail as we go deeper into learning Java. So this was just a basic syntax of Java. There are many other things as well that we will be covering. Alright, now let's get started with writing our first program in Java. Alright, so this is our browser. So here we will do the Java programming in an online compiler. For the further tutorials, we'll be using an IDE or code editor, but for our first program in Java, let's do it on an online compiler. Alright, so we'll type online Java, online GDB Java. Alright, so we'll click on it. Yeah, here it is. So let's just remove this. So basically, as you can see on the screen, this is public class main. So here public is an access modifier. It means that the main method is accessible from anywhere, including outside of the class. We'll discuss it in the further tutorials. Then class is the keyword, then main is the name of the class. Alright. Now inside it, we'll be creating the main method, which is the entry point of any Java program. Alright. So we'll start public static void arguments, then the brackets. So here you might be wondering what is static. As we already know, public is a access specifier or access modifier. Static here is a keyword in Java that is used to indicate that a particular member belongs to the class itself rather than the instances or. And here void. Void is basically the return type. So void keyword means that the main method doesn't return any value. We'll be learning about void in the coming tutorials, so you don't need to worry about all. So main is the function that we know, and the string arguments. So this is a parameter basically that the main method, it's an array in the form of text that allows you to pass arguments to your program from the line. Alright. Now here we want to write our first Java program. So basically we'll say hi or hello to the Java world. So what we'll do is system.out. Hello. So this is hello Java that we have typed. Now we have to run this program. Alright, so we'll go to run. As you can see, hello Java is printing in hello. So this is our first. Now if we want to rewrite it multiple times, we can just simply copy paste it and paste it multiple times. Then again we click and it will display hello Java 3 times on the compiler. Now we can also alter that whatsoever you want to write, like let's say I'm writing hello Sam and here I'll write hello. So it will print that only. So whatever is written inside this curly braces, that will be printed. So it's, and as we already discussed that the difference between println and print. So here I'll show you. So this is println, but instead of println, if we'll use system.out.print and simply we'll type hello Sam, then this hello John will be printed along with this in the same line as that of hello Sam. Alright, so so as you can see, hello Sam and then hello John. So both of these are getting printed in the same line. And if we want to print hello John in the next line, we'll simply use println instead. Here it is, hello Java, hello Sam, and repeat. So I suppose now you have understood the difference between println and print. And we just wrote our first, so we have just wrote our first program. Alright, so this was about our first Java program. Now let's understand how to start learning Java for beginners. Alright, so how to start learning Java for beginners? First thing first is make a schedule. So create a learning schedule. Consistency is a key when learning a new skill like Java. Set aside some dedicated time each day or week, even it's just an hour or two. The goal is to build a habit. You will find that practicing regularly helps everything sink in. Next up, it's important to clear your basics. Start with the fundamentals of Java like syntax, variables, data types, loops, and conditions. I repeat, these are the building blocks of everything you'll repeat. Take your time with these concepts as a strong foundation will make learning more advanced topics easier. Then, this can't be stressed enough. Practice, I repeat. The only way to get better at Java is by writing code. Start by solving simple problems and gradually move on to more complex challenges. Websites like LeetCode have tons of beginner-friendly coding problems you can try. Practicing will not only improve your coding skills, but also build your... Then, generate algorithms. Once you're comfortable with this, start focusing on generating algorithms. This means learning how to break down a problem and figure out the steps needed to solve it using code. It's like solving a puzzle. Your goal is to write the logic that makes... Then, repeat. It is also important to learn about version control, specifically Git. As you start coding more, you will want to keep track of your projects. Version control helps you save different versions of your code, so you can go back and fix things without losing your work. It is also essential if you plan to collaborate with others. One great habit is to try coding on paper first. Before jumping straight into the computer, write down the logic or steps on paper. It helps you think through the problem without getting stuck on the syntax. Once you have worked it out, you can type it up and test it. Next is read Java programs documents regularly. Stay updated by reading Java programming documents regularly. The official Java documentation is a great resource. It may seem a bit dense at first, but it's packed with useful information and examples that will deepen your understanding of the beat. Plus, it's a habit all professional developers have. Getting comfortable with documentation will really help in the long run. By following these steps, you will be able to learn Java in a structured and, I repeat, start with basics, build good habits, and practice. Now let me ask you a quick question. Do you want to take your tech skills to the next level? Our Masters in Computer Science program is perfect for anyone looking to advance their career in development. In this program, you will learn advanced Java concepts, data structures, design and analysis of algorithms, front-end and back-end development, system design, and much more. You will gain the knowledge and skills needed to become a leader in your field. Don't miss out. Click the link in the description box to start your journey to mastering computer science today. Alright, let's wrap things up. We have taken at Java history, what it's all about, and how it's used in different areas. We covered its features, the important components, and even got hands-on with a basic Java program. For those just starting out, we talked about how to begin learning Java. Java's an awesome language with endless possibilities. Thanks for watching this video. Now it's your turn to dive in and start. Hey everyone, welcome back to another video by UpGrad. Today, we are going to walk you through the process of installing Java on Windows 10 computer. Whether you are just starting out or need a refresher, we have got you covered. I will walk you through the steps to download and install Eclipse on your Windows 10 desktop or laptop, and by the end, you will be all set to write and run your own Java programs. So what is code editor and IDE? As a beginner, when you start coding in Java or any other programming language, you will need a place to write your code. Think of it like this. When you write a story, you use a word processor like Microsoft Word or Google Docs, right? Similarly, when you write a code, you need a tool that's designed to help you out. That's where code editors and IDEs, that is Integrated Development Environment, comes in. A code editor is a simple tool where you can write and edit your code. Think of it as a specialized text editor like Notepad, but with extra features that help you write code more efficiently. Some of the common examples of code editors and IDEs are IntelliJ for professional Java work, Eclipse for customization, VS Code for lightweight versatility, and Sublime Text for speed and simplicity in coding. So now that we have understood about code editors and IDEs, let's have a look at how to install it on Windows. In this video session, we will download and install Eclipse on our system to run Java programs. So without further ado, let's jump in. So this is our browser. First, we need to download the Eclipse installer. So now we will head over to official Eclipse website by typing Eclipse IDE download, or we can simply type Eclipse into our browser search bar. Alright, so to keep things simple, we'll simply type Eclipse. Alright, so this is the first link. This is the official website of Eclipse. We'll click on this and the official website opens. Now here we can see download option. We'll simply click on this download option and this will navigate to this page. Now here it is visible. Install your favorite desktop IDE packages. We'll click on download. And here we can see it includes JRE, so we don't need to separately download all these things, JRE and all. So we'll simply click on download. Now we'll be selecting the place where we want to download it. So yeah, it is getting downloaded, as we can see. So as you can see, it is downloaded. We'll click on this. So the installer is opening. Let's wait. Alright, so the installer is open. Now we can see different options over here. So as a beginner and we are doing the Java development, so we will be selecting this first option, Eclipse IDE for Java developers. But if somebody wants to do all this programming in C, C++, he or she might select this option. And there are various options like PHP developers and whatnot. So it's up to you what you want to select. As we are doing Java programming, so we'll be selecting the first option. So we'll click on this. And here we'll have to select the model. The latest we will select, so JRE 22.0.2. So by default it is that only, so we'll be selecting this. And if you want to create a menu starting, menu entry, and create a desktop shortcut, you can select or unselect this one. It's up to you. I'll be selecting both of these. Now we'll simply click on install. Except now it is installing. Let's wait. It might take some time, but you have to be patient with it. So yeah, let's wait. So yeah, as it is visible on the screen, the installation is completed. Now all we have to do is to click on launch. It is opening. Let's wait. Alright, so now we have to select the directory. So we'll click on browse. If you want to change what is already there, what is by default, I don't really want to change it, so I'll simply click on launch. As you can see on the screen, the Eclipse is open. Now what we'll have to do is to will go to files, just do that. Yeah, now we'll go to files and we'll click on new, and then we'll go to Java project. We'll click on Java project, and as you can see here, we'll have to write the project name. For example, let's say we'll write example tutorials. Alright, so this is the location where it is getting saved. Use default location. If you want to change, you can unselect it and do as per your choice. So we don't want to change it, so we'll keep it like that only. Now as we can see, this is the model. We have selected Java SE 2022. So I'll not change it. I'll keep it this only. And yeah, pretty much it. You don't have to worry about anything else over here. We'll simply click on finish. Now we'll cross this welcome screen. So as you can see, this is Eclipse workspace. Now what you'll have to do is you'll go to the source. By clicking over here, the source will come. We'll go to source and right click on it. Here you'll go to new. Over here you can see Java class. So we'll select Java class. So it will create a Java class. For that, we'll be adding the package name and the class name basically. So let's keep the class name as study. Let's say study itself, and package name is tutorial. Alright, now we'll click on. So basically these are the modifiers: public, package, abstract. So you don't need to worry about that. We'll be covering. So now we'll click on finish. So as you can see, this is our Eclipse. So here we can easily code. We don't need to worry about any package or something. So everything is there. So let's just write a simple program over here.
So first of all, as we can see, this is public class study. So this is a class that we have created. We have to now create a main function. So for that, public static void main. Now string arguments. Inside the brackets, we'll do system dot out. We're gonna print something. Print ln. Now let's say we'll write hello UpGrad. All right. So keep in mind, always do this semicolon thing, because usually we forget that. So you have to keep this thing in mind. Now, how do we run this program? So for that, you'll go, first of all, we'll have to save it. For that, you can go to file and you can just click on save all. And I've done, I repeat, and I've done with the help of Control and S. You can do with that as well. Now we'll go to example tutorials, the package, right click on it, and here is the option run as. We'll click on run as this first Java application, that means this application, and it will run this program. So as it is visible, Java hello UpGrad, it is printed. So whatsoever we'll do will be visible over here. Just make sure to save it. By pressing Ctrl and S, you can save it, and by going over here, clicking right and run as first Java application, we are running it. As you can see, 2 times it has printed hello UpGrad. So this is how you can do this in Eclipse.
So this is how you download and install Eclipse on your Windows 10 computer. With Eclipse setup, you're ready to start your Java programming journey and build some amazing projects. It's a powerful tool that will support you as you learn and grow your coding skills. In the coming tutorials, we'll be diving into various Java topics to help you build a solid foundation in programming. We'll be using Eclipse to write and run our Java programs. Stay tuned and get ready to take your Java skills to the next level. Ever wondered what actually happens when you run a Java program? I mean, how does your computer actually take those lines of code and display something as the output? Well, you're in the right place. Today, we are diving into behind the scenes of how Java programs actually work. This knowledge isn't just useful, it's something that is often asked to you in your interviews. We'll break it down step by step. We'll explore everything from what happens when you first write your code to the moment it actually runs on your system. By the end, you will have a solid understanding of both the compilation and execution stages of Java.
So how does the Java programming language work? When you write a program in Java, you are creating what's known as source code. This is the code that you as a developer write using a text editor or an integrated development environment, that is IDE. It's in a format that's easy for humans to read and understand, but it's not something your computer can execute directly. To make this code, it first needs to be translated into a form that your computer can understand, and that's where Java compiler comes in. The compiler takes your code and converts it into an intermediate form known as bytecode. This bytecode can run on any operating systems as long as that operating system has the Java runtime environment, that is JRE. Unlike C++, where the code must be recompiled for different systems, Java's bytecode is portable. It can be executed anywhere, making Java a truly portable language. The process doesn't stop at compilation. Once the source code has been compiled into bytecode, the next stage is execution. During this stage, the Java virtual machine, that is JVM, comes into play. The JVM is a part of Java runtime environment, and its job is to execute the bytecode. When you run a Java program, the JVM interprets the bytecode and translates into a machine code that your computer can understand. This translation happens on the fly, which is why Java programs can run on any system with JVM regardless of any underlying hardware or operating system. So this was about how does Java work. But what exactly happens under the hood when you run a Java program? Let's take a closer look at how Java programs work internally, step by step. So the first thing that you see is the class declaration, public class UpGrad. Think of a class as a container that holds your code. Here we are naming our class as UpGrad. Public is an access modifier. which indicates that this class is accessible from other classes, meaning other parts of your program or even other programs can use this classes if needed. By the way, your class name UpGrad needs to match your file name, that is upgrad.java. If they don't match, Java will get confused and won't run your code. So make sure it is same. Now that we have got our class set up, let's move on to the entry point of Java program, the main method. So next is main method, as we said, public static void main string arguments. This is where your program starts. It's like the starting point of your code. Java looks for this method or function when it starts running your program. Public is an access modifier, which means that the method can be called from anywhere, even outside the class. The static part means it belongs to the class and not to the objects of the class. So Java doesn't need to create an object to run it. And void is a data type, which means it doesn't return anything. The string arguments parameters allows the program to accept command line arguments if any are provided when the program runs. With the main method ready to go, the next step is to actually do something like printing a message to the console. So inside the main method, we have this line system.out.print. Let's learn Java that we have wrote. You can write anything you want. All this does is print that message to the console. You know, the black screen where you see outputs? Here's how it works. So system is a built-in class that comes with Java. Out is a special tool in that class that lets you send stuff to the console. Println is a method of the print stream class that prints what you tell to it. And it even adds a new line at the end, so each message starts on its own line. Okay, so now that we know that what code does, let's see what happens when you click on run the program. So compilation is the next step. Compilation just means turning your human readable code that you wrote into something the computer can actually run. When you compile your Java file, that is upgrad.java, the Java compiler checks if everything is correct. If it is, it turns your code into bytecode and saves it in a file called upgrad.class. This bytecode is like a universal language that any computer can understand as long as it has Java installed. So once your code is compiled into bytecode, the next step is to get ready to run, that is class loading. Once your code is compiled and you run the Java program, Java's engine, that is JVM, loads that bytecode from upgrad.class file into memory. The JVM does a quick check to make sure everything is safe and sound before moving on. It's like a pre-flight check before taking off. With the class loaded and everything checked, it's time for the main event, that is executing the main function. So after the class is loaded, the JVM looks for that main function we talked about earlier. This is where the real action begins. Java creates a little workspace in memory called a stack frame for the main method and start running the code inside it. As the main method runs, it reaches the part of the code where we print something to the console. Alright, now printing to the console. As JVM runs the code, it hits the system.out.println line. This is when the message "Let's learn Java" gets printed on the screen. That's pretty much it. And once everything is printed and done, the program finishes up. That is the termination. Finally, once the main method has finished executing all its statements, the program comes to an end. This is known as termination. The JVM then releases any resources that were allocated during the program execution, such as memory. During this entire process, the JVM also handles other important tasks like memory management and exception handling to ensure that your program runs smoothly without any issues.
And there you have it. We have explored how Java programs work from the moment you write your code all the way to when it runs on your computer. We covered everything from class declarations, the main method and printing statements to how Java compiles and executes your code. Now you should have a much clearer understanding of what's happening behind the scenes every time you run the Java program. In the next video, we will understand variables in Java. So do subscribe to the channel because we will cover the complete Java series in the upcoming tutorials. Now before leaving, if you are interested in boosting your Java skills, our Master in Computer Science program is perfect for anyone who wants to grow their career in development. In this program, you will explore advanced Java, learn about data structures, algorithms, front-end and back-end development, system design and more. You will work on 7+ case studies and projects, get hands-on experience with 7+ programming tools and languages, and benefit from one-on-one mentorship to guide your every step of the way. Don't miss out, click the link in the description to start your journey to mastering computer science today. Hey everyone, welcome back to another video. So variables in Java. Variables are the foundation of any Java program and mastering them is necessary if you want to master Java. Today in this video, we are diving deep into variables. We are going to cover everything you need to know about variables, from declaring them to assigning them and initializing them. By the end of this video, you will have a solid understanding of variables and be well equipped to use them effectively in your Java programs. Also, in the end of this video, we have something important for you. So stick around till the end and I promise you will finish this video with a solid understanding of variables. So variables in Java. Imagine you have a bunch of boxes in front of you. Each box has a label on it, so you know what's inside without opening it. These boxes represent variables. The label on the box is like the name of the variable. It helps you identify what's inside the box. What's inside the box is the value of the variable. It could be anything, a number, a word, or even a decimal point value. Let's say you have a box labeled age, and inside this box is the number 7. This means that the age variable has a value of 7. Now imagine you have another box labeled name. Inside this box you might find a word like Alex, representing someone's name. This means the name variable has Alex as the value. To store values in memory, we need to reserve some space, which is done using a variable. So in Java, there is a little extra step because Java is what we call a strongly typed language. This means when you create a variable, you also need to say what kind of thing or the variable you are going to put inside it. So each variable has a specific data type. If you want to store a number in your variable, you need to specify that your variable is meant for numbers. For example, you might create a variable for age using the type int, which stands for integer. If you want to store words or letters like your name, you would use the type string. If your number has a decimal point like 7.28, you need to use a type like double to store it. Specifying the type of variable is important because it helps Java understand how to handle the value inside the variable. For example, you can do math with numbers, but you can't add a number to a name. By knowing the type, Java can prevent mistakes and help your programs run correctly. In Java, there are different types of variables. For example, int. So basically, int is used to store whole numbers without decimals. For example, 42 is an integer. Now, the second one is double. Double is used to store decimal numbers, offering more precision for values like 3.14, 7.28, 5.65 like that. Then there is string, used to store sequences of characters like words or sentences, such as hello, such as John, Robert, or any other name. Then there is float, also used to store decimal numbers but with less precision than double. Alright, next is character or char. It is used to store single characters, that is a, whether it is lowercase or uppercase. Then there is boolean. Boolean is used to store values that represent two states, either it's true or false. So these are the data types that you need to take care of. And these are the variables that are being used with it. Alright, now coming to the declaration part. So in Java, declaring a variable is like telling the computer, hey, I'm going to need some space in memory for this piece of information. So basically, when we are declaring, we are allocating space in the memory. For that, first you tell Java what kind of data you're going to store. That is the data type that we just discussed. This could be a number, string, double, and so on. Next, you give your variable name. This name is what you will use to refer to that piece of information. It should be like type, then the variable name as it is visible on the screen. So for example, type can be int and the variable name can be num, and type can be string and the variable name can be name. So it's up to you what variable name you want to put. It's your choice. Alright, we have to make sure the type of the variable matches with the data inside it, otherwise it will show an error. Now if we want to declare multiple variables, then we can easily write type name1, name2, name3. separated with commas. You don't have to write separately. I mean, it's your choice. If you want to write separately, then also you can do that. But if you want to write in one single line, then you can do like this, separated by commas. And in the end, make sure to put this semicolon sign. It acts as a full stop. So this was about declaration. Now, let's move on and understand assignment. Now, if we want to store a value inside a variable, we use assignment operator. Assignment in Java is done using equal sign. When you use the equal sign, you're telling Java to take whatever is on the right side of the equal sign and store it in the variable on the left side. For example, id equals to 12. So here we have assigned a value 12 to id, which means whenever you use id in your program, Java knows that it refers to the number 12. One important thing about assignment is that you can change the value stored in a variable later on. This is called reassignment. But yeah, make sure the assignment always takes from left to right. So as we can see on the screen, 12 is the value that is being assigned to the variable id. Alright, so let me tell you this with the help of an example. Alright, so this is our Eclipse IDE that we just installed in the previous videos. So here we'll do some programs to let you guys understand variables in Java in a proper way. Alright, so first of all, so let me tell you first what is declaration. So here this is declaration. So basically what I'm doing here is I have wrote the data type, which is int, and after that there is a variable name, and this part is known as declaration. Alright, after that I'm gonna assign a value to it. Let's say a equals 10. So this is basically assignment. Alright, so if we keep or merge both of these parts together, it becomes the initialization. As simple as that. Just write int a equals to 10 and semicolon. Make sure to put semicolon in the end, because if you're starting on Java, you'll keep on doing the same mistake by ignoring this thing. So make sure to put semicolon in the end. So this is basically initialization, as we said. Alright, so this is initialization. So we can also keep like this only. We don't need to include this if we are doing initialization in a single step. So this is how you comment using backslash, double backslash. It will become a comment. So the Java code will not read it, okay? If you want to do like this, you can do that. I'm gonna do this because I'm gonna show you something. So now, if we try to print it, system.out.println, so what do you think? Will it print or not? Let's see. I have saved it by pressing Ctrl and S. Now I'll go to example tutorials, right click on it and run as first Java application, proceed. Alright, so there's some error it is showing. As we can see, system.out.println. So we have read over here, it is mentioned clearly. We have done this mistake. We have put dot after this, and now again we have to save it. And now let's see if it runs or not. We'll try to run this again, control, first Java application, and as we can see, it is getting printed. So yeah, instead of doing declaration and assignment in a different line, you can do in a single line as well, initialization. And even if you do like this only, then also you don't have to do this initialization. It's up to you what you want to do. Alright, now just in case if you want to know whether the previous thing, that is declaration and assignment, doing separately will work or not, let me show you guys. Now we'll make this comment and now the Java code will run it. Alright, now let's save and let's see whether it will run or not. Alright, as you can see, 10 is there. Now using variables, you can also add or subtract numbers or anything. So for example, let's do something about it. So let's say we have a number num1 and we will assign a value of 25 to it. We have another variable named num2 and we will assign value 26 to it. Now if we want to do addition of it, we'll type system.out.println, as we know, semicolon in the end, and here we'll do num1 plus num2. Alright, now we'll save it and let's see if it will work or not. So as we can see, it is printing 51, which is 25 plus 26 equals to 51. So it is correct. But yeah, instead of doing this, you can do one more thing. You can use another variable to store the addition of num1 and num2. So let's say this another variable is result. Now you can write num1 plus num2. Now what here we are doing is we are storing the addition of num1 and num2 from left to right. As we discussed, from left to right is the assigning. So here num1 plus num2, whatever the value is inside it will be added and assigned to result. Now here while printing, we'll simply write the result variable. We'll save it and run it. So as you can see 51. So yeah, if we'll change the digits, let's say we'll make it 10 and save it, and let's again try to run it. The addition is 36 as you can see. Now instead of doing addition, you can also do subtraction. Alright, let me show you an example. We'll save it, and there are various other operations that you can do that we'll simply learn in the further tutorials. Alright, now before that we need to understand many things like variables, data types. So let's understand that first. Alright, so I'm gonna write some data types and variables, and I'm gonna write what is that variable and what is that data type. Alright, so int age equals to 25 semicolon. So basically, what do you think, what kind of variable it is? Yes, it is a integer variable. Another type of variable is double, as we discussed earlier. So double, as we discussed, kind of it's like a decimal point value, so you can use it like this, 5.9. We'll type double in variable. Alright, so double variable for decimals basically. Now the third one is character or char. Here we'll type the name of character as initial, and you have to store in quotes. Whether it can be uppercase letter or a lowercase letter, it's up to you, whatsoever you want to store. Alright, after that there is boolean. Boolean is male or is student or anything you want. It's the variable name, you can have your variable name, it's up to you. Alright, it can be true or false, so you have two choices to keep it whether true or false. Then there is string. So if you want to store a name or anything, a sentence or something, then you use string. String name equals Alice. Yeah, so make sure to put semicolon in the end. Alright, so now let's just print all these. System.out.println. Alright, so here we'll type name because we want to print name equal to the name of the person. So we'll do like this, name equal to. Now if we want to print a variable, so what we'll do is we'll write plus, that is the addition operator, and name. That's all you want to do. And as you can see, as soon as we type name, it is indicating this variable. So yeah, it is the same variable. So now what this will do is it will print name equals to Alice while printing on the console over here. So this is how you have to use the variable name when you are printing something with it. So whatever you want to print should be in double quotes, and the variable name, make sure the variable name shouldn't be in the double quotes. Alright. Slowly when you do the coding by yourself, you'll realize these things. So you don't have to worry much about that. Just keep in mind these things. Alright. Now the another thing that we want to print is age. So we'll write age equals plus the name of the variable, that is age. So instead of wasting time, we just copy and paste. Alright, so here we'll use HEIGHT, height, and the name of the variable. Height is the name of the variable. These things are a bit case sensitive, so make sure to write it as it is so that you don't want to take risks, right? So you have to do like this only. Initial equals to the name of the variable is initial itself, as you can see. Okay, now what left is the boolean thing. Yeah, system.out.println. I'm gonna write it now because this is the last one. Yeah, so system.out.println, inside it what we'll write is the name of is male, double quotes, is male. So gender will type, and the name of the variable is male, this one. Now let's try whether it will run or not. What we're gonna do is we'll save it, yes, And now let's try to run this. Right click, run as first Java application. So as we can see, here name is Alice, age is 25, height is 5.9, initial A, gender true. But if we use another variable, like let's say I'm using integer with a string, like here I'm using integer, then what do you think? Will it print or not? Let's try this. Well, I know it will show an error, but still. So as we can see, it is showing unresolved compilation problem. There's a compilation error. So we have to correct it. String with a capital letter, string. Same goes for this one. It may look like an integer, but it is not because decimal point is there. So we should use double with it or float. Alright, so this is how you have to be correct with the data types when it comes to variables. If you're going to do some examples, you'll definitely learn about it, so you don't need to worry much about that. Now what we will gonna do is we'll do a simple example of swapping two numbers. But before that, we need to understand what's the logic behind it. For that, let's do a pseudocode run. So basically, swapping two numbers is, let's say ki one number is 10, another number is 20. We want to swap both of these numbers so that the 20 comes in the place of 10 and 10 comes in the place of 20. So this is what we want to do with the help of Java program. So to make this understand, we here will show you a pseudocode. So first, we will declare a variable called a and assign it to a value of 5. Next, we declare another variable b and set it the value of 10. We know how to declare and assign a value, so we can do that. We don't need to worry about that. Now, this is simply printing the values of a and b before swapping them. It helps you see what the variables are before making any changes. Because here we're going to print these because we want to show before swapping those numbers how it is looking like. A has the value of 5, b has the value of 10, but we will print it to show that it does have those values. Alright, now we will introduce a third variable, temp. Assume it like a temporary variable. This variable is used to temporarily store the value of a. So now temporary variable temp holds the value of 5, that is the original value of a. This step is important because we are about to change a, but we need to keep its original value to assign it to b later. Alright, here's the actual swap happening. First, we assign the value of b to a, which means a now takes on the value of b, which is 10. Next, we assign the value of temp to b, which means b now takes on the original value of a, which was stored in the temp, that is 5. This prints the value of a and b after the swap has been performed. So you can confirm that the values have been successfully swapped. Let's do this example. Alright, so we are back on our editor IDE. Now we are doing a swap function. Alright, we will write a program to swap two numbers. Alright, so first of all, let us assign a value of 5 to the a variable. Simple, this is the initialization. Here is the data type, here is the variable, here is the assignment. So int a equals to 5. Now a holds the value of 5. Another variable is b, int b equals 10. Now b has the value of 10. Now to simply show the people, we will print it. We'll write something as well, like before swap, this is the value, okay. So plus, as I told you, operator a, then again we have to use plus because we are doing another variable. So yeah, before swap. Now we have to do actual swapping. Now as we can see, as we told earlier, temp, which is the temporary variable. You don't have to take the temp word itself, you can name it as per your choice. It can be C also, it can be Z also, it's up to you. We have to show the temporary variable, that's why I'm using temp. Now first what we're going to do is we're going to store a's value to temporary variable temp. So a has the value 5 right now. We have given the value of a to temporary variable. Alright. So basically we are using temporary variable to pass the value of a to b. That's all we are doing. So now a has the value of 5. We have given the value of a to temp. Now temp holds the value of a, which is 5. Alright. Now once a has given its value, a becomes empty. Now a is empty. So b said, let me give you my value, which is 10. So now B has given his value 10 to A. Now A holds the value of 10. Remember, A here is 10. Alright. Now after that, now B becomes empty because B has given his value to A. Alright. So now temp said, I will give you my value. So as we know that here temp has the value of 5, which is given by A. Now temp has given 5, the value of A, to B. Now here we'll again type B here is 5, which is the value of A. So basically we have swapped both the numbers with the help of the temporary variable. It is as simple as that. System.out.println, and let's write after swap. Alright, let's save it. Println, yeah. So let's save it and let's see if there are no errors, it will run. So as you can see, before swap the value was 5 and 10, and after swap the value is 10 and 5. I know it may look like 510 and 105. Let me do something about it. What we can do is we can add some space in between. Alright, so yeah, here also we can do the same. I'm gonna save it. Let's see, let's run it. As you can see, before swap 5 and 10 was the value of A and B. After swap A becomes 10 and B becomes 5. So this is as simple as that. We have done nothing here, we have just took the temporary variable which passes the value of A to B, that's it. So yeah, this is pretty much about it, and I want you to perform this program on your console, whether it will be an online compiler or Eclipse IDE, it's up to you, but do perform this. Maybe you have to watch this video again and again, but do watch and do like this. It is very easy and this will help you gain confidence in it. Alright. Now I'm going to tell you some things to keep in mind that we just told you in the starting of the video, which is very important for you guys to remember. Alright, so things to keep in mind. Do not redefine variables. Avoid declaring a variable with the same name more than once within the same scope to prevent errors and confusion. Just do the examples like I did. You don't need to worry about anything else. Don't overcomplicate things. Keep it simple as you're starting with it, so you have to keep it simple. Slowly you'll learn to do the advanced programs. Alright. Second is initialize variable before use. Always assign a value to variable before using them to avoid unexpected behavior on runtime errors. So make sure to assign a value before using that particular variable. Alright. Third one is understand the data types. Be familiar with Java's data types. It's not that difficult. For example, int is used for numbers, you can say, without decimal numbers. String is for the names and things like that. Double is for the decimal type of numbers, and like that only there are various other data types. So you have to be familiar with these data types to ensure proper handling of values and avoid type mismatches. Alright. So all you have to do as of now is to do the examples that I did and keep these three things in mind. That's it. And that's a wrap. We have covered everything you need to know about variables in Java, from declaring, assigning and initializing them, with the help of some hands-on example also. Hopefully you are feeling more confident handling variables now. But we are just getting started. In the upcoming videos, we will dive into conditional statements, loops and explore operators, plus a whole lot more. So stay tuned because there's a plenty of awesome content coming your way. Thanks for watching this video. Have you ever wondered how your code knows when to add, compare or make decisions? That's where operators comes in. They are the backbone of every calculation, comparison and logical choice your program makes. Java provides you with a rich set of operators, from simple arithmetic to complex logic. In this video, we will guide you through everything you need to know, from basic arithmetic to logical and relational operations. We will make sure you understand each concept clearly. By the end of this video, you will be confident using operators to write clean and efficient code. So what are operators in Java? Think of operators like special symbols that are applied on variables to perform operations. These operations can be anything like adding two numbers together, checking if one number is bigger than the other, deciding if two things are equal or not, and many more. In Java, operators work with operands. Operands are the values or variables that the operator acts on. For example, in the expression 5 plus 3, the plus is the operator and 5 and 3 are the operands. The operator tells Java what kind of action to take with these operands. Java has a variety of operators that allow you to do all sort of things. And you will see these operators pop up in pretty much every piece of code you write. So Java provides a wide variety of operators, each with its specific function. So now let's explore the types of operators in Java. So arithmetic operator is the first one, assignment operator is the second one, then there is relational operators, logical operators and unary operators. So these were the types of operators. Now let's explore them one by one. Alright, so at number 1 we have arithmetic operator. So arithmetic operator allow you to do things like addition, subtraction and multiplication and more within your code. They work on numbers like integer, floats, etc. and help you do calculations just like you would do with a calculator. There are 5 main arithmetic operators in Java, each designed to handle a specific type of math. So first one on the list is addition. So the addition operator, this operators add two numbers together. It's the same as the plus symbol you would use in any math problem. Alright, then second one is subtraction operator. So this operator subtracts one number from the other. It helps you find the difference between two numbers. At number 3 we have multiplication. So this operator multiplies two numbers together. It's your go-to operator when you want to scale or increase a number by multiplying it. So make sure in this multiplication operator you don't have to use the multiply sign, but instead you should use the star operator. That is the multiplication operator. Alright, next up we have is division operator. So this division operator divides one number by another. It's important to note that when you divide two integers in Java, the result is also an integer. So no decimals. Then there is modulus operator. So this operators gives you the remainder when one number is divided by another. It's really handy when you want to check if a number is even or odd, or if you are working with numbers that cycle like days of the week. To make it understand, you can take an example of 11 divided by 5. If we divide 11 by 5, then we'll get the remainder 1. So basically, it gives you the remainder instead of the quotient. In division operator, you get the quotient, but in the modulus operator, you get the remainder. So that is the difference between these two. So don't get confused. Alright, so this was about arithmetic operator. Let's do some examples on it. Alright, so this is our Eclipse IDE and I'm sure that you guys have it. Now here we'll be doing an example of arithmetic operator where we'll be adding, subtracting and then we'll multiply, division operator and then we'll use the modulus operator as well. So make you guys understand, so we'll be doing this example. First of all, we'll declare two variables, int a let's say equals to 45 and another variable let's say equals to 20. Let's name it b. So we have declared two variables, a 45 and b 20. Now we want to add these basically. So what we'll do is system.out.println and this is the semicolon inside where we want to print a plus b. So we have used double quotes because we want to print it like a plus b equals to the answer. So we have used double quotes. Now using this operator we'll be writing the addition. So here as we can see we have used the addition operator a plus b. Now if we'll run this program, it will print the desired output, that is the addition of 45 and 20. Let's try to run it. First of all we'll save it, then we'll run it. Run as first Java application. As you can see it is printing a plus b equals to 65. If we wouldn't have used a plus b in the double quotes, so it will simply show 65, but we have used this way because we want to make it look good, right? So that's why we have used it. Similarly we'll do for the subtraction operator and the other operators as well. So let's do it. System.out.println. Now here again we'll do the same thing. A minus B equals to. Here we'll be using the subtraction operator. A minus B, simple as that. Alright, now we can just copy paste it, but I will advise you guys to write all this system.out.println, because then only you will be able to write it as per choice. Alright, now A minus B. After A minus B, let's do the what we call multiplication. So we'll use this asterisk sign, A into B basically. Then system.out.println. I'm gonna write it. Now here what should we write? A divided by B. Alright, so A divided by B. Write in the comment section what you think, what will it give. Alright, now the modulus operator, system.out.println, double quotes, A mod B equals to A mod B. Alright, so this is here we have used all of these operators, and if we'll subtract 45 from 20, I repeat, if we subtract 45 from 20, it will give the answer. Likewise, all these operators would work. So let's save it first. Now we'll try to run this. Run as first Java application. So as we can see, A plus B equals to 65, which is correct, and 45 minus 20, which will give us 25. This is also correct. A into B, 45 into 20 equals to 900. It is also right. Then A divided by B. So here you will notice that it has given us 2, but as we know, we have used integer, so it won't give us the decimal point value of it. If we would have used float or double, then it would have given us that decimal point value, but as we are not using float or double, so it will give us integer value without any decimal. So that's why it has used this. Alright, so after this we can see the mod, A mod B. This particular thing, A mod B, will give us the remainder and not the quotient. I'll just mention remainder. Here I'll mention quotient, Q for quotient. Okay, so this will give us the quotient, the normal division. This will give us the remainder. This is what you're going to use in the programming a lot. So make sure I repeat, so make sure you understand this thing. Alright, so now that we have covered how arithmetic operators work in Java, let's move forward. It's not just about performing calculations in Java. You also need to store and update those values in variables, and that's where assignment operators comes into play. Alright, so assignment operator. In Java, assignment operators are used to assign values to variables. It's a way of telling Java to store a specific value in a variable. The most basic assignment operator is the equal sign. But Java gives you more tools to combine assignments with some basic math too. Let's walk through the different assignment operators first. So at number 1, we have the simple assignment. So this is the most common one you will see. It takes the value on the right side and assigns it to the variable on the left. For example, if you write int a equals to 5, it means the variable a now holds the value of 5 because we are assigning 5 to the a variable. It's that easy. The next one is add and assign. This operator adds the value on the right to the variable on the left and assigns the result back to the left hand variable. It's like a shortcut. Instead of writing a equals to a plus 5, you can simply write a plus equal to 5. Don't worry guys, if you are not understanding it as of now theoretically, we'll be doing the examples after this one, so you don't need to worry. Just try to understand what I'm conveying. Alright, now this was about add and assign. The third one operator is subtract and assign. Just like add and assign, this operator subtracts the value on the right from the value of the variable in the left and stores the result back in the variable. So instead of writing a equals to a minus 2, you can just use a minus equals to 2, which will mean the same thing. So it's up to you. Alright. Then next one is multiply and assign. So this operator multiplies the variable by the value on the right and assigns the result back to the variable. So a equals to a into 2 becomes a into equals to 2. It is the same thing. Simple as that. Next one is divide and assign. So this operator again divides the variable by the value on the right and stores the result back in the variable. It's a shortcut, a equals to a divided by 2. So you can just write a divided equals to 2. Then there is modulus and assign. So this operator finds the remainder when variable is divided by the value on the right and assigns that remainder back to the variable. Instead of writing a equals to a mod 3, you can simply write a mod equals to 3. Alright, so these were the assignment operators. Now let's understand it with the help of an example. Alright, so we are back on Eclipse IDE. Let's just remove this part because now we'll be doing an example of assignment operators. So one by one we'll do these examples of each and every operator. Alright, now as of now we are on the assignment operator. So first of all, we will create a variable, we'll declare a variable. So let's do that. Int x equals to 8. Alright, now let's declare another variable, let's say result. Now we will assign a value using the equal to operator. So let me just comment it out for you guys. Assign value using equal to operator. Alright, so how we're gonna do that? Result equals to x. So here the value of x is 8 as we have mentioned. Then we declared another variable result. Now what we are doing is we are simply assigning the value of x to the result variable as we told you earlier. Here the assignment takes place from the left to the right. So keep in mind, assignment is always taking place from the left to the right. So as we know the x has the value of 8, now we are simply assigning that particular value of 8 to result. Alright, that's it. Now we'll write system.out.println. We'll try to print it. Now semicolon result using equal to, simply plus sign we use, then result. That's it. Now let's try to run this. First we'll have to save it. I hope it runs. I think there is some error. Alright, so we haven't used the braces properly. Alright, we have used. Again we have saved and we'll try to run. As you can see, result using equals to operator is 8. So basically we are showing how assignment operator works. Alright, it is very simple. You don't have to be very attentive about it. It's very easy to understand. Now I'll do another one, that is add and assign operator that we discussed. So let me just write assign using add and assign operator. Alright, so here we'll simply write result plus equals to, we'll give some space, plus equals to x. So here what it actually means is result equals to result plus x. That's it. These both things are equal. So it's up to you. If you want to write it like this, then it's up to you. If you want to write it like this, then again it's your choice. So basically this add and assign operator means this, and this goes for each and every operator. For subtract and assign operator the same thing is happening. Alright, and for multiplying and assign operator the same thing is happening. That's it. You don't have to worry about it. Alright, now we'll try to print system.out.println. Now here we'll write result using plus equals to operator. Alright, so let's save it first. Now let's do another one, then only we'll do this. Let's do for multiply and assign operator also, then we'll run it. So assign using multiply and assign operator. Alright, so here result, again we'll do the same thing, this asterisk sign which is the multiplication sign, then x. That's it. Here this means the same thing, result equals to result into x. So basically it's the shortcut. It's both the same thing. If you want to write it in shortcut, so this is what you can use, and this is being used while doing the programming and coding thing. Alright, so system.out.println. Alright, now we'll write double quotes result using multiply equal to plus, now here we'll write result again. All right, so let's try to save it. We have saved it. Now let's run it. First Java application, and as we can see, result using assignment operator is 8, result using plus an assign operator is 16, which is correct because result already has this 8, then it will add 8 plus 8, then it will like this only, it will go this 8, 16 it will become, and same goes for this, like, so here multiplication thing is also correct. So that is how we are gonna proceed with this operators, that is the assignment operators. So now that we have seen how assignment operators let us store and update the values, it's time to explore how we can compare those values. That's where relational operators comes in. Alright, so let's move on and understand relational operators. Alright, so now relational operators. Relational operators in Java are used to compare two values or variables. Think of them like asking Java questions such as, is this number bigger than the other one? Are these two things equal? Based on the comparison, they return either true or false, which is super helpful when you're writing conditions for things like if statements. Some of the relational operators are, first, equal to. So here double equal to is there. So this checks if two values are exactly the same. If they are, it returns true. If they are not, it returns false. As simple as that. So don't confuse assignment and equal to operator. In Java, double equal to sign means equal to operator and single equal to sign means assignment operator. So don't confuse these both. Alright. So next one is not equal to. So this not equal to operator checks if two values are different. If they are different, it returns true. If they are not, it returns false. Next one is greater than. So this checks if the value on the left is greater than the value on the right. If it is, it returns true. Next one is less than. So this operator checks if the value on the left is less than the value on the right. If it is, it returns true. Make sure we are always telling you that on the left to the right. So we have to check like that only. Next one is greater than or equal to. So this checks if the value on the left is either greater than or equal to the value on the right. If either is true, it returns true. Alright. Next one is less than or equal to. So this less than or equal to checks if the value on the left is either less than or equal to the value on the right. If either is true, it returns true. That's it. Now let's understand this relation operators with the help of an example. So let's go to our Eclipse IDE. Alright, so this is our Eclipse IDE. First of all, let's remove this code. Alright, so we have removed the code. Now let's do examples of relational operators. So here we are going to declare two variables. First, we have assigned the value 10. Next one, let's say 20. Alright. So just to showcase you guys, I'm just printing these values. Dot out dot println y. Alright, now just to show you guys 10 and 20 as we can see. Alright, now first of all, we'll have a look at the equal to operator. Alright, so system dot out dot println. So as we know, the value of x is 10 and the value of y is 20. So these are not equal, we know that. So now with the help of equal to operator, we are just checking if they are equal or not, and the output will give us the value as true or false. Alright, so double equal to y, this will give us the value like, and here we will use this operator x equal to y, or equal to operator you can say. Alright, so this is equal to operator. So let me just write all the operators and then we'll run it and explain each one of it. Alright, just to mention, here I'm going to comment this thing. This is basically the equal to operator. Alright, now here we'll do another one which is not equal to operator. System dot out dot println. Alright, here in double quotes we'll write x not equal to y, and here x not equal to y. Alright, so as you can see, here we are using not equal to operator. Similarly, we'll do for all the other operators. Let me just copy paste it. Alright, now here we can use greater than operator, and here also we'll have to do the same thing. Similarly, here we'll use greater than, let's say, equal to operator. Here also we'll write, and then there is less than equal to. My bad. We'll keep it like this, and here we'll use the greater than equal to. Alright, the next one is less than equal to. So less than equal to, here also we'll do the same, less than equal to. Alright, so as we know that x value is 10 and y value is 20, so this is gonna be false, okay, because x is not equal to y. So this will give us false. And this is not equal to operator, and here it is showing x value is greater than y's value, which we know is not true because x value is 10 and 10 is not greater than 20. So as it is a not operator, because it is the opposite of the equal to operator, so it will give us the value as true. All right, so we'll mention this true. So this one is greater than equal to. Now here it is mentioned x is greater than equal to y, which is not, because 10 is not greater than equal to 20. So here we'll again write false. Right, so this one is less than equal to. So yeah, either it should be less than or it should be equal to. It is less than equal to, I repeat, as 10 is less than 20, so that is why it is true. All right, now let's save it and try to run this. Here we'll go to run as first Java application. All right, so this is the output. So as we can see, previously the values were 10 and 20. Just to showcase you guys, I have printed 10 and 20. Then we can see x equal to y, that is if x is equal to y, it is false, and we also wrote false. X is greater than y. So here x is not greater than y. So that's why it is false. We by mistake we have wrote true. All right. Next one is x is greater than equal to y. This is again is false, and this one is x is less than equal to y. This is true basically. So yeah, it is a simple, very basic example of this relational operators. You can try this example on your own. So as a starting, you should give it try to these kind of example, and slowly you have to practice the much more advanced examples as well. But as a starting, as your guys are starting from now on, so you can give it a shot on these examples. So with the relational operators, we can now compare values. But what if you need to evaluate multiple conditions at once? That's where logical operators step in, allowing you to combine conditions and make more complex decisions in your programs. All right. So for that, let's now understand logical operators in Java. So logical operators in Java. So logical operators are used when you want to combine multiple conditions or expressions and make decisions based on whether they are true or false. They help you decide things like, are both the conditions true, or at least one of these conditions are true. The three main logical operators in Java are AND, that is we called logical AND. Then this operator basically checks if both the conditions are true. If both are true, it returns true. If even one of is false, it returns false. Think of it as saying this AND has, I repeat, think of it as saying this AND that must be true. So basically, for this one, both the conditions must be true. Then only it will give you the value as true. Otherwise, it will give you the value as false. All right. So the next one is logical OR. So this operators check if at least one condition is true. If either condition is true, it returns true. It only returns false if both conditions are false. It's like saying either this or that needs to be true. All right. I hope you guys are understanding what I'm conveying. Next one is logical NOT. So this operator flips the result basically. If a condition is true, it turns it into false. And if it is false, it turns it into true. It's like saying I want the opposite of this condition. That's it. It's simple as that. Now let's understand this logical operators with the help of an example. Alright, so again we are back on Eclipse. Let's just remove this thing. This code we have removed. Now here, first of all, we'll create variables. Boolean variables we are creating. As we know, Boolean are like either true or false. Boolean b equals to false. All right, now system.out.println. Here what we'll do is we'll simply write the operator. But before that, we'll be using this in double quotes as we are doing for all other examples. So plus A and B. So basically here we are using logical AND. So let me just comment it and write for you guys so that you can understand. This is logical AND operator, all right. Similarly, system.out.println. Here again we'll write the OR operator. All right. So this is logical OR. Now the third one is logical NOT. So as we discussed, it basically complements the condition. It will negate it. So let's just write logical NOT. Right here, not A. All right, now system dot, again we'll do the same thing, dot println. All right, so here we have used logical NOT. It will just make true to false and false to true. That's it. And this is logical OR. Either this condition is true or both. As I told you that in logical OR, it checks if at least one condition is true. If either condition is true, it returns true, and it only returns false if both the condition are false. So like that. And when it comes to AND, this operator checks if both the conditions are true. If both are true, it returns true. If even one is false, it returns false. So this is the difference between these two and logical NOT, as I explained. All right, now let's save it and right click. Now we'll run it. So as you can see, A and B, which give us false, which is true. This is the output of it. A or operator, B true, which is correct, as both either of these should be like as I told you. So it is correct. Then there is logical NOT. As we know, A is true, then basically NOT operator is negating it. So it is making it false. Then there is NOT B. So B was previously false and it is making it true, as we can see. So that's it. This was about the logical operators. So this is the basic example. You can give it a shot to understand it, and then you can try some more complex examples on it. All right. Now that we have understood about the logical operators, so this was basically about the logical operators. So unary operator in Java. Unary operators in Java are used when you want to perform an operation on just one value or variable. That's why they are called unary, which means one. These operators can help you do things like increasing or decreasing a value, changing a sign, or even flipping a Boolean value. Here are the common unary operators in Java. First one on the list is unary plus. So this operator doesn't change the value but can be used to explicitly indicate a positive number. In most cases, you won't need to use it since numbers are positive by default. Then there is unary minus. So this operator negates the value, meaning it turns a positive number into a negative and vice versa. Think of it as flipping the sign of a number. Next one is increment, that is plus plus 1. So this operator basically increases the value of a variable by 1. It often used in loops or when you need to step through the values. There are two ways to use it, that is pre-increment and post-increment. In pre-increment, it increases the value before it's used, and in post-increment, it increases the value after it's used. We will understand it in the following tutorials. All right. Next one is decrement operator. So this operator decreases the value of a variable by 1, just like plus plus but in the opposite direction. All right. So it is also of two types, that is pre-decrement and post-decrement. So yeah. Next one is logical complement operator. So this operator is used to reverse a Boolean value. If a condition is true, it flips it to false, and if it's false, it flips it to true. For your information, the logical complement operator and the NOT operator are essentially the same thing, but they are referred to by different names in various contexts. All right. So now this was about unary operator. Now let's do an example on it. So let's go to the Eclipse. Alright, so this is our Eclipse, and here we'll be doing an example on unary operators. Alright, so first of all, we are going to declare two values, or you can say variables. Int x equals to, let's say, 25, int y equals to 25. Alright, now we'll declare two more variables, int incremented value, alright, and another variable is decremented value. Alright, so two more variables we have declared. So basically now we'll print the original value of x, okay? System.out.println. Here we will display the original value of x, alright? Now here we will use the increment operator. So let me just comment increment operator. So what increment operator does is basically it adds a value to 1, like one value it adds, like if it is 1 it will become 2, if it is 4 it will become 5, if it is 7 it will become 8. So basically it increments, as the name says, alright, simple as that. So incremented value, right, equals to plus plus, that is the pre-increment x. Now system.out.println. So what do you think, what will be the value? Here we'll write after increment, now plus here incremented value. Alright, so basically here we are printing the incremented value. We have done the increment operator, we have used it with the variable x, and we are storing this value to incremented value. Now what we'll do is we'll basically print it so that we can find the difference between the original value of x and the incremented value of x. Alright, that's what we're gonna do. Same goes for the original value of y. So now first of all we'll print the original value of y, println, here we'll print y, here we'll write, let's make it capital only. Okay, so original value of y. Now after decrement, okay, so we'll write decrement operator. System, no, first of all we'll have to store this value, decremented value it was, yeah. So we are storing the value of y to the decremented value variable. Alright, so here is assigning going on, y to decremented value, as we did here. So here we'll have to use the pre-decrement operator and then we are assigning. Okay, so now system.out.println. So as we know, as this will increase the value by 1, so basically this will decrease the value by 1, simple as that. As the name suggests, increment and decrement you can figure out, right? Alright, now what we'll do is write after decrement. So decremented value. Alright, so this is the decremented value. Now let's save it first and now we'll try to run this. So as we can see, the original value of x is 25. After increment, that is after using increment operator, we are again printing it, which gives us the value of 26. Similarly, the original value of y was 25, as we can see, original value of y. After decrementing this value, as we can see, so here we have decremented the value here, and then after decrement we are storing this value to decremented value. After that we are just printing it. So after decrementing the value becomes 24. So these increment and decrement operator are the ones that you will use most while doing the programming and while doing the loops thing. In loops also you guys will use this operators, both of these operators. Alright, now I want you guys to work on these examples. If you want, we can attach a source file where we'll be writing these source codes in the document or a sheet below this video. Also, I want you guys to try these examples and do some more examples on the basic level only. Slowly you have to try some complex examples and then intermediate examples as well. So you have to do the practice makes you perfect. And yeah, so these were the examples of operators that you can try. So by mastering these operators, you can handle everything from simple math to complex decision making in your code. Whether you're incrementing values with unary operators or assigning variables with assignment operators, these operators will be your constant companion as you develop in Java. In this video, we understood arithmetic operators, assignment operators, relational operators, logical operators and unary operators in Java. With this foundation, you are now ready to dive deep into more advanced concepts in Java. In the next video, we will be exploring conditional statements essential for controlling the flow of your program. Stay tuned and get ready to take your Java skills to the next level. Hey everyone, welcome back to another video by UpGrad. Today we are diving into one of the most absolute basics of programming in Java, but also one of the most important, that is if-else statements. Now before you scroll away, let me tell you why this is essential. You are going to need this literally everywhere in the programming. We'll start with simplest form of an if statement, and then I'll show you how to use else and even else if to cover more complex situations. We will cover nested if-else and switch statements as well with hands-on examples. Now let me tell you, if you are looking forward to level up your Java skills, check out UpGrad's Masters in Computer Science program. It's the perfect way to advance your career. Check the link in the description to learn more. Now before we begin, make sure to subscribe to the channel and press the bell icon to never miss any update.
So what are conditional statements in Java? Conditional statements in Java allow your program to decide what actions to take, similar to how you make choices in your day-to-day lives. They let the program decide what to do based on a certain conditions or situations. For example, if a specific condition is true, the program will take one path and execute a particular set of instructions. But if that condition isn't true, it can follow a different path and do something else. For example, if it's raining, you might decide to bring an umbrella, but if it's sunny, you might wear sunglasses. Similarly, conditional statements in Java allow your program to make choices based on specific conditions. This makes your program more dynamic and responsive, allowing it to handle different situations effectively. So this was about the conditional statements. Now let's understand the if statement first. So imagine the if statement as a gatekeeper in your program. It checks a condition, and if that condition is true, it lets you run the code inside it. It's called a one-way selection statement because it only goes one way. Either the condition is met and the code executes, or nothing happens at all. So when you use an if statement, you're basically saying, check this condition. If it's true, execute the following code, and if it's not true, just skip it and move on. Now let's have a look at its syntax. So for if condition or the if statement, there is an if keyword and then there is brackets. So inside the brackets, as we can see, there's a condition. So that condition needs to be satisfied, then only the code inside the body, that is the code inside the curly braces, will run. So it's as simple as that. Now as we can see on the screen, here's the first thing, here's the first scenario. Here int x equals to 6. So we have declared a variable x and we have assigned a value 6 to it. And as we can see, we have used if condition. Now the condition is x should be greater than 0. But as we know, we already assigned a value to x which is 6, and we know that 6 is greater than 0. So yeah, this condition is satisfied, and now the block or the body inside the curly braces inside if condition will run. Alright, so this condition is true and code will execute. Now coming to the second scenario. The second scenario, as we can have a look at it, here again we have assigned a value of 6 to x. But here the condition inside the if statement is different. Here x should be less than 0. X should be less than 0, then only the body inside the curly braces will execute, otherwise it will skip that part and execute the body after the if statement. And as we know that x is not less than 0, so this condition is not met, this condition is not satisfied. So it will skip the body of if condition and move to the body that is after the if statement. Alright, it is very simple. Now let's understand this with the help of an example. Alright, so this is our Eclipse IDE. Now here we'll do an example of simple if statement to make you guys understand. Alright, so as you can see,
public class study is there. Now we will do public static void main. So this is the basic syntax. I hope you guys know it. We've already discussed this. Alright, now so here first of all we'll declare a variable, let's say age, and we'll assign a value. Let's say the age is 16. Alright, now here we'll use an if condition, and inside the if statement we'll put a condition. Let's say age should be greater than equal to 18, that a person should be greater than or equal to 18, then only he or she would be eligible. So yeah, so here we'll simply print a message saying you are eligible or not. So we will double quotes. Inside the double quotes, first of all, let's say we want to mention the age. So this age variable, then plus operator, because we want to separate the part where we want to print something and the actual value. So inside the double quotes, we'll use you are eligible. So this message will be printed with the age. Alright. So here what we are doing is basically, if the age of the person is greater than equal to 18, for example, age is 18, 19, 20, 21 like that, then the message would be printed his age and you are eligible. But if the age is less than 18, then it will not print anything. So as we know, we have assigned 16 to age, so it will not print anything. So to let me show you guys, I'll just run this code. I've saved it and now run as first Java application. Again, let's try to run this. I think we have to remove this part. Now let's save it and let's try. Yeah, so as we can see, we have run this program, but it is not showing anything because we haven't printed for the else thing. So this if and else thing, I have discussed now the if part, the else thing we'll discuss the next. But let's say if the value over here is, let's say 20, then what should it print? As you can see, 20, you are eligible. Like if we want to make a difference in between 20 and you, we can use a space in between and save it. So now as we know that the value of age, that is 20, is greater than 18. So that is why this condition is met and this thing is getting printed, that is age and you are eligible is getting printed. But if the value is less than 18, then it will not print in this case. So this is basically a one way, as we already discussed, a one way thing. So if the condition is met, then only it will execute, otherwise it will not. Simple as that. Now let's understand the other part, which is if else statement. So an if else statement works like a decision with two possible outcomes. It first checks if a condition is true, and if it is, the code inside the if block runs. But if the condition is false, the program doesn't just stop. Instead, it moves to the else block and executes the code there. So you can think of it as giving your program two paths to follow. If this is true, do this, but if it is not true, do something else. It's a way to handle two different possibilities in your code, depending on whether the condition is met or not. So the syntax for if else statement is similar to that of one, but here we'll use else block also. So as we can see, syntax is if statement, then there's a condition, then there's curly braces and the body of if statement. After that there is an else block. Else block is for those if the condition is not met, the code will come to the else block. As simple as that. So let's have a look at the first scenario here. We know the value of x is 25. So we have assigned a value 25 to x. We have declared a variable x and the value is 25. But the if condition says x should be greater than 0, which is true for x equals to 25, as we know that 25 is greater than equal to 0. So in this case, the block inside the if statement will run. The body inside the if statement will run in this case. But if the case of, let's say, x equals to minus 25, then what will it happen? I repeat, then what should happen? Let's have a look at it. So here int x equals to 25. The value of x is 25 again, but now the value of x should be less than 0 according to if statement. And we know x is 25, which is not less than 0. In this case, if statement will not execute, but else block will execute. So whatsoever you write in the else block, that particular piece of code will execute instead of the if statement. So this is how if else statement works. Simple as that. Now to understand the if else statement, let's do some examples on them. Alright, we are back on Eclipse. Here we'll do example on if and else. Alright, so let's do one thing. We'll keep the other thing same, and here first we'll use a variable. Let's say the variable name is, let's say, number. Alright, the value of number is 15. We have assigned 15 to the variable number. Alright, now here we'll use if condition. The condition inside if is num mod 2, that is the remainder, should be equal to 0. That is, it should be perfectly divisible by 2, then only the remainder will be 0. Alright, now system.out.println, here again number, that is the variable name, plus operator to separate the part that we want to display is even. I mean, if the if condition is satisfied, then it will print is even after the mentioning the number. Alright, then here is the else block. So in the else block, again we'll write system.out.println. Here again number is there, then plus operator, here is odd. So here what we are doing is basically we have taken a number, we have basically declared a number, the number variable, and assigned a value of 15 to it as of now. But the condition here says the number variable should be perfectly divisible by 2. So basically it should be an even number, then only it should be perfectly divisible by 2. Alright, so as I already said that mod doesn't mean divide, it means it will give you the remainder of it. For example, if we'll divide 17 by 2, 2 8s are 16, so 1 is the remainder. But here the remainder should be 0. Alright, so in case of 15, as we know 15 is not an even number, it is an odd number. So in this case the remainder would be 1, as 2 7s are 14, so in this case the remainder should be 1. So this condition will not follow, but the code will go to the else block. So once the code goes into the else block, it will mention this particular number, that is 15, is odd. Simple as that. Now let's try to run this. We have saved the code. Now let's see. As you can see, 15 is odd, as we already mentioned. Now let's make it 18. Save it and again run it. 18 is even. Now let's say 21. Again save it, run it. 21 is odd. Again let's do it 22. As we know 22 is even, so it will print 22 is even. So this is basically the even odd program that you can do with the help of if else condition. It is very basic, you can try this program. Alright, now this was a basic example to make you guys understand how it works. Now let's do another example. So now we'll do another example in which we will understand one more thing, which is how to take the input basically. So here just we are printing something. Using the logic of if else, we are basically printing whether a number is even or that number is odd. That's it, but we are not taking any input out of it. So let's say I want to take an input, so what should I do? Alright, I want to take an input from the user, so what should I do? For that, first of all, you'll have to include a package which is import java.util scanner. Alright, so basically let me tell you guys what it is. Util.scanner. So this is basically a package which is used when you want to take the input. Alright, so now we'll use the scanner class. So inside this package there's a scanner class. So the scanner class is a part of java.util package. It allows you to take input from various sources. Here we will create a scanner object called s. So the argument system.in that we will write, I'll show you guys while doing. Alright, first of all let me write scanner s equals new scanner. So this is basically the syntax. Now system.in. Alright, before taking the input, system.in. Now we will display a message saying enter the number you want to enter. Alright, system.out.println, and we know how to display a message, so it's pretty easy for you guys also. So it is enter the number. Alright, so this message will be displayed. Alright, once this message is displayed, then we will take the input. Input number equals to s dot next int. So s is the object basically, s dot next int. Alright, so this is where we are taking the input. Now here what we'll do is, so number is a variable and we are storing the number that is entered by the user to the number variable. Okay, now we'll use a condition, if condition basically, if number mod 2, that is the remainder of number, is equal to 0. Double equal to means 0, single equal to means assigning operator. Alright, so the remainder should be 0, which means it should be even. Alright, again that we have done previously, system.out.println. Here we'll write before this number plus operator, then is even. Alright, now we'll go to else. In the else block we'll do the same thing, just copy it and just paste it to save some time, is odd. Alright, I think you guys understand the basics of it, like how we are doing this. If a number is showing 0 as a remainder, it is even, and if it is not, it is odd. Okay, so you don't need to worry about it. If you'll do some examples, you will understand it perfectly. It's not a big deal. But the thing I want you guys to understand here is this scanner class basically. So as I told you that it allows you to take input from various sources. Here we have created the scanner object called S. As you can see, this is the scanner object S. The argument system.in specified that the input will be taken from the keyboard. Alright, the next int method here, as you can see, the next int. So this method is used to read an integer value from the user. Once the user type a number and presses enter, it stores that number into the number variable, this variable. As simple as that. So this is how you can take the input. Alright, so now let's save it first. We have saved it. Now let's try to run this. So as you can see, a message is being displayed, enter the number. So now whichever number we enter, this program will tell us whether it is even or odd. So let's say I'm adding, let's say 16 in this time, and 16 is even, it is telling us. Now again save it and run it. Now we'll write, let's say 657, and we know that 657 is an odd number. 657 is odd, and let's say run again. Now let's write 1298. We know it's an even number, so 1298 is an even number. As simple as that. I hope you guys understood how to take the input from the user. So basically you have to use this import java.util_scanner package. Then inside this package there's a scanner class. It's a part of this package. Then this is the syntax basically, scanner. So here is the name of the object that you want to do, the new scanner system.in. So this is the syntax. Then after this, as we know that we have displayed this message, enter the number, it's up to you whatsoever you want to display. Then here you are actually taking the input. So we have declared a variable named number, and using the help of this object we are basically taking the input, next.int. It is the method that I already discussed with you guys. So this and this is the syntax of taking the input. I hope you guys understood this thing. Alright, so this was about if else statement. Now let's understand the next thing, which is else if statement. Alright, an else if statement comes into play when you want to check multiple conditions, not just one. It's like saying if this first condition is true, do this, but if that's not true, check another condition. This way you can have different actions depending on different scenarios. If the first if condition is false, the program moves on to check the else if condition. If that's true, it runs the corresponding code. If neither condition is true, you can even follow up with an else statement to handle the anything that doesn't match. In short, else if is used to add more choices and handle more possibilities when one condition isn't enough. To make you guys understand, it is very simple. First of all, you can't use condition with else. You have to use if with it. So in this case, as we know, else if is used because we want to put a condition in else block also. So that is why else if we have used. So this is basically used when we have to use multiple choices are there. So that is how we use. So as we can see on the screen, first if condition is there. So the code inside this if block will execute if the condition 1 is true. If this condition is satisfied, that is condition 1 is satisfied, then only this block if block will run. If not, then there is else if condition, which is another condition. So the block inside this one will execute if condition 2 is true. Alright. Then we have another else if. The block inside it will execute if this condition is true. And let's say if neither of the condition is true, then we have this default else, we can say. This will execute if all the conditions are false. Like let's say if none of the conditions are met, then this else block in the end will execute. So yeah, it's pretty simple. You don't have to worry about it. We'll do an example to make you guys understand. Alright. Now let's go back to our code editor. Alright, so we are back at Eclipse IDE. So now let's do an example. Alright, so as we can see, we have to do an example on else if conditions. Alright. So first of all, here we'll start with declaring a variable. Let's say the variable is number, and we have assigned a value to it, which is 75. Now we will use an if condition first. If number is, let's say, greater than 90. Alright. If number is greater than 90, then we will print system.out.println. Here we will print the grade is A. So basically, if this guy has scored number greater than 90, then his grade is A. Alright. Now here we can't use else condition because we have to mention the grade for other ranges of numbers as well, right? So here what we'll do is we'll use an else if statement. So as we already told you that we can't use condition with else, so we'll use else if. Alright. So in else if, here we'll mention number greater than, let's say, 70. Then here we will print system.out.println. The grade is B. Alright. Now there are some other ranges also. So again, else if is there. I hope you guys are understanding why we are using else if, because we have to cover different ranges. So in programming, you will face similar challenges in various, coding thing and programming thing. So you have to have the knowledge of this thing. So let's say the number is greater than, if the number is greater than 50, then what grade it should be? Again, system.out.println. Here the grade would be C. Alright. If the number is greater than 50, then C. If it is greater than 70, then it is B. If greater than 90, it is A. Alright. Now let's say if the number doesn't fall in any of these category, alright, then there is a default, you can say, else condition. Here what will happen is, if none of the conditions are satisfied, then this particular else block will execute. And you guys have noticed we haven't used condition with it because of the obvious reasons we can't use condition with else. So if none of these conditions are met or not satisfied, then this particular block else will run. Alright. So here that automatically means the number is less than 50, which is the grade is D. Alright. So if number is greater than 50, then it is C. Greater than 70, it is B. Greater than 90, it is A. But if it doesn't fall in any of these categories, which means it is less than these, then the grade is D. Alright. As simple as that. So now let's save it and run it. As we know, 75, which falls under the category of B. Now let's change it and let's say make it 92. Alright. Save it. The grade is A. as number is greater than 90, so it is, this particular condition is executed. Now let's say the number is, let's say 45, all right, save it and run it. The grade is D, this else block, because none of the conditions are met. So in this case, this will run, all right. I hope you guys are understanding what I'm conveying. To make you guys understand, let's take 3 scenarios in this case also. All right, so taking the 3 scenarios, so first scenario is there in else if ladder statement condition. So the first condition is if the variable value is 112, that is 112. In this case, as you can see, the first condition is if variable is greater than 0, which is true. So in this case, the if block will run, and if block is already executed, then it will skip all the other statements and it will go to the code after the statements, all right, as simple as that. Condition 2 is there. So now as we can see here, the value of the variable is 10, and the first if condition says if the value of the variable is greater than 10, then in this case this block will execute. But we know the value is not greater than 10, but it is equal to 10. So as we know in else if, we can see variable value should be equal to 10, then only else if block will execute. So in this case, this else if block will execute, and then after executing, it will skip all the other blocks and go to the code after the statements, after the if else statements. All right, taking the example of the third one, which is if condition 1 and condition 2 both is false. Okay, here the value of var variable is minus 10. So if condition says value should be greater than 10, which is not in this case, and else if condition says value should be equal to 10, which is not in this case. So condition 1 and 2 is not satisfied. So the code will skip these 2 statements and go to the default else block that we mentioned. So it will run through the whatever the code inside the else block will be executed, and then it will go to the code after the else if statements. So yeah, this is how else if statement works. I hope you guys understood this thing. All right, now let's understand the another important statement, which is nested if else statements. So in real life, we often make decisions that depend on the results of previous decisions. For example, imagine you're deciding what to do on a weekend based on multiple factors. Let's say the weather, how much free time you have, and whether your friends are available. You might start by checking the weather, and then depending on whether it's sunny or rainy, you will make another decision about what to do next. In programming, this kind of decision making is done using nested if else statement, where one decision or condition leads to another, creating a tree of decisions. Nested if else statements are if else statements that are contained within other if else statements. They allow for more complex decision making processes where multiple conditions need to be evaluated. Alright, as we can see on the screen, there's a syntax. So syntax of nested if else statement. So first, as we can see, condition 1 is there. So if the condition is met, that is condition 1 is met, this particular thing will execute, this particular block will execute, and then it will go to the condition number 2. So now if condition 1 is true, that is it is satisfied, then only it will go to condition number 2. Alright, now the block inside the condition number 2 will execute only if condition 1 and condition 2 are both true. Alright, if both the conditions are true, then only the code inside condition 2 will execute, which is obvious. Alright, now let's say if the condition 2 is not satisfied, then in that case this else block that we can see on the screen, that particular else block will execute. And we also mentioned code to execute if condition 1 is true but condition 2 is false. Alright, so this is the else block for the condition 2 if. Alright, so now as we can see the last else. So the last else block will execute only if condition 1 is also false. I hope you guys understand. So first condition 1 is checked. If that is true, it will go to condition 2. If that is true, then everything is good. But let's say if condition 1 is true but condition 2 is not satisfied. In that case, it will go to the second last else condition. Alright, in that case, that second last else block will execute. But let's say even the first condition, that is first if condition is not true, then simply it will ignore all the if else thing and goes to the last else block, which we have mentioned, code to execute if condition 1 is false. Even if you guys are getting confused, you don't need to get confused. We'll do a simple example on it to make you guys understand this. Alright, so let's go back to our code editor, that is Eclipse. Alright, we are back on Eclipse. Here, let's do the example. Alright, so here we are. Alright, so first of all, we'll do a simple example of it. Let's make it a complex example so that you guys also can understand. So what should we do? Let's do an example in which a person should be allocated a particular, let's say, a loan. Alright, and based on certain conditions, the loan is to be granted. Okay, so let's say the conditions are the annual income should be greater than something, the credit score should be greater than something, the age should be greater than something. So we'll make conditions based on these, and if the conditions are satisfied, then the loan will be granted. Alright, we'll make a simple program of it. So for that, we have to first create some variables, and for each of these things, the conditions that we mentioned, we have to create a variable. We'll start with the first one, which is, let's say, annual income. Let's say the annual income of the current employee, the user, let's say, is 50,000. Okay, and another variable, let's say, credit score. So the credit score of the current person or the user is 750, let's say. Okay, and the age is 25. Okay, now here we will declare a variable named, let's say, is eligible, and the data type of that variable we will keep as boolean so that it should be true or false. Alright, so boolean. So let's name the variable eligible, is eligible. Alright, so let's by default we'll keep it false. Okay, so yeah, now first we'll use here the nested if else thing. So first we will be checking the annual income of that particular user or a person. Then we'll check the credit score and then age. Like that we'll proceed. Okay, so first condition that we'll be using here is annual income. Here, annual income. So let's say we want at least the annual income should be 40k. Alright, so here we are basically checking the income. Alright, now if this condition is true, then there is another condition. There is another eligibility criteria, you can say, that is the credit score. So now if the credit score should be, in this case, should be greater than 700, then only you can proceed. Alright, now again, this is nested if else, you know that. So now again, the third eligibility criteria is to check the age of the person. So age variable, age should be greater than equal to 21, that is 21, and the age should be 21, 22, 23, like that only. Alright, now if all these three conditions are met, then we will basically assign the value true. Alright, so is eligible, I think some mistake is there, just copy paste it. Yeah, so yeah, we will assign true to this value, as we know that previously the default value that we assigned was false. Now if all these three conditions met, that is all these three eligibility criteria is met, then the condition, then here we will assign this true. Okay, so here we have assigned it, then only it is true if these three conditions are met. Now here we'll use an else block also. Like let's say these two conditions are met, that is the annual income is greater than 40k and the credit score is greater than 700, but the person is younger than 21, let's say. So in this case we'll write else block, and this else block is for this if condition, basically this one. All right, so here we'll write the else block. So here we will simply mention you are too young to apply for the loan. Alright. Now this is the else block for the if condition. Alright. Now let's say this else thing is done. Now here we'll use else block for this one also. Alright. First of all, let's create system.out.println. Here we'll write your credit score is less than 700. So let's write your credit score is low, let's say. So this was the case if the annual income is greater than 40,000 but the credit score is less than 700, then in this case this else block will execute. Okay, as simple as that. All right, so we have used else block for this one also. Now coming to the annual income else block, here again we'll write else. Now again system.out.println. Now here we'll write your annual income is low and that is why you can't apply. All right, so we have mentioned all these three things. Now after this we'll use a if statement. Like let's say if all of these things are met, then we'll use if statement. If is eligible, that is if this thing is true, we don't have to make it equal to true, we can simply write like this also, it will also mean the same thing. Okay, so if eligible is true, then what we'll do is we'll print a message saying congratulations, you are eligible for the loan. Okay, congrats, you are eligible for the loan. All right, so this is the message that will display if all the three conditions are met, that is if is eligible is true. If eligible is true, then this condition will print. All right, this statement will print. Now here also we'll use another else block where you say, that means if all these three conditions are not met, then this is the, you can say, a default one, system.out.println. here you can write you are not eligible for the loan. All right, so this is how nested if else things work. Nested if else statements are being used in programming a lot. You need to practice all these examples, then only you will be able to understand. By just seeing the tutorials, it won't help you in that much extent. For you guys, we'll be adding these examples in the description. You can download it with the explanations and then you can practice on your own. All right, so now first let's see if it is working or not. We have saved it and let's see if there are any errors. So as we can see, our annual income is greater than 50,000. Credit score is 750, which is greater than the limit that they have set. Age is 25, which is greater than 21. So in this case, we are basically eligible for the loan. All right. Now let's say if my credit score is, let's say, 600 only, and let's save it and run it. As you can see, your credit score is low. Unfortunately, you are not eligible for the loan. So it will display these messages. So it is displaying this message that we have put in the else condition for the credit score, as you can see, and also along with this message, unfortunately one, this is also being displayed. All right, now let's say our credit score is 750 itself, but our age is, let's say, 20. Okay, now let's run it. As you can see, here also it is running correctly, as you are too young to apply for the loan. Unfortunately, you are not eligible for the. So I hope you guys understood how we use this nested if else conditions to make use of this program and print the desired output. I want you guys to practice on the examples that I've did and any additional examples that you can find on the internet. So yeah, this is how you're gonna do it. Now coming to the next thing, which is Java switch statements. So Java switch statements. So you have probably seen if else statements where the program checks conditions one by one. The main difference with the switch statement is that it can have more than one way to be executed. With if-else, each statement is checked in sequence, one at a time. If the first condition is false, the next one is checked, and so on. The switch statement, on the other hand, jumps directly to the matching case based on the value of the expression. It doesn't need to evaluate each option like an if-else chain. This makes the switch statement faster and more efficient in scenarios where you are dealing with fixed number of options. Instead of multiple evaluations, it directly looks for a match, reducing unnecessary comparisons. But yeah, make sure it is preferable when you're dealing with a fixed number of options. Alright, so to make you guys understand, there's a syntax. So first, as we can see, there's a switch statement. Inside switch, there's an expression. And if that expression matches with the case value, then that particular block will execute. For example, if the expression matches with the case value 2, then the code inside the case value 2, that particular case will execute. And if it matches, the expression matches the case number 3, then that particular case will execute. And let's say if none of the cases matches, then there's a default keyword, as you can see. So the default keyword defines the code to execute when none of the cases matches. As simple as that. Along with this, we'll be using break statement also. So the break statement can be used to exit a loop early. So let's do an example of this one also. Alright. So let's go to the Eclipse. So we are back on Eclipse, and yeah, let's do an example. Alright, so now we'll be doing an example of switch statements. So for that, first of all, we'll declare a variable day and assign a value 3. Alright, so we'll be changing this, so it's not like you have to declare it 3 also, just a random value I've taken. So now here we'll do a program in which we will be mentioning the number of day. Like let's say we'll start with Monday. All right, let's say day 1 is Monday, day 2 is Tuesday, day 3 is Wednesday, like that we'll do. And whatever the value we'll put here, based on that particular day will be displayed. All right, for example, here we have taken 3, so according to the number that we have set, it should be Wednesday, Monday 1, Tuesday 2, Wednesday 3. So it should be like this only. All right, so we'll be doing a program like that. So with the help of switch statement, we'll do this. So int day equals to 3. Now switch statement, and then here we'll mention the day, that is the expression. Now here, all right, now here inside switch statement, there should be the cases. For example, there's a case 1. Inside case 1, we'll write system.out.println, and the day is Monday. We'll be printing this. The day is Monday, all right. And then, as we mentioned, break statement to jump out of the block basically, or loop. Now there is case 2. This means if the value is 2 here, the case 2, case 1 is, it's like that only, right? System.out.println, the day is Tuesday. All right, again here we'll be using break. Now similarly we'll do for other cases also. Just copy it and then we'll change the numbers. Case 2 here, case 3, which is Wednesday, case 4 is Thursday, case 5 is Friday, and case 6 Saturday. Now 6 cases are there, 1 is left, that is the Sunday case. Case 7, the day is Sunday, the happy day. All right, so now along with this, like let's say if a user puts in the value 9 or 10 or 8, anything like that, or the minus value, so in this case what should a program should do? So for this case we'll be using a default value. Okay, so default value, we don't have to put any expression because it's a default value. System.out.println. all right, now here we'll mention invalid number, and then we'll mention please enter the number between 1 and 7. all right, Simple. Please enter the number between 1 and 7. Now after this, again we'll use break to jump out. Alright, so let's do this. I have saved it. Now let's hope it works. The day is Wednesday. Alright, now let's change it to 6 and the day is Saturday. Case number 6 is Saturday. So as we know, this 6 matches with this expression, that is case number 6. So that is why this particular day is being, this particular code is being executed. Alright, it's very simple. And if let's try to put 7, save it, it will display the day is Sunday. Alright, now as we discussed, let's try to put 11. So as we know that there are only 7 days in a week, so we can't put any other number. So by default that we have here, put the message in the default case, which is invalid number, please enter the number between 1 and 7. So yeah, this is how you can make use of switch statements. It's very easy and it is preferable in cases where you knew the number of cases. I hope you guys understood this, and I want you guys to do this example first. Why? Because I want you to do this example by not doing this but taking the input. As we know, you have to use import java.util.scanner package, and then I've already discussed the syntax in the code. Use that syntax and take the input from the user, enter the input, and then based on the input display the output. It is very simple. Just try it and that's it. So, and that's I repeat, and so this is how you can master this switch statements, loops in Java. It is very crucial concept in Java. So I want you guys to really understand and practice these concepts. And that's a wrap on if-else statements in Java. Hopefully you now see how powerful and essential this concept is for making your programs more dynamic and responsive. Whether it's deciding what message to display, what action to take, or how your app reacts to different inputs, if-else is the backbone of smart, flexible code. Now, if you want to practice the examples we used in this tutorial with explanations, and that's a wrap on if-else statements in Java. Hopefully, you now see how powerful and essential this concept is for you for making your programs more dynamic and responsive. Whether it's deciding what message to display, what action to take, or how your app reacts to different inputs, if-else is the backbone of smart, flexible code. Now, let me ask you a quick question. Do you want to take your tech skills to the next level? Our Masters in Computer Science program is perfect for anyone looking to advance their career in development. In this program, you will learn advanced Java concepts, data structures, design and analysis algorithms, front-end and back-end development, system design, and much more. You will gain the knowledge and skills needed to become a leader in your field. Don't miss out. Click the link in the description to start your journey to mastering computer science today. In the next video, we will be exploring loops in Java and various important concepts of Java. So stay tuned. Thanks for watching this video. Keep practicing, keep coding, and I'll see you in the next one. Ever felt like you were stuck in a never-ending loop, repeating the same task over and over again? Well, in the world of programming, loops are here to save the day. They allow you to automate repetitive tasks, making your code more efficient and less tedious. Loops solve this problem by allowing you to define a block of code and a set of rules for how many times it should execute. In this video, we will dive into each type of loop, exploring how they work and when to use them. We will explore for loop, while loop, and do while loop with hands-on examples. So loops in Java. Imagine you have a task to do something multiple times, like printing numbers from 1 to 5. Now, instead of writing system.out.println1, system.out.println2, and so on 5 times, a loop will help you do that in a cleaner and faster way. In programming, a loop is a way to repeat a block of code until a certain condition is no longer true. This is super helpful when you want to perform repetitive tasks without having to manually write out each action. Some of the common types of loops include for loop, while loop, and do while loop. All of these loops are essential for tasks like counting, iterating over collections, etc. So this was about loops in Java. Now let's first start by understanding the for loop. So a for loop in Java is used to repeat a block of code multiple times. It's one of the most common ways to control repetition in programming. The loop lets you decide how many times the code should run, giving you flexibility and control. The for loops works by following three main steps. So the first thing inside the condition of for loop is the initialization. So the initialization is where you set up the starting point of the loop. You define a variable, often called a counter, and assign it an initial value. This step establishes where the loop will begin. The next is condition. So the loop continues to execute as long as specific condition remains true. This condition is checked before each iteration. If the condition is false, the loop stops running. Then there is updation or update. After each iteration, the loop control variable, that is the counter, is updated. This usually involves changing the variable's value to move closer to meeting the condition for the loop to stop. So this update can be incrementing, decrementing, or some other modification of the variable. So this structure allows you to run the loop a set number of times and ensures that the loop stops once the condition is no longer true. A for loop is especially useful when you know ahead of time how many times you need to repeat something. Alright, so as we can see on the screen, so there's a for loop syntax. First there is initialization, condition, and then updation. And inside the for loop there's a block which is to be executed based on the condition. Alright, so to understand the for loop better, let's do a simple example. So let's go to our code editor. Alright, so this is our Eclipse. Here we will be doing an example in which we will calculate the sums from, let's say, 1 to 10. Alright, we'll calculate the sum of numbers from 1 to 10. So first thing first, public static void main. Alright, after this, first of all we will decide to initialize a variable. That variable will be sum. So we have to calculate the sum. So we have initialized the variable sum with 0 as of now. So it's our choice. But for this case, as we have to do the summation of all the numbers, we have to initialize the value as 0 as in the starting. Alright, now we will use a for loop. Now this is the initialization condition, that is int I equals to 0. Here I have used int with I because we haven't initialized I before, so here we can also initialize it. Alright, int I equals to, let's say, 1. So this loop is starting from 1. Then there is the second, that is the condition, as we mentioned earlier. Here I less than equal to 10 because we have to do the sum till 10. So we want to include 10 also, that is why it is less than equal to 10. So the loop will move from 1 to 10. Alright, now the next thing was updation. Alright, so as we mentioned earlier, first is initialization, that is this part. Then there is condition, that is this part. And then there is updation, that is this part. So what this loop will do, this is the basic syntax of it. So initialization part is saying that I will run from 1. Condition is I will run till 10. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how it will move from 1 to 10? Through this incrementing operator. So basically this updation will take place after each repetition or each iteration. Alright, once the loop will go, then another loop will go, then like this it will go on, the complete cycle will repeat 10 times. Now sum is the variable that we declared. Sum equals to sum plus I. Alright, so sum equals to sum plus I. Why we are doing this, I'll let you know. Like the first thing first is we have to add all these numbers to each other. 1 plus 2 plus 3 plus 4 plus 5, like that. So initially the value of sum is 0. So here it is 0. Now first 1 will come, as 1 is less than 10. So 1 plus 0, 1 will be stored here. Then 2 will come, 1 plus 2, then the sum will be stored here, like that. So it will keep on repeating and the total sum will be stored in this sum. I'll let you guys understand in further explanation also. So let's do this first. As we can see, after the complete summation thing will happen, the sum is happened, then what we'll have to do is outside this loop. So You guys have noticed the loop is from here to here, right? Outside this loop, we'll have to print ln. Here we will print sum, but before that we have to use string also. Sum is, let's say, now we will use the plus operator and some variable. All right, now it will print the total sum. All right, now let's save it and try to run this. Sum is 55. So now if you'll calculate the sum from 1 to 10, that is 1 plus 2 plus 3 plus 4 plus 5 like that, the total sum would be 55, which is correct. Now let me tell you, if some of you guys have not understand it how it is working, then let me tell you. First of all, this, as we can see, this sum equals to 0. This line sets up a variable called sum and start it at 0. This variable will be used to keep the track of the total as we add numbers together. Okay. Now then comes the for loop. As we can see, this is the for loop. This is the basic syntax of it we discussed earlier. So the for loop, first I is starting from 1. This is the initialization. This part is initialization. Then it checks if it's reached 10 yet or not. So as we know, 1 is less than 10. So it is not reached 10 yet. So yeah, we can go forward like that. If it hasn't reached 10 yet, it continues. So this is the condition part. All right. It will keep on going. This loop will keep on going until it matches with 10. After 10, let this 11, it will not print that. All right. So this is the basically condition part. Then after checking the condition, the I counts up to the next number. This is the incrementing thing. So this is what moving the thing basically. So I will count up to the next number. So if it is at, let's say 1, it goes to 2. This is the updation part basically. Incrementing part or the updation parts. Not necessary, we can also use decrementation operator also, but we are not using it. This is basically, if we'll have to say, this is the updation part. All right. So after checking, the I counts to the next number. So this is the updation part, as I told you. While I is counting, it's also adding each number to a total. As we know, this is adding each number to a total. Here I is 1, then I will come 2, 3, 4, 5. It is basically adding each number to the total sum. So this is what sum equals to sum plus I is doing. So the sum equals to sum plus I means it's like adding each number to a bucket. I keeps doing this until it reaches 10. Then it stops because it's finished counting. After the loop has finished running, when I is no longer less than or equal to 10, this line will print out the final value of sum, showing the total sum of the numbers from 1 to 10. All right, this is that simple. So as we know that initially the value of sum was 0, then here the loop runs, the value of I is 1. So 0 plus 1 equals to 1. So the value now of sum is 1. Then the loop will run again for 2. Now 2 is there, so 1 is there. 1 plus 2 equals to 3. It will add up to that. Then 3 will come. Now this is 3 and this is 3. 3 plus 3 is 6. Like that it will come to there. So this is basically the working of it. Alright. So this is the first example of for loop. Alright. This is pretty basic example. You have to try this example also. Then only you'll be able to go for the intermediate examples. You'll have to do at least 5 to 6 examples of basic one. Then you can try for the bit advanced examples, if I can say. All right, now let's do a bit complex example than this one, which is Fibonacci series. All right, I hope you guys know what is Fibonacci series. It's like the number is the sum of the preceding two numbers. Like, let's say if I have a number, like let's say 5, it will be the sum of the previous two numbers, that is 2 plus 3. So the sequence is 2, 3, 5 like that. Normally the Fibonacci series starts from 0, 0, 1, 2, 5 like that, it moves on. So if you guys know about it, I hope you guys know about it. If you guys didn't know about it, so you can just Google it and then you'll get to know. It is often asked in interviews, and while cracking for interviews, this Fibonacci series and other examples like factorial thing is being asked repeatedly. So I think you guys have to know this Fibonacci series. So now let's do an example of Fibonacci series. Alright, so let's remove this again. Yeah, we'll start again. We'll type public static void main. It's a good practice. You can write again and again. String arguments. Alright, now inside it, first of all, here we want to print at least 10 Fibonacci series numbers. Alright, so by the time I think that you guys have understood what is Fibonacci series. If you haven't understood, just Google it Fibonacci series and it will give you the Fibonacci series. You guys will understand the number is each number of the Fibonacci series should be the summation of the previous two numbers. That's it. That is the proper definition of it. Alright. So this way the whole series is there. So we are going to print that series for the first 10 numbers. Okay. Alright. So first of all, we have to declare two variables. Let's say fib1 and 2. In this case, we have to declare the variable as fib1 and fib2 because the Fibonacci series usually starts from 0 and 1. Okay. So the first two numbers we have to assume, that is 0 and 1. And it should be 0 and 1 itself. No other number should be there. Fibonacci numbers, first two numbers is 0 and 1. Okay. Now, the thing is, here we again have to use the for loop. So this is what we are doing with the for loop. We'll start from 0, int I equals to 0. Alright, int I equals to 0. This is the initialization part. Then I less than 10. This is the condition part. I plus plus, this is the updation part. So here what we are saying to the for loop. So we are starting the for loop from I equals to 0. Then I should be less than 10. So the loop will keep on iterating till I is less than 10. That is I equals to 9. Now I plus plus. After each iteration, a number will be increased. Alright. So this is the updation part where we are incrementing it. Alright. Now let's print first of all system.out.println. Here we want to print fib1, that is the variable name. Then let's keep a space after this. All right. So this is you'll get to know why we are doing this, to add some space in between. So yeah. Now let me do the summation of two numbers and then storing it to the temporary variable. Let me do this and then I'll let you guys understand what I'm doing. Int temporary variable, and we are storing fib1 plus fib2, the summation of fib1 and fib2. Fib1 equals to fib2, we are assigning it. Then we are back assigning the value of temp to the fib2. I hope you guys are understanding what I'm doing. But for those people who are not understanding yet, do not worry, we'll make you understand. Alright. Alright, so let me start with the first thing. So this example basically calculates the first 10 Fibonacci numbers. So fib1 and fib2 are initialized to 0 and 1 respectively, and the loop will run 10 times as I is less than 10, as we already mentioned. Alright. In each iteration, the current value of fib1 is printed. Okay. So here we are printing fib1. In each iteration, the current value of fib1 is printed. Then we calculate the next Fibonacci number by adding fib1 and fib2. Alright. So this result is stored in a temporary variable that we mentioned, temp. Fib1 is updated to the value of fib2, moving to the next number, and fib2 is updated to the temporary variable. So this is pretty simple. Fib1 and fib2 are two variables. Their sum is getting assigned to temp variable. Now the value of fib2 is assigned to fib1. Alright. Now fib2 becomes empty. Now the summation of these both, we are assigning it to fib2 again. Why we are doing this? Because this is the way to, write the complete sequence of Fibonacci series. Again, fib1 is updated to the value of fib2, moving to the next number, and fib2 is updated to the temporary variable, the new Fibonacci number. First, it will print fib1 equals to 0, then fib1 becomes 1 and fib2 becomes 1, since 0 plus 1 equals to 1. Alright. Next, it prints fib1 equals to 1, then fib1 becomes 1 and fib2 becomes 2, that is 1 plus 1, 2. This process continues until we print the first 10 Fibonacci numbers. Alright, that is 0 plus 1, that is 1, then 1 plus 1, that is 2, then 2 plus 1 equals to 3, then 3 plus 2 equals to 5, then 5 plus 3 equals to 8. So this is the Fibonacci series. So we are basically adding the previous two numbers, and the addition, the sum of those two previous two numbers, we are printing it to the third number. Like that we are moving. Alright. I hope you guys understand. If you want to understand it better, you can go through this example again and try this example on your own. Then only you will be able to, particularly grab what I am telling you right now. And this is how you practice actually. Alright. So give it a shot. Try the Fibonacci number. Don't underestimate yourself. Give it a shot. You can do that. Alright. Next is while loop that we have to understand. So let's understand while loop. While loops. So while loop is just another way to repeat a block of code multiple times. But instead of running a set number of times like in a for loop, it keeps running as long as a condition is true. Think of it as giving the computer a rule to follow. Keep doing this task as long as the condition is met. So the loop keeps checking the condition over and over, and if the condition is still true, the computer runs the instructions again. If the condition becomes false, the loop stops and the computer moves on to the next part of the program. So this was about the while loop, and now let's understand its syntax. So as you can see on the screen, while and then there is a condition. So there is no updation, no condition, no initial phase. But yeah, while loop is a bit different from for loop. So the condition inside the parenthesis first is evaluated. Then if the test expression or condition is true, the code inside the body of the loop is executed. After executing the code, the condition is evaluated again. So the loop will keep running as long as the condition or test expression is true. So when the test expression or condition becomes false, the loop stops and the program moves on to the next part of the code after the loop. It is as simple as that. Alright. So this condition should be true, then only the loop will keep on running. Alright. Now to understand this while loop better, let's do some examples. Alright, let's get back to the Eclipse. Alright, so we are back on Eclipse. Now let's do an example of while loop. Again, public static void main string arguments. So here we have initialized a variable and assigned it a value of 1. So this is a counter variable basically. So in this example, what we are doing is, here the loop will run 5 times, printing the value of count each time. Alright, so this is what this simple example will do. Now let's write a while loop in which count is less than equal to 5, because we want to run it 5 times, so that is why less than equal to 5. So 5 is included basically. Alright, now here this is the part which is inside the loop. Here we want to print it system.out.println. Here inside we are printing it because we want to repeat it 5 times. We want to print something 5 times. Alright, if we have to do the sum, then we'll print it outside, but here we want it to print 5 times. That is why we are printing it inside of the loop. Alright, so don't get confused. Now count is, here we'll use plus operator and count variable. Alright, so here we are printing it, and then the updation, that is the increment thing, count plus plus, because we want the loop to keep on running, right? So we'll have to use count plus plus, that is the increment operator. So this is basically the counter. We have initialized it with 1. So the loop says it will keep on running till the value of count is less than equal to 5. So loop will run for 1, 2, 3, 4 and 5, that's it. If it becomes 6, then it will not run because the condition is not met. Alright, and how it is moving forward with the help of this count plus plus. So basically, if you want to see, this is the initialization part, this is the updation part, and the condition is here. So yeah, it is a bit different from for loop, but it is also used for different purposes. Yeah, there are some times where you can use for loop and while loop also, but it depends at your convenience. Alright, so this is the updation part as we already discussed. Now for those who haven't understand, this is the counter variable. The loop will run till count is less than equal to 5. So the while loop will continue executing as long as the value of count is less than or equal to 5. So system.out.println, we know that it is used for printing it, and count is count like we wrote here. So this will print the current value of count to the console. So first 1 is there, so it will print 1, then 2 is there, it will print 2, like that. Alright. So this will print the current value of count to the console each time the loop will run. Alright. So the count plus plus is the use for after printing the value of count, it is incremented by 1. Alright. So it works like that. And the loop will terminate when count reaches 6, that is greater than 5. Alright. As the condition count less than equal to 5 will no longer be true, then the loop will break. Okay. So yeah, now I hope you guys understood it. Let's save it and try to run this. As you can see, count is 1, count is 2, count is 3, count is 4, count is 5. So this is a basic example of while loop. As you are starting with while loop, you can try this one. Now let's do a bit more complex example of while loop, in which we will do, basically we will do an example in which we'll continuously accept numbers from the users and we will add them together, and we'll keep a button for the adding thing. So the loop will run until the user enters 0 number. So let's say I'm entering 5, 6, 7, 1, 2, like that, and if I want to add all of these, I'll just click on 0 and then it will give us the sum of all the numbers that we have typed before. Alright, so let's do this example. Alright, so in this example we'll be using the while loop again, so that you guys can understand. Other than that, we'll be taking an input, as I mentioned, we'll be putting an input again and again, and then we'll do the sum. So we want to take the input. So as we know that we have to use import java.util.scanner class. This is the package that we have to include. Then we have to create a scanner object to get the user input. For that, what we'll do is scanner and scanner. So this object, you can name it as your wish, but the other syntax would remain the same. Alright, system.in. Alright, now we will initialize the sum with 0, initial int integer sum equals to 0. Now declare another variable, let's say number. Now we'll have to start the while loop. To start the while loop, we'll keep the value as true as the boolean value and ask the user to enter a number, okay, inside the while loop, because we want to, I repeat, because we want it to keep on running. Alright, so true, we want it to keep running. Now we'll ask the user to enter a number inside the loop, okay, system.out.println, here enter a number. Okay, now here we'll display another message, or enter 0 to stop it. Okay, alright, so yeah, this is it. Now after this while loop, I mean outside this while loop, not outside, inside this while loop only, we'll have to take the input also, right? So here inside this only, we forgot to take the input. Now the number variable that we declared, we'll make use of it, and scanner dot next int. So this is how you take the input, as we already discussed in the previous lectures. So this is how you take the input using this scanner class and all. Alright, so there's a link if you want to refresh that thing. There's a link in below this video if you want to go and check that part in the previous video. Alright, now I want to read the user input. So this is how I will read the user input, and if the user inputs enter 0, so for that we have to use the if condition. If number is equal to 0, so double equal to is for equal to operator, single equal to is for assignment operator, keep in mind that. Okay, so now if number equals to 0, then we will break it. So this break thing is, will jump out, basically we'll jump out of it. We'll be covering break and continue statements in the coming lectures. So right now, just understand, to coming out of this loop, we'll use break if number is 0. Alright, now we will write add the number to sum. We basically want to keep adding the numbers that a user is entering. Okay, for that we use the same thing that we did previously, sum equals to sum plus number. So each of the number that user is entering will add up to it. So here we know that some initial value is 0. So here it is 0. Now let's say user entered 1. So 0 plus 1, then 1 is stored in this. So now sum becomes 1, alright. Then again user will enter 3. So 1 plus 3, 4. Now sum becomes 4. Now let's say user enters 5. Then 5 plus 4, that is 9. Now sum becomes 9. So this is the theory behind it. So this is how we are adding the numbers to the sum basically. Alright, because we have to display the output also, so that is why we are doing it. Alright. Now coming to the printing part. System.out.println. Here we'll first of all we'll write the total sum is plus operator sum, that is the variable name. Alright. Alright, so yeah, I think this is what it is. This is pretty much about it. Now let's save it. I hope there are no errors, and else everything is fine. First let's try and then explain to you guys. Alright, so enter a number or enter 0 to stop it. Alright, so we'll start with, let's say 5, then 7, 8, 2, 9, 7, 6, 5 and 4. And now if I want to stop it and I want to display the result also, the sum of all these numbers, then I'll click on 0 and enter it. So the total sum is 47. So you guys can also calculate if you want to make sure it is doing correct or not. But I believe it is correct, and if we'll do the summation of all these numbers, it will come out to 47. Alright, so the code is working correct, right? Now for the guys who haven't understand this thing, so the thing is I'll let you guys understand. So first of all, this is the scanner object. So we use the scanner class to take the input from the user. Alright. Now here, as we can see, we have declared the two variables and we have initialized sum with 0. Alright. So we want to take the input also, so we declared another variable number. Alright. We are storing the value which user is entering to number. Now the part is here, this is the while loop. So we have used this. So this is what we call as infinite loop or infinite while loop. So we have made the value of while as true. So it will keep on, looping, keep on going. So this loop runs indefinitely until the user enters 0. Alright, because we have used if condition to stop it. Alright, so this loop will keep on going repeatedly until the user enter a 0. Alright, which triggers the break statement over here. Alright, as simple as that. Now user input, as we can see, the user input here we are taking. So inside the loop, the program repeatedly asks the user to enter a number. Alright, now if number becomes 0, if number is 0, let's say user enters 0, then it will break. And when the user enters 0, the loop breaks and the program stops asking for the input. That's it. That's what we made sure with this if condition. Okay. Now if the user enters other numbers, that is summing the numbers. If the user enters any number other than 0, it is added to the sum, all thanks to this. Now printing the result. So after the loop ends, the total sum is printed. So as we can see, we want to print the sum. That is why we are printing it outside the loop. So this is the while loop. We are printing it outside because we want to print the result or the sum. We don't want to print it 5 times. We want to print the sum. Alright. So that is why outside the loop. So the total sum is getting printed like this. So this again is not a very difficult examples. You can try this example. It will help you understand the concept of taking the input from the user also and using the while loop, especially the infinite loop. Alright. So this was about while loop. Now let's move forward and understand the another important concept, which is a do while loop. Alright. Alright, so a do while loop in Java is a type of loop that ensures the code inside it runs at least once. Regardless of condition, the key difference between a do while loop and a while loop is the order in which they check the condition. So there's the condition. This is the syntax basically. So first there is a do, then there is a while, and text expression means condition. So you guys don't need to get confused about that. Don't worry about that. Text expression means the condition itself. So now First, the code inside the loop is executed. It doesn't matter if the condition is true or false. The code will always run at least once because we have used do. So whatever is inside the do block, it will run. It is not checking any condition. So it doesn't matter if the condition is true or false. The code will always run at least once. Alright. Next, after the code has been executed once, the condition is checked. All thanks to while loop. So after the code has been executed, the condition is checked. This condition is a test to see if the loop should run again or not. If the condition is true, the loop repeats, meaning the code inside the loop will run again. If the condition is false, the loop stops and the program moves to the next part of the code after the loop. Alright, so here do specifies that at least once the program will run, and after that the while will check whether the second time will it run or not. So this condition, that is the test expression, will be applied to the second time. Alright, so in simple terms, a do while loop says first do this task, then check if the condition is met. This structure is particularly useful when you need to perform an action at least once, regardless of whether a condition is met or not. Alright, so this is the main thing behind it. It is also used selectively in the programs. Now let's do an example. Alright, let's get back to Eclipse. Alright, so we are back on Eclipse. Now let's remove this part. Again, let's do an example of do while loop. So in this example, we will do a program which will print hello world 5 times. But with the help of do while loop, we'll do that. We'll not simply print hello world, alright. With the help of do while loop, we'll print 5 times hello world, alright. So let's start. First of all, declaring and initializing the variable int I equals to 1. Let it be like this only, yeah. Now we will use the do while loop. So first there is do, and inside it we'll basically print something. So what we want to print is hello world, okay. System.out.println hello world, alright. So this is the do block. After this we have to do the increment, that is the updation part. So here only we are doing the increment thing, alright. So I becomes 2 now. I is initially 1, I plus plus, I becomes 2 now, alright. Update expression basically it is. Now here we'll use the while, okay. So I less than 6, or we can use it like this also, as there is syntax for it. I less than 6, alright. I less than 6, and that's it. So this is the syntax. So first hello world is printed, and then there is an increment, then again it will print. So for 5 times it will print at least. Then at 6th time it will check I should be less than 6. So then it will stop, because then there's a condition. It will not print, okay. So the first time is the independence, but for the other times, for the 4 next times, it is also the condition is being met, so it will print total 5 times. Alright, so yeah, let's save it first, and now let's try to run this. Hello world 1 2 3 4 5. 5 times it is getting printed. I hope you guys understood the thing behind this do and while loop. So if somebody haven't, I repeat, if somebody doesn't get what I'm telling right now, so the thing is, this statement prints hello world to the console basically. This will happen every time the loop will run. So system.out.println hello world. So this line basically prints hello world to the console each time the loop will run. After printing the counter variable I, that is incremented by 1, that is the update expression. After the body of loop runs, the condition while I less than 6 is evaluated. If I less than 6, the loop repeats, otherwise it stops. In this case, the loop will continue to run as long as I is less than 6. The loop stops when I reaches 6 because the condition I less than 6 becomes false. So this is how it works. So the examples that I just did now, you can also try these examples. That will help you, alright? So we have covered the essentials of how loops work, from automating repetitive tasks with the for loop to handling dynamic conditions with the while and do while loops. By mastering these loops, you will be able to write more efficient and streamlined code, making your programming projects much smoother. Also, if you are interested in mastering Java, you can join a free masterclass. The link to register is provided in the description below. If you found this video helpful, don't forget to like, subscribe and hit the notification bell so you don't miss out on future content. Hey everyone, welcome back to another video by UpGrad. Today we are diving into something really important. Something that not only helps you make your code more efficient, but also comes up in a lot of technical interviews. The break and continue statements. If you have ever found yourself in an interview, especially Java interview, chances are you have been asked something like, how would you stop a loop early? Or how can you skip a specific iterations in a loop? Well, these questions are all about break and continue. In this video, we will learn how to get out of loops or skip it using break and continue statements. So what is a break statement? Imagine you are in a loop. A loop is like a train that keeps going through its stations until it reaches the end. Sometimes, though you might not want the train to visit every station, you might want it to stop early, maybe because you're already found that you're looking for. That's where the break statement comes in. The break statement allows you to exit or break out of a loop before it naturally finishes its run. Think of it as a way to tell the loop, hey, I'm done, no need to keep going. It stops the loop immediately, no matter where you are inside it. So basically, it is used in programming to immediately exit a loop regardless of its current situation. Now, let's understand with the help of an example. Here, we will do an example that runs from 1 to 20, but we want to stop the loop as soon as we reach the number 11. So, let's get back to Eclipse. Alright, so this is our Eclipse IDE. So, here we will be doing an example. So, here we'll do an example in which a program runs a loop from 1 to 10, but exits, or you can say breaks the loop early when I reaches 5. Alright. So let's do this example so that you guys can also understand it better. Alright, so first of all, there's a for loop that we have to use and initialize it with 0. Then I should be, let's say, less than equal to 10, then I plus plus. Alright, now inside this for loop, we'll have to use if condition. That is, if I equal to 5, then we will print something, okay? If I, then we will print system.out.println. So here we will print breaking the loop at I equals to, basically we will show breaking the loop at this point, that is the 5th point. Alright, so this is what we want to print. Breaking the loop at I equals to, here we'll write plus operator and I variable. That's it. Now here we'll use break because we want to exit the loop when I equals to 5, right? So we'll use break. So this is where break is used when you actually want to exit a loop. Alright, so using break we will exit the loop at 5, at I equals to 5. Then after this, as we know that after the loop we will be printing system.out.println, then the value of I. I think we'll have to print it inside it because we have to print multiple things. So we wanted to keep that thing printing on, so we have to keep it inside the loop. System.out.println. Now here we'll write current value of I. We forgot to put this in double quotes. Alright, so now it's in double quotes here plus I. Let's add some gap here. Alright, so yeah, this will show the current value. So those here again, so this is the loop basically, and what we are doing is the loop starts from I equals to 1, as we know that here we'll have to mention 1 instead of 0. So the loop is starting from I equals to 1 and will loop, I repeat, and let's run it to 20, okay, and let's stop it at, let's say, 11. Alright, just make it long. Alright, so the loop starts from I equals to 1 and runs up to I equals to 20 as we are witnessing it. And when I becomes 11, as we can see, if I becomes 11, then the condition will be true, right? So the break statement is executed at this point. Alright, so we have used this break keyword. So at this point, the break statement is executed. As soon as break is encountered, the loop is terminated. Alright, and the control moves to the code outside the loop. So the control moves to the outside the loop. Alright, now let's do this. Let's save it first and now run it. I think there is some error, that is why it is showing this. Yeah, the main error is we haven't used the public static void main. Alright, public static void main string public static. Yeah, now let's save it and let's try to run this. It was a basic example, I hope you guys understood it. So as we can see, current value of I is 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10. It is breaking the loop at 20, at 11 when it is supposed to be going till 20, right? But as we know that the loop runs till it becomes 20, I becomes 20, right? But here, all thanks to break statement, the loop is terminated with the help of break statement at 11, because here we have put this condition: if I becomes 11, then print this thing breaking the loop at this particular point and just break it. So it is printing breaking the loop at I equals to 11 because we have used break, and this is I equals to 11, that is I equals to 11. So this is what break statement does to a program or a loop. Alright, so this example is for you guys to understand it better. If you want to terminate the particular loop, then it is used. Okay, now let's take an example with a while loop. So in this case, the loop continues to run until a certain condition is met, and we will use the break statement to stop it. Okay, so let's use the while loop in the following example. All right, so let's remove this part. All right, now here let's initialize, as we are using while loop, so we'll have to initialize I equals to 1. We are initializing it, then while I is less than equal to 10, let's say, till I is less than equal to 10, then again we will use another condition inside, I equals to 7. Now I equals to 7, here we want to put a continue or a break statement, not continue but the break statement. Okay, again here we will print system.out.println. Here we'll print breaking the loop at I, like we did previously. Okay, breaking the loop at I plus I. All right, so we'll show that this is the point where we are breaking it. Okay, so that is why we are doing it. You don't need to necessarily do that. So break keyword, so this particular keyword, as we did previously, this will exit the loop when I equals to 7, I becomes equals to 7. So I will be, initially the value of I is 1, then condition is here. Now to run the loop, we'll have to use the increment operator also, because we want the loop to keep on going, right? So we'll be using increment operator also. So before that, we'll be printing the current value. Okay, so for current value, system.out.println, here double quotes, current value of I, okay, plus I plus plus. All right, so this is it. So this is the updation part of this, basically the while loop. So if we'll talk about, this is the initialization, this is the condition, and this is the updation. Now it will check if I becomes equal to 7. If it becomes equal to 7, it will break at that point, although we want it to run till 10. Okay, let's save it and run it. As you can see on the screen, let me just do this. Yeah, current value 1, 2, 3, 4, 5, 6, 7, and breaking the loop at I equals to 7. By mistake we wrote loop is instead of loop, but I ignored that thing. But breaking the loop at I equals to 7, as we discussed earlier. All right, so this is what you can do with the help of break. You can use it in for, while, and many other programs you will be able to use it. So this is for basically the explanation part. So I hope you guys understood, when I becomes equals to 7, the if condition becomes true and the break statement is executed, the loop is immediately stopped and the control will jump to the code following the loop. Okay, so this is how it goes. All right, so this was about the break statement. Now that we have understood the break statement and the working of it with hands-on example, now let's understand the continue statement. So now let's talk about the continue statement. Imagine you're working with loops like a for loop or a while loop, and you want to skip a certain iterations without completely stopping the loop. That's where the continue statement comes in handy. Think of continue as saying, hey, just skip this part and move on to the next round. Unlike the break statement, which completely stops the loop, continue just tells the loop to skip the current iteration and go directly to the next one. So basically, the continue statement in Java is a control flow statement that causes the loop to skip the rest of the code in the current iteration and immediately proceed to the next iteration. Let's say we want to print numbers from 1 to 10, but we want to skip all even numbers. So we can use continue to achieve this. I repeat. So we can use continue to achieve this by skipping any iteration where the number is even. We just don't have to stop it like the previous break statement. Alright. So this is the difference between these two basically. We'll be discussing it further, but as of now, I want you guys to understand this thing. Alright. Now let's do an example in Eclipse. Alright, so we are back on Eclipse. Now let's remove this thing. Okay, so let's do an example of continue statement. So here we will be doing an example in which the program will run a while loop that increments the variable from I1, then it prints the current value of I until I reaches 7. At that point, the loop breaks and the program stops further execution. So in this example, we'll run the loop from I equals to 1 to 10, but at 7, when in this program we are basically use the continue statement where we'll be skipping the parts of even numbers. We'll be printing from 1 to 10 and we'll skip the even numbers between them. Alright, as simple as that. So we'll start with first of all the for loop. Let's start with the for loop. Int I equals to 1, I less than equals to 10, I plus plus. Now inside the for loop we'll use if, and then there's the condition I mod 2. So whenever we want to check whether a number is even or odd, basically mod is used because it gives us the remainder of thing. If a particular value is odd, then it will give you 1 as the remainder, otherwise it will completely be divisible by it and give you 0. So even numbers will give 0 as an output if that particular number is divided or mod by 2, not divided but mod by 2. So it is basically used to check that equal to 0. So that means if a particular I number is mod, that is the remainder of these two things, is 0, then it means it is even number. Alright. So now here we'll do continue keyword. Alright. So this particular thing will skip the iteration if the number is even. So basically here what we are saying is if I mod 2 equals to 0, that means if a number is even, then skip that particular number. Alright. Now we will print system.out.println and here we'll print I basically. So we are printing the odd numbers, that's it. Alright, from 1 to 10 we are printing the odd numbers. Alright, now let's save it and let's try to run this. Alright, 1, 3, 5, 7, 9. As you can see, it is printing the numbers. Let's make it 50. Save it and run it. So we can check all the numbers are odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. So what continue statement does is it doesn't stop it, but it skips that part. Alright, so this is the difference between both of these. It's very simple. The loop the loop is iterating through numbers from 1 to 10. When the number is even, that is I mod 2 equals to 0, the continue statement is executed, skipping the even parts and only displays the odd numbers. Alright. So now let's do an example using a while loop that behaves similarly. We'll loop through the numbers from 1 to 10 and skip the numbers that are divisible by 3. Okay. So yeah, let's do this. So here we'll be using the while loop from 1 to 10 and we will skip the numbers that are divisible by 3. Now we'll start with int I equals to 1 because we have to initialize as we are using the while loop. I less than equal to 10. Now inside the while loop we'll use the condition if I mod 3, that is if a number is divided by 3 and give you 0 as a remainder, then it means it is divisible by 3. As simple as that. I plus plus. So here we are incrementing. So don't forget to increment I or it will cause an infinite loop. Okay, here. So now here semicolon we'll have to use. Now here we will use a continue statement. So here again, it will skip the iteration if the number is divisible by 3. Okay, we want to skip those numbers. Then system.out.println, here we'll print I. Alright, so now after this I plus plus. So this is the increment of I after printing the number basically. So after each increment it will be like this only. So it is basically no different than the previous one, but all it is doing is it is skipping the numbers which is divisible by 3. That is perfectly divisible by 3. That is, it will give you 0 as a remainder. So yeah, it is the difference. Now let's save it. I think one bracket is missing. Yeah. Now save it and let's try to run this. So as you can see, let's keep it like this only. Alright, so the output is like this now. 1, 2, 4, 5, 7, 8, 10. None of these numbers are perfectly divisible by 3. And we have used the while loop till 10, so that is why it is printing this thing. If we'll keep it 40, let's say, and save it and then again run it, it will give us this many number. And all of these numbers are not divisible by 3. Alright. So this is another example of while loop. I hope you guys understand it. Yeah. So now let's do an example in which we are using both break and continue statements. Alright. So let me try to shift this back. Alright. So I think, alright. So this was about continue. Now let's do an example in which we are using both break and continue statements together. Alright. So let's do this. Let's remove this also. Alright. Now here we'll do a program that performs a countdown from 10 to 1, skipping the numbers 5 using the continue statement. And it will stop the countdown entirely when the number reaches 3 with the help of break statement. We'll do that. Alright. So it will skip 5 and it will stop when the number becomes 3. Alright. That's it. So let's do this example. We'll start with the main function, public static void main string arguments. Alright, now inside this we will use a for loop first. So inside this for loop, which is starting from 10 and it will go till 1. Alright, so previously we are using the for loops that were incrementing from 0 or 1 to 10, but now we'll use a for loop which is decrementing basically from 10 to 0 or 1. Alright, so let me show you how to do that. Int I equals to 10, I greater than 0, I minus minus, that is the decrement. So here what we are doing is we are starting the I from 10, that is initial value is 10, and this loop will keep on running till I is greater than 0. Alright, and then we have used the updation, which is the decrement operator. So after every cycle it will become 1 less, like let's say 10, then it will be 9, 8, 7, 6, 5. Till it is greater than 0, this loop will keep on running. That is till 1 it will run. Alright. So it is pretty simple, just the opposite you'll have to do. That's it. Alright, now inside this loop, we'll use if condition, that is if I is equal to 5. Then in this case, we'll print skipping the number. Alright, here we have wrote skipping the number, and then we'll write continue. Alright, now after this we'll have to use if statement. If I equals to 3, that is, now we have to use the break statement also. So we are using I equal to 3. Now inside this if condition, we'll be stopping the loop at I equals to 3. Alright, so for that we'll first print system.out.println. Now we'll write stopping countdown at number 3. Alright, it will display that number. Alright, now after this we'll have to use break, which will do the work actually, which will exactly stop the loop at number 3. Now after this, I mean inside the loop, we'll have to print something, system.out.println. So here we'll print countdown, and let's put this thing in double quotes basically, and plus I, it is used for printing. So here is the actual printing taking place. All right. So now let me explain you guys. The loop counts down from 10 to 1. Then the continue is used to skip the number 5. When the loop reaches 5, the message skipping number 5 is printed, but the loop skips the remaining code in that iteration and moves to the next number. Now break is used to stop the loop when countdown reaches 3. When it reaches 3, the message stopping countdown at number 3 is printed and the loop is terminated. So the numbers 2 and 1 are not processed and the numbers 2 and 1 will not get printed. Alright, let's save this and run this. Alright, now as you can see 10, 9, 8, 7, 6, skipping the number 5, 4 and it will stop at 3. So 2 and 1 are not getting printed. So it is working exactly as we predicted. So this is how you can use continue and break. I hope you guys understood their functionalities. But let's just again recall what is the difference between break and continue. Alright. So the break statement, first function is the break statement completely exits a loop. When it is executed, the control is transferred to the first line of code outside the loop, terminating the loop immediately. Whereas in the continue statement skips the current iteration of loop and jumps to the next iteration, allowing the loop to keep running. Alright. Now talking about the break statement, you use break when you want to stop the entire loop because continuing with further iterations is no longer necessary. And continue statement, you can use continue statement when you want to skip certain iterations based on a condition but still want the loop to continue processing other iterations. Then there's talking about the effect on loops. So the break statement ends the loop entirely, no further iterations occur. But in case of continue statements, it skips the rest of the current iteration and goes to the next one without stopping the loop. So yeah, these are the main differences between these two. Both of these are very easy to use as only the keyword break and continue is used. So it is very easy to understand and use. Alright, now let's understand when to use break and continue. So you want to exit the entire loop or switch statement prematurely, then you will use the break statement. And another thing is you have found the desired result and don't want to continue iterating, then you use the break statement. And the third thing is you encounter an error or exceptional condition that makes it impossible to continue, then you would use the break statement. Now let's discuss when to use continue statements. So continue statement is used when you want to skip the remaining part of the current iteration and proceed to the next iteration. And it is used when you need to avoid certain calculations or actions for specific conditions. And then it is used if you want to optimize the loop's performance by skipping unnecessary work. Alright, so these were the reasons when break and continue statements are used. You can try the examples that we have covered and then you can practice all these examples and then you'll be able to understand it better. So we have covered how these break and continue statements can give you more control over your loops. Remember, these concepts don't just make your code cleaner, they are also common in technical interviews. So mastering them is a great way to sharpen your problem solving skills. In the upcoming videos, we will be covering topics like strings, arrays, etc. Don't wait, click the link in the description and start your journey today. Hey everyone, welcome to another video by UpGrad. So far, we have been working mostly with numbers in our Java code, doing calculations, playing around with different data types and all that good stuff. But now, let's switch gears and talk about something equally important, that is strings. Instead of just dealing with numbers, we are going to explore how to handle text like names, sentences or any kind of words in our code. We will go over how to create strings, how to mess around with them and various string operations with hands-on examples. So what are strings in Java? Imagine a string is like a sentence or just any text that you write. In Java, when we want to deal with words, letters or even entire paragraphs, we use strings. A string in Java is like a sequence of characters. It can be a single word, a full sentence or even something as simple as hello. It's like saying, here's some text. In Java, you should treat it as a one whole thing, not individual characters. Now, here's the thing about strings in Java. They are actual objects. Java doesn't treat strings like basic numbers or other simple data types. So when you create a string, Java is really creating an object behind the scenes. The string class in Java provides a wide variety of methods to work with strings that we will explore in this tutorial. Unlike in some other languages, strings in Java are immutable, meaning once a string object is created, it cannot be changed. This we will discuss further. Now that we have understood what strings are, let's move on to how you can create strings in Java. So there are two primary ways to create strings in Java. That is string literal. String literal is the most common and straightforward way to create a string. When you do this, Java tries to be smart about memory usage. It places the string hello world in a special area called the string pool. Here's the cool part. If another string with the exact same value already exists in the pool, Java won't create a new one. It will just reuse the existing string. This means if you later create another string like this, like string str equals to hello world, Java will point str, that is the name of the string, to the same string object in the pool as str1, saving memory. It's an efficient way to manage strings. Another one method to create a Java string is new keyword. So in the new keyword, we are telling Java explicitly create a new string object in memory, even if hello world already exists in the string pool. Java won't reuse anything. It will create a fresh copy of that string using extra memory. So even though str2 and str1 have the same content, they are two different objects in memory. String str2 equals to new string hello world, as we can see on the screen. The new keyword here is used to explicitly create a new object. Here it tells Java to create a new string object, even if an identical one exists in the memory. This line creates a new string object with the value hello world and store it in the variable str2. Unlike using a string literal, this ensures a new object is created in memory even if the same value exists elsewhere. So this is how you can create strings in Java. I've shown you two methods. Now let's do a simple example of Java to make you guys understand it better. Alright, so this is our Eclipse IDE. Here we'll be doing a simple example to make you guys understand. We'll do an example of string. So here we'll be taking an input also, and then we'll be displaying the name and whatsoever we want to display. Alright, so it will be a simple example. First of all, we want to take the input, right? For that, as we already told you, that we have to import this package java.util.scanner. So if you want to take the input, you have to include this. Just keep in mind. After that, we have to create a scanner object to take the input from the user. And this is also that we have discussed previously. Scanner object we are creating now, scanner, and let's name the object also scanner, new scanner system.in. Alright, so this is the syntax. You have to create the scanner object. Now what we'll do is we will declare and initialize a variable. Alright, so this is a string, that is the data type of a string, and the name of the string, let's say greeting. Alright, now the value is hello. Now string greeting holds the value hello. Simple. Alright, now as we know, we have to take the input from the user, so we'll ask the user to enter their name. For that, we will have to display to enter the name. Okay, so we'll write system.out.println, and inside this we'll display a message saying enter your name. Alright, so this is what we have displayed. After this, we will take the input. I repeat, after this we will take the input. So for that, we will create another variable, string variable, that is name. Alright, in this one we will store the value that is being put by the user. Alright, scanner dot next line. So this is how you take the input of a string. Now the thing is, while taking a whole line, we must input dot next line, as we can see. If you are taking the input of the whole line, then you should use dot next line. But if we want to take the input of a particular word, then we'll use dot next only. So dot next like this only we'll have to use if we are scanning a single word. Alright, so if a particular word is being scanned by us, then we can use this. But here we want to scan like a name, so we have to use dot next line. Alright, now after this, here the user will enter and that particular name will be stored in this name variable. Alright, simple as that. Now another variable that we will mention, it is here we are declaring it string message. Now here the variable name greeting plus, so we want to display hello and then the name of the person. So let's say a person named Sam, enter his name Sam, or a person named Robert, enter his name as Robert. So it should display hello Robert. Alright, so we want that only. So this is the name of the variable, this hello, so it will display hello over here, and after this we'll use a comma or something, like let's say we have used comma and a space, then again plus operator, this we already know. Alright, then the name variable that a user has put in. Alright, now after this, if you want to do something else also, you can do that, like let's say I am using this exclamation sign, you can do that as well, it's your choice. Now let's try to print this system.out.println and the message. So this thing is being stored in message variable, so we'll display the message variable. Alright, let's save this one and run it. So it is showing enter your name as we can see on the screen. So let's say we'll add Robert and then we'll press enter. So it is displaying hello Robert. So we have understood how to take the input of a name or any other sentence or something like that. Previously in the previous tutorials we were discussing about numbers, but now we have started discussing about the string also. So this is how you can play around with strings. So this is a simple example. Here what we have done is we have used a variable named greeting. We have stored a value of hello in it, and then we have taken an input from the user in which he or she will enter his or her name, and we will put that variable with his name saying hello Robert, hello Sam, or hello Harsh, or something like that. Alright, so it's simple as that. You can do it on your, I repeat, you can try it on your own. Alright, so this was an example of strings. Now let's understand memory allotment of strings. So in Java, memory management for strings is handled efficiently through several key mechanisms, particularly with the use of string pool, heap memory and stack memory. Here's an in-depth explanation of how memory is allotted for strings in Java. When you create a string using literals like this, string s1 equals hello, what happens here is Java checks a special area of memory called the string pool. Think of string pool as a storage space where all the unique strings are kept. If Java sees that string hello already exists in the pool, it won't create a new one. Instead, it will give s1 a reference or a pointer to that already existing string. But if hello is not in the pool, Java will create it and put it there. This way, Java saves memory by reusing the same string whenever possible. Now using the new keyword, so this was about the string literal. Now using the new keyword. Now if you use string s2 equals to new string, that is the new method, then Java behaves a little differently. Even if hello already exists in string pool, the line creates a completely new string in the regular heap memory, which is a bigger part of memory where Java stores most objects. So even though the value of s2 is also hello, it's a different object in memory than s1. So now that we know how to create strings and memory allocations, let's dive into some common operations you can perform on strings in Java. So Java string operations. So Java provides a wide range of methods for strings operations. Let's explore some of the most common ones. So first we have is length of strings. First, let's start with finding the length of a string. The length of a string refers to the number of characters it contains, including spaces. Java provides the length method to get this information. The length method returns the number of characters present in the string. This includes letters, digits, spaces, and special characters. Alright, so let's do a simple example of this one also to make you guys understand it better. Let's move on to Eclipse. Alright, so let's remove this thing. Alright, so we'll have to do an example in which we are showing the length of the string. So string str, and let's say it is storing this value Java programming. Alright, so this is the value that is being stored in this variable str. Now another variable int, let's say length. So inside this we are storing the length of the string, that is str dot length. So this is the syntax, basically the name of the string, then the dot length method. Alright, as simple as that. So now the length of this string, that is Java programming, is being stored in this length variable. Now we will print it, system.out.println. Now first we'll display a message saying length of the string. Alright, the length of the string, then plus operator, and then the length variable. So this is a variable that is storing the length. So that is why we have used int, because it is storing an integer value. The length can be 5, 10, 20, like that. So that is why we are using integer value. Alright, so int data type is, that is why used. Now let's save it and run it. So as you can see, the length of the string is 16. And if we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's total 16 only, as you can see on the screen. If you'll add, it will come out 16. So it is very simple method to use, that is dot length, the name of the string, and dot length method. So this is how you can calculate the length of the string. This can be useful in variety of situations, such as when you are processing user input, validating string lengths, or iterating over the characters in a string. For example, when building applications that accepts passwords or names, you might want to ensure that the length of input string falls within a specific range. At that point, you can use this method. Alright, so you should keep in mind all these methods. Alright, now moving on to the second operation in Java, which is concatenating two strings. So let's talk about concatenating strings. Concatenation means joining two strings together. This can be done using the plus operator or the concat method. The plus operator or concat method can be used to combine two or more strings. So as we can see on the screen, string full name, first name plus last name, and in between there's a double quotes to just add some space in between. Alright, in the second method, as we can see, first name dot concat last name. So the output of both of these things would be same. Alright, so now this is a basic example, this is a syntax example of it. Now let's do an example in Eclipse. Alright. Alright, we are back on Eclipse. Now again we'll do an example of concatenation. So we'll discuss both the methods. First we will discuss the first method. Alright, so here string, let's name it first name. Alright, and let's store a famous name, let's say John. Alright, now again string last name Snow. So Jon Snow, I believe that you previously know this name. Alright, string full name, the first name, like we have just shown you on the screen, like previously, like that only will do. Alright, some space we'll add in the double quotes so that John and Snow, there should be a space in between, that will look nice. Alright, so that is why we have used double quotes with space. Now after this, what will come is last name. Alright, simple. Now using plus operator, let's write so that you guys can also understand. Using plus operator we have done this. Now using concatenation method will do. Alright, so string full name 2, let's say we have named this variable as full name 2, and here first name dot concat method and the last name. Yeah, but you know what, in this case there won't be any space. To show you guys, I can just print it, but yeah, after this we can again write something like this. This is using concat method. Alright, so yeah, after this there won't be a space between John and Snow, but to make you guys just see first and then I'll make the changes, I'll do like this only. Alright, now what we have to do is we have to print this. So here we will print first this system.out.println. Now here is full name. Let's mention also full name is, and then we will print the full name. Alright, simple as that. Similarly, we'll do here. Just copy it and paste it. Full name is, full name 2 is, let's write full name 2 is. Alright, so yeah, this was of uppercase. Now let's save it and let's see. As you can see, full name is John space Snow, and here full name 2 is John without any space Snow. As I already discussed with you guys, we have used this concat method, but it is not showing any difference between John and Snow. There is no space in between. Alright. So what we can do here, we have to add some space in between. So how should we do that? We'll use another concat method, concat, and this time we'll use double quotes in between. Alright. Now again dot would be used. Now let's save it. Let's see if it will work or not. Alright. Let's save it and again let's run it. As you can see, full name is Jon Snow, full name 2 is Jon Snow. So here this is how you can add space between concat method also. But if you want to use the first method, then you can go forward with the first method. This is how you can concat or merge two strings. Alright. So it is one of the most common operations when working with strings. Whether you're building full sentences, combining user input, or adding extra information to existing text, concatenation make it easy to join strings together. Alright. So keep this thing in mind. Now coming to the next operation, which is comparing two strings. So when comparing strings in Java, you have to be careful. You should use the equals method for content comparison and avoid using the equal to, that is equal to operator, as it checks for reference equality. So this is the syntax of equals method where we want to actually compare two strings. Alright. Now let's do an example where I'll show you the difference between equal to operator and equals method. Okay. Let's go to Eclipse. Alright, so this is our Eclipse and let's remove this. Again, we'll do an example. So doing example parallelly will help you understand it better. So if you want to do examples parallelly, you can do that. Otherwise, after this, you can practice these examples on your own system. Alright, str1. Here, let's name this variable as Java. Again, here another variable, string str2. Here again, we'll mention it Java. So string 1 and string 2 both are Java. Okay. Now string str3. So here we have named a new string. Alright. And here Java. Alright. So here what we are doing is we will compare two values, that is str1 and str2, and we'll see if that is true or false, right? So equals operator will give us the value in true and false. Alright, so system.out.println. So here str1 dot equals str2. So this will check if str1, that is the string 1, is equal to string 2 or not. Alright. So this is what we'll check. Alright. Next is, similarly we'll just copy it. Now here what we'll do is simply we'll write str1 equal to operator str2. Alright, it will check the equality, so it will check the reference in memory. If they have the same reference, it will give us true, otherwise false. Okay, so it should give us true basically. Alright, now we have named another variable string 3. So for that we have to create another system.out.println. So here what we'll do is instead of 2 we'll write 3. Alright, so this will check the equality, the content is same or not. Alright, now again we'll do the operator thing with str3, str1 equal to str3. Alright, so basically these are different objects in memory, because here we can see the new string. So these are the different objects in the memory basically. So I don't think it will give us the true value. Yeah, so let's see. So basically, if I have to tell you guys, in Java strings are objects and how you compare them matters. The equal to operator checks if two string reference point to the same memory location, not if the actual contents are the same. Alright, again, the equal to operator checks if two string references point to the same memory location, not if the actual contents are the same. This can lead to unexpected results when you are comparing strings created with new string, which generates a new object in the memory. The equals method, on the other hand, checks if the actual content of two strings are same. This is what you want when comparing strings for equality. Keep in mind that equals is case sensitive, meaning hello and small case hello are not considered equal. As simple as that. Alright. So now let's save it and let's run it. So as you can see, let's see. So yeah, so the first one, this is true as we believed. This is also true, string 1 equals to string 2, and this is not true because this is also true. Yeah, this is also true, and this is not true, that this is false. Basically different objects in memory, because they have different objects in memory, that is why. Alright, so this was an example of comparing two strings. Now let's understand another operation, which is substring. Now let's talk about extracting part of a string using the substring method. This method allows you to get a specific portion of the string based on starting index or both a starting and ending index. So as we can see on the screen, str1.substring7, str2.substring05. So this is basically the syntax of it. So we will understand it better if we can do an example. So let's go to Eclipse again and do an example of substring also. So this is our Eclipse. Again, we are doing an example because we want a practical way to understand these operations. Alright, so that is why we are doing examples. So let's do this example. So here we can see string sentence. So here what we'll do is we'll basically cut out, or make a substring out of a string and display that. Alright, so the name of the string is sentence, as you can see on the screen, and it is having the value hello world. Alright, we'll also use a comma in between. Alright, hello world. So this is a variable. Another string is string, let's say sub1. Here we are storing the value of substring. Alright, so we have to store the value of a substring that is being extracted from sentence string. So we will use sentence, that is the variable name, string name. Now substring method, and let's say 7. So why we have used 7 here? So basically the portion after 7th character, it will be displayed. Other than that, content will not get displayed. So as you can see, 1, 2, 3, 4, 5, 6. So this will not get displayed. Hello and comma will not be displayed, and only world will display. Alright. So the content after 7th character will be displayed. It will include the empty spaces as well. Alright, so yeah. Now let's do something more, like string sub2 sentence. Here we'll use dot substring 0, 5. Alright, so here it will display the index from 0 to 5, the contents between 0 to 5, it will display that. Basically we are extracting a substring out of a string. So 0, 1, from here it will take 1, 2, 3, 0, 1, 2, 3, 4, 5. So hello will be displayed in this case. Alright, so 0 to 5. If we can do 0 to 7, then it will also include W also in between. Yeah, so it is like this only. Now let's try to display this. System.out.println. So here substring 1 sub1, substring 2 sub2. So here the result of this first string will be displayed. The first substring will be displayed, and the second substring, here it will display the result of second substring. Alright, now it should display world and it should display hello. All right, and let's save and run this. As you can see, world and hello. So this is very simple. You have to just know about the index of that particular character, and which is pretty easy. So here in the second case we have extracted hello, and in the first case we have extracted world. All right, as simple as that. So this is how you can use the substring method. The substring method is powerful tool when you want to extract portions of a string. It can be useful for tasks like parsing URLs, processing user inputs, or extracting specific data from a formatted string. So you can use it in many places. So just keep in mind that these methods do exist, these operations do exist, and by practicing it you can understand it better. Now let's understand about trim method. So the trim method is used to remove any leading or trailing spaces in a string. This is especially useful when dealing with user input that may contain unwanted spaces. The trim method is great for cleaning up input. When users enters data into forms, it's common for them to add extra spaces either before or after their text, whether by accident or habit. Trim method removes all leading, that is before the text, and trailing, that is after the text, spaces. But it does not remove spaces between words. Alright, to understand it better, we can do an example of it as well, and the syntax is there on the screen. Alright, so let's go to Eclipse now. Here we are back on Eclipse. Let's do an example of trim method here. Alright, again, the name of the variable is str and the value inside it is now Java programming. I repeat, Java programming, but we are adding some space between Java programming and the, as we can see in the double quotes, there's some empty spaces. So yeah, Java programming, and there are some empty spaces before and after Java programming. All right, we will remove it using the trim method basically. So again, another variable trimmed str, we'll name it. Now the original string, along with it we'll use the trim method as we already showed you. I repeat, as we already displayed the syntax, str.trim method. It's very simple to use. Now let's try to print it. System.out.println. Now here we'll write original and plus str. Alright, similarly let's just copy it. Now trimmed. So here the value was trimmed str, right? So we are displaying that. To do some extra space here, so we are using this. Now let's try to save it and let's run it. So as you can see, Java programming, before it was this extra spaces was there, this one. After trimming both the spaces, we have removed that. Alright, so this is how you can do that with the help of trim method. So this line, basically the string str Java programming is declaring here and initializing a string named str, and the value of that particular string is not just Java programming, it also includes some empty spaces. Now the trim method is called on the string str. This method removes the leading and trailing spaces basically, but not spaces within the string. So a new string trimmed str is created with leading and trailing spaces removed. So that is being displayed here. Alright. Now let's do another operation of strings, which is empty. Alright, so isEmpty method. This method checks whether a string is empty, meaning it contains no characters. It returns true if the string length is 0. The isEmpty method is a quick and efficient way to check if a string has no characters at all. This method is different from checking if a string is null. So you should often combine it with a null check to ensure you are not working with a null reference. Alright, so this is the syntax, simple, isEmpty, E with an uppercase, that's it. Let's go to Eclipse to do an example of it. Alright, we are back on Eclipse. Let's do example of isEmpty method. String This is the name of the variable and we are not storing anything, just an empty space and non-empty str. All right, so yeah, this is another variable name Java. So the first one is empty and this is non-empty. I hope you guys understood by the name. All right, so system.out.println, here we will be printing if that particular string is empty or not. All right, so is empty str empty. All right, and then using plus operator, the name of the variable is empty str dot, and then the method is empty. Simple as that. I hope you guys are not getting confused. Now what do you think, what should it display? All right, now system dot out dot println here is non empty str is empty. All right, here again we'll write the name. We can just copy and paste it to save the time. All right, along with it we'll use the method is empty method to check whether this string is empty or not. So basically this method is checking whether the string is empty or not, but we know that this is empty and this is not, so we already know what should it display. All right, but to show you guys we are doing this. All right, system, miss the M. All right, now let's try to run this. First one should be true and second one should be false. As you can see on the screen is empty, this one true, and this one is false because this is the empty variable of string and this is non-empty. So yeah, this is how you can check. This is a fine example of it. Now let's do another example of string replace method. All right, let's do this. So the replace methods allows you to replace characters of substrings within a string. It's great for situations where you need to modify specific parts of a string. This method is useful for making targeted modifications to strings. You can replace individual characters or entire substrings within the original string. So as we can see on the screen, str.replace Java with Python. So basically it will replace Java with Python. So to make you guys understand, let's do a simple example. Let's go to our Eclipse IDE. Alright, so we are back. So let's do an example. So first we'll create a string sentence name, let's say I love Java. Alright, so this is the first string. Now another string that we will create is new sentence. Alright, so here we will, what we'll do is basically we will use the method, that is the replace method, sentence dot replace. So sentence is this one string, replace is the method. Now inside this we'll use Java. I'll write Java comma Python. So basically it will replace Java with Python. All right, now system dot out dot println. All right, so here we'll write original one, sentence. Now system dot out dot println, here we'll write replaced, here we'll write new sentence. All right, so this is the first original, this is replaced. So it will display I love Java only, it will display I love Python. All right, let's save it and run it. So as we can see, Python has replaced Java. So the second element will replace the first element here. Simple as that. All right, so this is the string. We have used this operation, that is replace operation on sentence, that is the name of the string, and it is basically replacing this particular word with the word that we want to. All right, So this is how you can use replace method. Now coming to the next operation, which is char at. Alright, so char at method returns the character at a specified index in the string. Remember that string indices start at 0. It is very useful when you need to access individual characters in a string. You can use it in scenarios like parsing or validating strings where you need to check specific characters. Keep in mind that index start from 0, so the first character is at index 0, the second character at index 1, and so on. Alright, simple as that. Again, this is the syntax str.char at, so the index number is there, as you can see. Now let's get back to Eclipse. Alright, so again here string str, let's name this as Java. So Java is a str is a string holding the value Java. Then character, so this is the data type of character char, and we will name it character itself, the name of the variable. Alright, now str dot char at, alright, let's say 3. This is the index number. Now if we'll print it, system dot out dot println. So what do you think? What should it print? Type in the comments. So meanwhile, let's do that. We'll write character at index 3 is character variable. Alright, let's save it. So and try to run this. Character at index 3 is A. So it starts from 0, 1, 2 and 3. So at index number 3 it is A. Don't get confused that it should be V. As we already discussed, the index starts from 0. So we should count from 0. So J is at 0, A is at 1, V is at 2 and again A is at 3. So as simple as that. So what we have done is we have used this char at operation on this string variable. So when we use this operation on this string, so it displays the particular character within that particular string, and then we have displayed I repeat, and then we have displayed that A is that character. Alright, now these were some of the operations of strings in Java that you can use and you should use while doing programs in Java. Try these examples. So now let's understand about Java strings, mutable or immutable. Alright, so in Java, strings are immutable by default. This immutability often leads beginners to wonder, why are strings immutable in Java? Let's break it down and understand what that means. I repeat, let's break it down and understand what this means. An immutable object is one whose state or data cannot be changed after it has been created. For Java strings, this means that once you create a string, you cannot change its value. Any operation that seems to modify a string, like concatenation or replacement, actually creates a new string object rather than changing the original one. This immutability brings benefits like security. Since strings are used in sensitive operations like file paths or network connections, so this is the benefit of it. Another benefit is thread safety. That is, the multiple threads can safely use the same string without risking modification. And the third benefit is memory efficiency. So basically, Java uses a string pool to store string literals, reusing existing strings to save memory. If strings were mutable, Java couldn't reuse them safely. If you need to modify strings frequently, Java provides string builder and string buffer, which are mutable, meaning they allow you to change their contents without creating new objects each time. So this was about Java strings, whether they are mutable or immutable. Now let me ask you, so this was about Java strings, mutable or immutable. I hope you guys understood it. And that's a wrap. Hopefully, you have got a solid understanding of how strings work in Java and how to handle text in your code. We have gone from creating basic strings to messing around with different methods, and you should now feel more comfortable working with strings. In the upcoming videos, we will be covering topics like arrays in Java, It is one of the most important concepts in Java. So stay tuned with this video tutorial series. If you found this video helpful, don't forget to hit that like button and subscribe for more content like this. Imagine if I asked you to create 100 separate variables to store data. Sounds like a time-consuming task, right? You would have to name each one, keep track of them all, and constantly reference them individually. Definitely not an efficient way to code. This is where arrays comes in to rescue the Java. Instead of creating individual variables, you can use an array to store multiple values under one name, all neatly organized and easy to access. Now here's why understanding array is crucial, especially from an interview perspective. Arrays are fundamental in most programming tasks, and interviewers often use them to access your problem-solving skills. You will frequently encounter scenarios where handling large data sets is key, and knowing how to use arrays will demonstrate your ability to write clean and optimized code.
So what are arrays in Java? An array in Java is like a container that holds a fixed number of items, and all those items have to be of the same type. Imagine you have a row of boxes, and each box can only store a specific type of item, like only books or only shoes, but never both. So basically, it allows you to store multiple items of the same type in a contiguous block of memory. Once you create an array and its size is set, then if you create an array to hold 6 items, it will always have space for exactly 6 items. You can't add more later, and you cannot shrink it later. Alright. Next thing is, all the elements in an array must be of the same type. If you create an array of integer, it can only hold integers, no mixing in with other types like strings or characters. Every item in an array has a position, and these positions are called indexes. In Java, array indexes start at 0, meaning the first element is at position 0 and the second is at position 1, and so on. Arrays allows you to quickly access any element directly by using its index. This makes array very efficient when you know the position of the data you want to retrieve. Arrays are great when you know ahead of time how many items you need to store and you want to keep things simple. They give you direct access to any element by its index, making them fast and efficient for tasks like looping through data or updating specific values. For example, if you have a list of student grades and you know there are 30 students, an array is a perfect solution because you can store all the grades in one place and access them quickly using a loop that we will be discussing in this tutorial further, how to use array with loops. Alright, so now come to the next topic, which is how to declare, initialize and access elements of an array in Java. So before you can use an array, you need to tell Java that you are going to create one. Declaring an array is just like saying, hey Java, I need a collection to store multiple values of a specific type. So here's the syntax, int numbers. So as we can see, the int part tells Java you are creating an array that holds integer, that is int data type. Then there is numbers. Number is the name of the array. Here it tells the name that array has this name, just like naming any other variable. It's simple. It's your choice, whatever you want to name it, it's up to you. So basically you are just declaring the array here, meaning you haven't actually created space in memory to hold values yet. It's like saying I need an array but not specifying how many elements you will store. Alright, now let's explore further. This was the declaration. Now let's understand initialization part. So initializing an array. So once you have declared an array, you need to allocate space for it and fill it with values. Initializing means actually creating the array and giving it a fixed size. So there are two main ways to initialize an array in Java. First is initializing with a fixed size, that is without specific values. So you can create an array with a fixed size but without giving it any specific values right away. Java will automatically fill the array with the default values. For example, 0 for integers, null for objects. Here as we can see, int, then there is array numbers, new int 5. So here you are saying create an array of integers called numbers that can hold 5 values. Initially, all the elements of numbers will be 0 because that's the default value for integers in Java. So like that. Second is initializing with specific values.
So this is the second type, how you can, initialize the value of an array. So you can create and initialize an array with specific values all at once. As we can see on the screen, int numbers, then we have specified the values 10, 20, 30, 40 and 50. So this creates an array of 5 integers and immediately fills it with values like 10, 20, 30, 40 and 50. So you don't need to specify the size like new int 5, because Java knows the size based on the number of values you have provided. So it's that simple. Alright. So we have covered the declaration and initialization part. Now let's understand the accessing the elements of an array part. So for that, let me tell you guys with the help of an example. So let's go to Eclipse. Alright, we are on our Eclipse IDE. So here we'll be doing an example in which I'll be explaining about accessing the elements in an array. Alright. So after you have declared and initialized your array, you will often want to access specific elements. In Java, you do this using the index of element that you want to access. Alright. So just keep in mind that array indexes in Java start from 0. So the first element is at index 0 and the second element is at index 1 and so on. Like that it goes. Alright. So let's understand with the help of an example. So int numbers, let's say. So this is how you declare and initialize the array. This is the syntax basically. And here we will be adding the values. So the values you can add as per your choice. You don't have to add exactly the values that I'm adding. All right, 4, let's say 34, then 19 and 7. All right, so few values we have added inside the array. Now if I want to access these elements of an array, what I'll do is I'll simply, first of all, I'll just write the print statement. Yeah, what I'll do is the name of the array, numbers, and the brackets. Inside the brackets, I'll mention the index of the array. For example, let's say I want to display 12, this 12 over here. So what I'll do? So this 12 is at position 0, 1 and 2. So it is at the second index. So I'll just write 2. Just keep in mind, again I'm saying, in arrays the index starts from 0, 0, 1, 2, 3 like that. So technically this 12 is at position 2. Alright. Now again, if I want to print some other element, like let's say I want to print 19, right? So this 19 I want to print. So tell me at which index number it is right now. So 0, 1, 2, 3, 4 and 5. It is at index 5. Alright. Now I will save it and I will run it. So as you can see, now we are basically accessing or displaying the elements of an array. So you can perform various operations. This is a simple operation. I just want to let you guys know. So like this you can, access the elements of an array. Simple as that. So this was about, the integers. For example, let's say I have a string array. Alright. So for that, what I'll do is, let's create a string. So here we are creating a string array and we have named it house. Now inside this, we'll add some elements. Let's say Stark, Lannister. So this is how you create an string array. So you have to separate those elements, and there is Greyjoy. All right, semicolon. Now again, similarly, I'll do for this one also. For example, if I want to print, let's say Lannisters, okay. So what I'll do is the name of the array and inside the brackets, I'll mention the index. Now tell me guys, what is the index of Lannister over here? I believe you guys have said 1. So Stark is 0, 1, 2 and 3. It goes like that. But the actual size is 4. Just keep in mind that. Alright. So I'll write 1 if I want to print the Lannisters. I'll save it and I'll run it. So as you can see, Lannister is being print. So this is how you can access the elements of an array. So this was a complete basic example. Now, so this was basically about declaring and initializing arrays in Java. Now let's talk about the types of array in Java. Alright. So types of array in Java. So in Java, arrays come into two main types. single dimensional arrays and multi-dimensional arrays. These allows you to store and manage multiple values efficiently, but they differ in how they are structured and accessed. So in Java, arrays come into two main types: single dimension arrays and multi-dimensional arrays. These allows you to store and manage multiple values efficiently, but they differ in how they are structured and accessed. Alright, so first we have is single dimensional arrays. A single dimensional array, often just called an array, is the most basic type of array in Java. It's like a straight line of boxes where each box can hold one value, all of the same type. You access each element using a single index, as we just did an example of it. Alright, so here's the syntax on the screen. So ages is the name of the array. 25, 30, 35, 40, 45, these are the elements. So this is a single dimension array. Each element is accessed by a single index that represents its position in the array. You can think of this as a list of values in a straight line. Alright, now coming to the multidimensional array. So multidimensional array is essentially an array of arrays. The most common type is the two-dimensional array, also called 2D array. But Java allows arrays with more dimensions as well, though they are less common in practice. But yeah, a two-dimensional array can be thought of as a table or grid with rows and columns. You access elements using two indexes, one for the row and one for the column. So as you can see on the screen, 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically here also the rows and columns numbers start from 0, not 1. Just keep in mind. So here 1, 2, 3 is row 0, 4, 5, 6 is row 1, 7, 8, 9 is row 2. Alright. So it goes like matrix. So if I have to say this matrix array, the position 0, 0, that is row 0 and column 0, that particular element is 1, because 1 is at 0th column and 0th row. And the element which is at position 1 and column 2 is 6. So the column of 6 is 2 and the row is 1. As I told you, 0, 1, 2. So in that sense, 6th element is at row 1 but the column number 2. Alright. So if you can go through it again and understand, you can easily get what I'm saying right now. So basically here the first index represents the row and the second index represents the column. This is very useful when you need to represent data in the table, like a chessboard or matrix in a math. Alright. So this was about types of arrays in Java. Now let's understand how arrays are stored in memory. So when you create an array in Java, the computer sets aside a block of memory to store all the items in the array. This memory is located in a part of computer's memory called the heap, which is where Java stores objects. Arrays are special because they store items one after another in a straight line called contiguous memory. This makes it easy for Java to quickly find any item in the array. For example, if you create an array to store 5 numbers, Java will allocate enough space in the memory to store 5 integers which are all placed next to each other. When you want to access or change a value in the array, Java calculates where each item is based on its position called index. This makes accessing the elements in an array very fast because Java knows exactly where each item is stored. So in Java, arrays are stored in two parts of memory, that is the heap. So the heap stores the actual data, the array elements, and the stack. The stack stores the reference or address that points to where the array is at the heap. Alright. So basically heap stores the elements of array and the stack stores the address which points to where the array is in the heap. Simple as that. So this was about how arrays are stored in memory. Alright. Now let's understand changing the elements of the array. So in Java, arrays allows you to update or change the value of any element after it has been initialized. Since arrays use indexing, where each element has position starting from 0, you can easily access and modify an element by specifying its syntax. You can directly assign a new value to an array using its index. Like just now we did an example of, accessing it. Now, as we can see on the screen, so we have arrays of, let's say its name is numbers, and it is storing 5 values: 24, 89, 123, 85 and 48, and their index are also mentioned. Now if you want to overwrite or change the value of third index, which is 85, the element 85, so simply I'll assign the new value to it. and it will automatically update it. Now let's understand this thing with the help of an example, because I want you guys to understand it completely so that you can also try some of the examples on your own. Alright, we are back on Eclipse. So here we'll be doing a simple example to make you guys understand it better. So here we'll take an example of strings, fruits. Alright, now let's mention some of the name of the fruits: apples, banana, then there is, let's say, cherry and date. Alright, so now let's say I want to overwrite a particular fruit. Alright, so what I'll do is, let's say I want to overwrite apple here. So let's say I want to update a value or element over here. So let's say I want to modify the first element, which is apple. Alright, so what I'll do is fruits, which is the name of the array, and the index of that particular element, that is apple. Apple is at 0th index, so we have mentioned 0, and here is the updated value, orange. So it will simply overwrite or update the value, or you can say modify the value. It will change the value of apple to orange. Alright, as simple as that. Now here we'll print fruits 0. Alright, so we have updated the value and now we are printing it. Let's save it and run it. So as we can see, fruits at 0th index, now apple is not there but orange is there. Simple as that. I hope you guys understood what I'm conveying. So this was about changing the element of an array. Alright, now coming to the next part, which is determining the length of the array. So in Java, an array is fixed collection of elements of the same data type. The length of an array is total number of elements it can hold. Once an array is created, its length cannot be changed. As simple as that. Alright, as you can see on the screen, there's an array numbers of which is having 5 elements. Alright, 24, 89, 123, 85 and 48. Index numbers are also mentioned, as you can see on the screen. So here the length of the array is 5. Don't calculate the length or size in terms of index, because index starts from 0 but length or size doesn't. Alright, so the length over here is 5 only, because if we'll calculate the number of boxes, which is 5, 1, 2, 3, 4, 5. But yeah, if we'll calculate from the index, which is a completely different thing, it will come out 4. Alright, so always remember, length is calculated from 1 itself. Okay, so if we want to print or figure out the length of an array, so how can we do that? Let's understand it. Alright, so for that, let's take an example, string animals. So here we'll add some elements. Let's say first one is dog, and there is cat, elephant, then there is giraffe, and another one is zebra, then there is lion. Alright, now if I want to figure out the length of this particular array, although I know the length of the array, but to show you guys, let me just do an example. So here what we'll do is, we'll use a method dot length, that's it. So system.out.println, so we'll directly print it. We can also do it otherwise, but yeah, we'll directly print it. So length of the array, and here animals, which is the name of the array, and the length method length, that's it. And now save it. So this will basically display the length of the array or the size of the array, or you can say the number of elements inside an array. Alright, it will give us an integer value. So the length of array is 6. So let's calculate 1, 2, 3, 4, 5, 6. As simple as that. So this is how you can calculate the length of the array. Alright, now coming to loops with array. So when you're working with arrays, you're dealing with the series of values that are stored under one variable. Arrays have multiple elements, and these elements are accessed using their positions known as index. So a loop is what you use when you want to go through each element in the array and perform some kind of operations on them. For instance, if you have an array of numbers, you want to add them up, you would set up a loop through each number one by one. The loop knows how many times it needs to run, because arrays have length, which is basically the total number of elements in them. In most cases, you would use something like a for loop or a while loop to go through the array. As simple as that. Now, to explain you guys, let's do an example. Alright, so we are back on Eclipse. So here we'll do an example in which we will loop through each element of an array and printing its value along with its index. Alright, so by this you will understand how loops are used with array. Alright, so you will be using loops with array quite often. In almost every program that you'll do, you might be using it. Alright, so I want you guys to understand it. First of all, we'll declare, let's say, what should we name it? Let's say numbers itself. Yeah. Now, let's add some values, 10, 30, 40 and 70, like that we can add, and 69 and 78, like that. We'll keep it consistent. Yeah, so these are the values and this is an array. So we have declared and initialized an array with the name of the array is numbers and its data type is int. Alright, now the second thing that we want to do, we'll use a for loop because we want a particular loop. We want to iterate each element of an array and we'll be printing each element of the array along with its index. Alright, for that we'll have to use for loop because loop help us to go through each element of the array and then printing each element of the array. But as we know, in for loop we must have a condition. So what condition should we use over here? Because we want a loop to run till a particular condition is met, right? So basically that's how the loop goes. So we'll be using for loop and int I equals to 0. So the loop will be starting from 0, which is the 0th index of the array, that is 10th. And then here we'll put a condition, the size of the array. Now we can't directly write. If you want, we can write in this case, but there are cases when we don't know the size of the array. So what in this case we can use numbers, which is the name of the array, dot. So you should use this, I less than numbers dot length. So the loop will start from 0 and it will keep on going till the length of the array, which is the last element of the array. Because we want to print each and every element, that is why we are looping it through each and every element till the last element of the array. Alright, so this is the increment. Once one element is done, then it will move to the other element, that is the other index. So it will start from 0th index, then 1 index, then 2 index, then 3 index, like that it will go. So this I plus plus is basically incrementing the index. Alright, now inside the for loop, what we'll do is we'll print system.out.println. Alright, so here as you can see, first we'll just write element at index. Alright, numbers I. Alright, so this is it. So basically what we are doing is, here we are printing the elements of the array, here we are printing the index of the array. Alright, now what the loop will do? So the loop, that is I equal to 0, will start from here. So first the 0th index will be printed. So at 0th index we have 10. Then it will check if the condition is met. Yes, the number is less than its length. So the length of the array is 1, 2, 3, 4, 5, 6. So yeah, this is the length of the array. 6 is the length of the array. So 0 is less than 6. So it will go to forward, that is it will increment. Then it will come to the index 1. Then 1 index is here, then it will print 1. Then similarly 2, then it will print 2. So it will keep on going till it will come to this. So once this will be printed, that is the 6th element, then the loop will stop. So one by one we are basically iterating. Alright, each and every element will be printed by that, and I is the index, so I is also getting printed. Alright, now we'll save it. Alright, we can see element at index 0 is 10, element at index 1 is 30, element at index 2 is 40, at 3 is 70, at 4 is 69, at 5 is 78. As simple as that. I hope you guys understand what I'm doing. You can also do this exactly same thing with the help of while loop. I want you guys to try this thing first with the for loop, and then on your own try this thing with the while loop. All right, I hope you guys have understood while loop. So I just want you to try that thing, because practice will make you perfect, so you guys have to give it a shot. All right, so this was one of the example of loop in which we are using it with an array. Now let's do another example. So this will be, here we will do an example in which we'll find the largest element of an array. All right, so I want you guys to pay some attention, because it can be a bit difficult for the beginners, but yeah, it will be worth it. So here we'll have to find the largest element of an array. So what we'll do is we'll go through the entire array and check each and every element if that element is greater than the element that we have set. So first let's start. I'll explain to you guys. All right, first we'll have to declare and initialize an array. Here again we'll take, let's say, numbers only. And all right, so this is the array and these are the elements of that particular array. Now here in this type of example, first of all we will assume the first element of the array is the largest. All right, so this is how it goes. So let's assume the first element is largest. So we'll take a variable largest and assign the first element. So how we're going to do that? Numbers. So the first element of the array, that is at the 0th index, correct? So all right, so we have assigned the first element, that is 5, to the largest variable. So what here we are doing is we are just assuming the first element is the largest. All right, I'll tell you guys why we are doing it. Now we will loop through the array to find the largest element. So we will basically compare this element with other elements. If it is greater than that, then automatically it will be the largest. Otherwise, the other element which is greater than this particular element will replace it. So this is how it goes. So we are using for loop again. Int I equals 1, I less than numbers dot length. All right, now I plus plus. All right, so inside this for loop, what we are doing is we'll use a if statement or if condition. Numbers will basically compare if number at ith index is greater than the number that we have assumed that is the greatest, that is the largest. Here we'll basically compare every element with this particular number. So one by one it will give us whether it is greater or not. If it is not greater, then the number that we are comparing it with will be assigned this number, the largest number. Largest equals to numbers I. If that particular number is greater than largest, then we'll basically assign that number to the largest, because that will automatically become the largest. Then again we'll compare with the other elements, like that it will go. So basically we'll update the largest if current element is greater. All right, so let me write here also so that you guys understand what I'm doing. All right, so this will give you an idea. All right, so now coming to the printing part. So here the largest element is the variable largest, because the end result will be stored in the largest, because we are basically assigning if that particular value is greater than that to the largest variable itself. So whatever be the largest value will be stored inside it. Don't worry if you guys haven't understand it yet, I will explain it again, so you don't need to worry. All right, now for those guys who haven't understand it yet, first of all let me just save it and run it to make you guys sure that it is running or not. I think there is some error, as you can see. Oh yeah, here we haven't used the semicolon. Let's save it again and now let's try to run it. So as you can see, the largest element is 20 and this is our array. So yeah, the largest element is 20 itself, as we can see. So how this works, again I am explaining. So the array numbers contain a list of integers. We initially assume that the first element, that is this 5, we initially assume that the first element is the largest. So the first element, how did we assume? We assigned that the first element, that is numbers at 0th index, which is 5, to the largest variable. All right, so then we use a for loop to iterate through the rest of the array starting from index 1. All right, to compare it basically. During each iteration, we check if the current element, that is 5, is greater than the current largest value. If it is, we update the value of the largest. Alright. And after the loop completes, the largest variable holds the value of the largest element in the array. So one by one, every element gets compared to 5. So first 5 gets compared to 12 and 12 is greater to 5. So yeah, now largest element becomes 12. Again, then 12 is compared, this is 12, 12 is compared with other element which is 7. But we know that 12 is greater than 7, then nothing will change. Then again 12 is compared with 20, then 20 is greater than 12, then the value 20 will be assigned to the largest variable, this variable. Again we'll compare it with 15, but 15 is not greater. Again we'll compare it with 9, but 9 is not greater. So eventually the largest element becomes 20. As simple as that. Alright. Now this was the example of finding the largest element. Let's do another example. Alright, so now we'll do an example in which we will find the sum and average of all the elements of an array. Alright, so first we will declare and initialize an array. Alright, so here we'll write the elements. 10, 20, 30, 40, 50 are the elements of numbers array. Alright, now we'll take a variable to store the sum of the elements. So we'll declare or we'll initialize a variable with 0. So this particular variable, sum variable, is storing the value 0. That is basically we are using this variable to store the sum. So initialized we have it with 0. We have initialized it with 0. Alright. Now we want to loop through the array to calculate the sum. So for that we have to use for loop because we want to loop it. So int I equals to 0, I less than numbers dot length now here sum equals sum plus numbers I. So here we will add each element to the sum. Alright, and we have did this example in the past in the previous tutorials also. So here we are basically adding each element to the sum. Alright, so as we know the initial value of sum is 0. We have initialized it with 0. So what this loop will do is, so basically this loop is iterating through this array. So first 0th index element comes, that is 10. So sum is, but as of now it is 0 and this is 10. So 0 plus 10 becomes 10. The value of sum becomes 10. Alright, then the second element will come and the second element value is 20 and sum is 10. So 10 plus 20 becomes 30. Then the third element will come, which is 30 and sum is also 30. Then 30 plus 30 becomes 60. So this is how it will goes. Basically it will add one by one to the sum variable and each element will be added. Alright. Alright, now after this we will calculate the average, basically average as an integer because we will be displaying sum and average of all the elements. So for that int average equals sum divided by numbers dot length. As we know the formula to calculate the average, the sum of all the numbers divided by the length, that is the n. So numbers dot length will give us the size of the array, that is the number of elements that are there in the array. So basically we will divide it. Alright. Now system dot out dot println. Now here we'll display sum of elements, sum system dot out dot println. Here average of elements, average. Alright, so here what we are doing is we are basically printing sum and average. So we will be calculating the sum using this and then we'll calculate average using this. Once this is complete, average is calculated and simply we will displaying the both sum and average. Let's save it and run it. Sum of elements is 150 and the average of elements is 30. So as we know, 1, 2, 3, 4, 5. If we'll divide 150 by 5, the average will come. 150 divided by 5 will give us 30. So this is correct basically. Alright. So this is how, using loops and arrays, you can calculate the sum and average of an array. That's it. I hope you guys understand it. Now let's do an example in which we will be counting even and odd numbers in an array. Alright. Alright. So now let's do another example. Again, for this one also we'll be taking the similar array. Let's say numbers 10, 23, 44, 55, 78, 90. Alright. So these are the elements of the numbers array. Now we will we'll declare the variables to store count of even and odd numbers. We'll initialize those variables with 0. So basically we want something kind of variable to store count of even and odd integers. So that is why we are declaring it. Alright. So even count, let's initialize it with 0. Then odd count again with 0. Alright. Because we want to display the even and odd numbers, so that particular count will be stored in these numbers. Alright. Now we will loop through the array to count even and odd numbers. For that we'll use for loop and int I equals 0, I less than numbers dot length I plus plus. If numbers I2 is 0. So here what we are doing is, I hope you guys understand this part where we will be looping through the array. But now comes the if condition that we are using inside it. So basically here we are checking if a particular element gives us the remainder as 0. So as we already discussed, any number, if we will divide it by 2 and it will give us 0, then it is an even number. Alright. So here what we are doing is, as we know, mod will give us the remainder. Alright. So if we divide a particular number by 2 and it will give us 0 as the remainder, that means that particular number is even. And if it will not give us 0, then it is odd number. Alright. Simple as that. So this is what we are doing by calculating it. Okay. So we will check one by one each number. If that particular number gives us 0, that means it is even number. And if that is even number, we will increment this thing. Basically one count is increased, that particular element is even. And if it is not, like if it doesn't give us 0 number, then this number will increase, that is the odd count. As simple as that. So even count plus plus. Let me write here so you guys can understand. Increment even count as remainder is 0. Alright, here we'll use semicolon. Alright, so this was if, and then there is else. So if a number is, like if an element doesn't give us 0 on dividing it by 2 as a remainder, then that particular element is not even, which means it is odd. Alright, odd count plus plus. Increment odd count as remainder is not 0. Alright. So this is how it is done. Now if and else condition we have put. Now the time is to print these. Alright. So here system dot out dot println. Here what we'll do is we'll print the even numbers. Numbers of even elements, even count. Then again we'll just copy paste it. Numbers of odd count. Alright, we'll save it. Let's see. So numbers of, alright, so by mistake we wrote like this. So yeah, numbers of even elements are 4 and number of odd elements are 2. Let's check. 2 is even, 44 is even, 78 is even, and 90 is even. Alright. So 4 are the even, and 7 and 55 and 23 are odd. So this output is correct. Alright. And I hope you guys understand. For those who didn't understand this thing, let me tell you, here we have initialized two variables, even count and odd count. We will be storing the number of counts in these particulars variables. Then we use loop to iterate through each and every element of an array and check if that particular element gives us 0 while dividing by 2. So mod 2 will give us remainder. So if we'll divide a particular element by 2 and if that particular element gives us 0, it means it is even number. And if it is even number, we'll increase the count by 1. And if it is not an even number, we will increase the count by 1 of the odd count. So this is how we are calculating the number of counts, and then we will simply displaying it. So yeah, these were some of the examples of arrays in Java. You can try these examples. I want you guys to try these examples and some more examples on your own, because then only you guys will be able to understand and implement these things. Alright, we have covered a lot about arrays in Java, and you should now have a solid understanding of how they work. We have looked at what arrays are, how to declare and initialize them, and how to access or modify their elements. You also learned about different types of arrays like one-dimensional array and multi-dimensional array, and how Java handles them in memory. By now, you should be comfortable using arrays in your programs and leveraging them for storing and managing collections of data efficiently. In the coming videos, we will cover for each loop and many topics like that. So stay tuned and keep learning. Ever felt like you had a bunch of tasks to do and you just wanted a simple way to tackle them all? Well, in Java, the for each loop offers just that kind of simplicity. It's clean and straightforward way to loop through every item in an array or collection without needing to mess around the index variables or complicated logic. Interviews love seeing developers who know how to write concise, readable code. So mastering the for each loop isn't just helpful, it is very important.
What is for each loop in Java? So the for each loop in Java is a simplified way to navigate through arrays or collections. Its primary purpose is to make it easier to work with every element in a group of data without having to manage the underlying mechanics of looping, like index positions or you can say boundaries. So when you are dealing with an array or a collection like a list of numbers or objects and you need to process or examine each item, the for each loop is your go-to solution. It essentially says for each element in this group, perform an action. So this eliminates the need to manually track how many items are there or where you are in the list. So basically, the for each loop in Java is a special type of loop used to easily go through each element in the collection, like an array or a list, without needing to worry about how many elements are there or how to access each one individually. So there is no point of having an index over here. So now that we understand what a for each loop is, let's look at how it is written in Java. So basically, let's have a look at its syntax. So the syntax for each loop in Java is designed to simplify the process of iterating over the arrays or collection. So here we don't use I, that is the index. So its syntax is pretty simple, as you can see. For the keyword, after that there is type, then the variable name, and then the name of the array. All right. So as we can see, first I'll explain the type. So this type refers to the data type of the elements in the array or collection. For example, if you are working with an array of integers, the type would be int, that is integer. If it is an array of strings, the type would be string. All right. So this was about the data type basically. After that, there is where. Where is basically the variable that holds each element in the array or collection. As the loop iterates, it represents the current element the loop is working with at any given moment. For each cycle of the loop, where is assigned the next element in the array. So basically, where is the variable that is getting stored from this array elements. So one by one, each and every element of the array will be shifting to this where and it will get printed or whatsoever you want to do with that. All right. So this was about where, which is the variable. Now The third is array. So this is the array or collection you are iterating over. So it could be of any type of array like integer, string, or a collection like an array list or a hash set that we will be discussing in further tutorials. So basically the loop goes through each element in the array or the collection from first to the last. So one by one, each and every item of the array will be going to this var variable that will hold the element, and then we can perform the actions. So we don't really use index over here. So now that we have gone through the syntax, let's explore how it actually works in the practice. So how does it work? So the for each loop in Java works by automatically iterating over the elements of an array, or you can say the collections, simplifying the process of handling each element without needing to manually manage indexes or worry about the length of the array or collection. All right. So here's the example on the screen as we can see. So int number. All right. So here it declares a variable named number of the type integer. So this variable will hold each element of the array numbers. The array name is numbers. So this number variable will hold each element of the array numbers during the loop's iteration. And we know numbers is the array. So numbers specified that the loop will iterate over each element in the array numbers. Alright, so numbers is basically the name of the array. So now let's break down how it works through an example. So now let's do an example and understand it in a much better way. Alright. Alright, so we are on Eclipse. So here we'll do an example to understand this thing better. So it's working basically. Alright, so first of all, as we know, public static void main, string arguments. Alright, let's remove this. Now under the braces, what we're gonna do is, first of all, we will, initialize an array int type, and let's name it array itself. Let's name it numbers, let's say. Alright, so 1, 2, 3, 4, 5. Alright, so we have declared an array. Now using for each loop, we will traverse through each and every array elements. Alright, so this is what we're going to do. For loop we'll use. So this time we are not using for loop, but for each loop. As we already know the syntax, the data type, the variable that will hold each and every element of the array. So keep in mind, this is numbers. Numbers is the array and number is the variable that will hold each and every item or element, that is 1 2 3 one by one. So here is the syntax, and numbers, that is the name of the array. So one by one, each and every element of numbers array will be transferred to number, that is the variable, and we will print each and every element. So simply we'll print number. All right, I hope you guys understand this thing. For those who didn't understand, again we'll repeat it, so you don't need to worry about it. Let me just print first. All right, so now it will print all the numbers, that is 1 2 3 4 5, that is the elements of the numbers array. Let's save it, and now let's try to run this. As you can see, 1 2 3 4 5, it is displaying each and every element of the numbers array. Now for the people who didn't understand it, so basically first of all what we did is, an array called numbers is created by us, which have the elements, that is the integer elements 1 2 3 4 5. All right, after that we have used a for each loop. So we wanted to display each and every element of the numbers array, so that is why we have used for each loop. This program can be done with the help of for loop also, but here we wanted to understand the working of for each loop, that is why we are doing it. Okay, so the for each loop starts with the keyword for, as we can see. Now the loop variable number is declared as an integer, as you can see, integer number. Now this means this matches the data type of the elements in the array numbers. As we know, the data type of the elements are integer only, so that is why we have used this. All right, now the loop will proceed to iterate over each element in the numbers array, starting from the first element. So during each iteration, the current element from the array is assigned to the variable number. So in the first iteration, number is assigned 1. In the second iteration, it's assigned the value 2, and so on until the loop has gone through all the elements. So inside the loop, as we can see, there is a print statement in which we are printing the number. So here this statement is executed printing the current value of the number. So this will continue until all the elements in the array have been processed and the loop exits after printing all the numbers. All right. So this is a very simple and basic example for you guys to understand. I hope you guys understood it. Now that we have seen how the for each loop works, let's move on to when it's appropriate time to use it. All right. So now let's understand when to use Java for each loop. So when to use Java for each loop? So you should use the Java for each loop when you want to go through all the elements in a list or array without changing anything. Now it's perfect for situations where you just need to read or process the elements, like printing them or calculating them based on any factor. For example, if you want to print all the items in an array or sum up numbers, the for each loop makes this easy and much more clean. All right. However, if you need to modify the elements or change the structure of the collection, then a regular loop would be more appropriate. So these are the differences that when you have to use Java for each loop and the for loop. All right. So basically, these are some of the, although both the loops can be used, but there are some advantages of both of these loops. And now let's understand when not to use for each loop. So as we have understood just now, like these are the situations when you should avoid for loop. Now let's have a look at the situations where should we avoid for each loop. That is when not to use for each loop. So you shouldn't use the for each loop in Java when you need to filter elements or modify the collection, like removing or replacing items. So this is because the for each loop hides the iterator, which is what you will need to perform these actions. And without the direct access to the iterator, you cannot remove elements or alter the structure of the list while iterating. So for example, if you are trying to remove certain items from array list based on a condition, the for each loop won't work because you can't call remove. In these cases, using an iterator or regular loop is a better option. So this was about when not to use for each loop. Now let's do some more examples on for each loop so that you guys can also understand along with me. You can also do the practice along with me. You can just open the code editor in your system and start coding with me and do the programs. This way you will understand it better. All right. Now let's do another example. All right, so we are back on Eclipse. I hope you guys understood the previous example that we did. It is already on the screen. Now we'll do another example in which again we'll use for each loop to traverse through again array of integers. But this time let's do some other numbers. All right. So yeah, let's do it. All right, now let's this time again we'll create a numbers array itself. And but this time it will be a random number like 23, 56, 61, 47, 102, 79, 34. Let's add some more numbers. All right, so these are the elements of the array. The name of the array is numbers. All right, so yeah, so we have declared the array, and now again using for each loop we will traverse through the array. All right, so here we can see for. I hope you guys understood the syntax, the data type, the variable that will hold each and every element of the array, then the colon. After colon we'll have to use the array name, that is numbers. All right, now this is the syntax, and inside this we'll simply print. And because we want to print each and every element one by one, so number will be holding each and every element one by one, so we will print that itself. So again, for the guys who didn't understand this, let me first save it. So the line for int number colon numbers is basically saying for each item in the numbers list, call it number and do something with it. So the loop grabs the first number from the list, which is, as you can see, 23, then goes inside the curly braces to see what to do next. First, it picks up the number 23, then moves to the next one, that is the 56 and prints that and keeps going until it's done with the whole array basically. So the loop continues until it has gone through every single element in the numbers array. So let's save this one and run this. I believe there is some error. Yeah, by mistake we have used the full stop instead of comma. So it has shown us compile time error. That is the syntax error. Alright, now let's again save it and run it. So as you can see, all the numbers are getting printed. 23, 56, 61, 47, 102, 79, 34, 29, 63, 77. Alright, so now we can also put a condition in between whatsoever you want to do. You can mess around this question in order to understand it better. Alright, so this was the first example. Now let's do another example. So this time we'll do an example of array list. Just now we did an example of array. Now we want to do an example of array list. So the array list is a concept that we haven't understood yet, but let's do an example of this one because we don't need to understand array list for this particular example. The basic things I'll tell you, but in the further tutorials we will be covering array list, so you don't need to worry about that. So basically my point of doing the example with array list is because we also use it with array list, the for each loop. So that is why I want you guys to understand and do an example with it. All right, so first of all, you can just ignore what the syntax is all about because obviously we'll be covering it in the further tutorials. So first of all, we'll have to create an array list of integers. So let me just do that. Array list, then integers. This is how we do it. Integers, then numbers, new, just copy paste it. New array list. All right, we have declared it. Now, in order to add numbers in this array list, we do it like this: numbers dot add and 4. Similarly, for each and every element that you want to add inside an array list is going to be like this only. So let's make it 3, let's make it 6, let's make it 31, 24. All right, so these are the numbers or elements that we want to add in the list, that is the array list. So this is how we do it: numbers dot add. That is the name of the array list and the add function. All right, now after this, we will be using a for each loop to traverse through each and every element basically. So the process is same itself. For loop int, that is the data type, number colon numbers, and then inside this system.out.println, now here number. Let's save it and let's run it. I know there's some error with array list, the syntax of it. All right, what it is showing, yeah. So the error is we haven't imported the java.util.arraylist class or the package, so we want to do that. So import java.util.arraylist. I believe now it will understand it. All right, as you can see, it is getting printed 4, 3, 6, 41, 24, 44, 98, and 7. So this is how you can add numbers, and using for each number, for each loop, you can print it in both arrays and array list. So this is very basic examples. I just want you guys to try the different examples because the basic is this only, the rest is upon you. So now I hope you have understood this example and the concept. Now I want you to try an example of for each loop. So the level of this example will be beginner only, as we did. So but you will be able to do it, and but if you are successful in doing the challenge, then you can write in the comments, and you can write done in the comments, or you can just give it a heads up. So I really want you guys to try this example because that will train your muscle to do more programs like this. All right, so the challenge is you have to create an array of 5 names or strings, that is, and like Alice, Bob, Charlie, David, Eve, and use a for each loop to go through the array and print out each name. Add one extra condition: if the name is David, print found David instead of just printing the name. Okay, now also if you are not able to do it, then also don't worry. After few days, we will add the link of the solution in the description, which you can have a look at it. But first, I want you guys to try this, because then only you'll be able to, get consistent in the practice of doing Java examples. And I believe you can do it because it's a pretty basic example. And yeah, now that we have covered both the use cases and limitations, now let's look at some of the advantages of the for each loop. Okay, so advantages of for each loop in Java. So the Java for each loop is a convenient and user friendly way to traverse through arrays and collections. It offers several advantages. First one is reduces errors. So since it handles the iteration internally, it eliminates common mistakes like going out of bounds with an index or skipping elements, which reduces the chances of bugs. Then there is improves readability. The code is much cleaner and easier to understand, especially when you just need to go through each element without worrying about the loop's mechanics. Alright, third one is no index or counter. So you don't have to manage an index or counter manually, making the code simpler and less prone to mistakes related to indexing. So these were the three advantages of for each loop in Java. Having looked at the advantages, now let's explore the limitations of the for each loop. So the limitations of for each loop in Java. First one is no reversal traversal. You can't go through elements in reverse order because it doesn't offer control over the iteration direction. Second one is cannot skip elements. Since there are no index, you cannot skip specific elements, meaning you have to process each one in the order. Third one is no access to specific elements. So it doesn't allow you to jump to odd or even elements directly, as you can't reference elements by their position. Now that we have discussed the advantages and limitations, now let's compare the for each loop with the traditional for loop. I hope you guys are waiting for this. So yeah, for loop and for each loop. First, for loop. So the for loop runs a set of code repeatedly until a condition becomes false, giving you the control over how many times the loop runs. Whereas a for each loop runs a set of code for each element in an array list or collection, automatically handling the iteration. Then for loop, it does not depend on collections or objects, meaning you can use it on any kind of repetitive task even without an array or collection. Whereas in for each loop, it works only with arrays or collections and cannot be used outside of that. So the third one of the for loop is it's versatile and can be used in a variety of situations whether or not you are working with objects. Whereas in for each loop, it's specifically designed for use with collections or objects that can be iterated over. Now, let me ask you something. Are you ready to take your tech skills to the next level and open doors to new career opportunities? Then check out our Masters in Computer Science program. It's perfect for anyone aiming to thrive in the development world. In this program, you will explore everything from advanced Java to data structures, algorithms, system design, and much more. Don't wait, click the link in the description and start your journey today. Also, we believe everyone has a unique path to success, and sometimes all you need is a little guidance. So, our expert career advisors are here to help you find the career path. Don't miss out. Click the link below to book your free counseling session and start building the career you have always dreamed of.
So that's a wrap for Java for each loop. We have covered how it simplifies looping through arrays and collections, making your code cleaner and more efficient. Now you are ready to tackle interviews with this in your toolkit. But we are not done yet. Up next, we will dive into multi-dimensional arrays and see how looping through them works. So stay tuned with this video tutorial series. If you found this video helpful, don't forget to hit the like button and subscribe for more content like this. We have already learned the basics, how arrays work, looping through them with for each loops, and some hands-on examples. But now it's time to take it a step further. Let's talk about multi-dimensional arrays. An array, as we know, is a data structure that stores similar data together in memory. But sometimes we need more than just a simple list of items. So this is where multi-dimensional arrays comes in. The idea behind them is that you can have arrays inside of arrays. The concept of multi-dimensional arrays is important when you're working with the things like image processing, game development, and scientific calculations where data needs to be stored in multiple dimensions. So in this video, we will understand everything about multidimensional arrays, its syntax, its types and applications of multidimensional array with hands-on examples. So introduction to multi-dimensional array in Java. An array in Java is like a simple structure that stores data of the same type together. Think of an array as a list of items like a list of names or numbers. But sometimes just a list isn't enough, especially when you need to store data that is more complex or structured, like information in rows and columns, similar to a spreadsheet. This is where multi-dimensional arrays comes into play. For example, consider a basic list of numbers which represents 1D array. As we can see on the screen, 1D array, array 472. 472 are the elements. Alright, and all the elements are arranged in a single line, as we can see, one after the other. Now, when your data requires an organization in tabular form with rows and columns, such as a grid or matrix like a 2D array, so as you can see on the screen, the 2D array like this format. So in this particular case, 2D array comes into play or it becomes useful. So a 2D array allows you to manage your data in both dimensions, making it ideal for representing structures like tables. Now a 2D array has rows and columns, and each element can be accessed using a pair of indexes, that is row and column. Now each position in this grid can be thought of a cell, much like how spreadsheets organize data. Now, multidimensional arrays can be extended beyond 2D. For example, a 3D array would be like a stack of tables, adding another layer of complexity by organizing data in rows, columns, and layers. Similarly, you can have 4D arrays or even higher dimensions. Through visualizing them becomes increasingly difficult. So we usually do till 3D arrays. Now, the operations performed on multidimensional arrays become more challenging with the increasing dimensions. You can add, subtract, multiply, and execute several other activities on a multidimensional array system. Alright, so this was about the multidimensional array introduction. Now let's proceed and understand its syntax. Alright, so here's the basic syntax for creating a multidimensional array. Let's start with the 2D array, which is the most common type basically. But first we have to understand its syntax. So first of all, as we can see on the screen, data type, then there's array name, then new data type, new is the keyword here, then rows and columns. So let me go through each of them one by one. So first of all, there is the data type. So this is the type of data the array will hold. It can be things like int for numbers, string for text, double for decimals, and so on. Like we discussed earlier in the previous tutorials, so I am considering that we know about the data types. So if you want to store a list of numbers, you would use int, and if you want to store names, you would use string. Alright, so this was about data type. Now array name. Now this is simply the name you give to your array, just like how you give your name to a variable. You give a name to your array so you can use it later in your code. As simple as that. You can name it whatever makes sense to your program. Now then comes the rows, as we can see on the screen in the syntax. So rows is basically the number of rows in the 2D array, which represents the first dimension. Think of it like a table where the rows go horizontally. Alright, now then columns. So this is the number of columns in the 2D array, which represent the second dimension. Now columns go vertically like in a spreadsheet. So rows go horizontally and columns go vertically. Now to access or modify elements inside a 2D array, we use square brackets for both row and column, as you can see on the screen. Now, for example, if you want to access the element at row 2 and column 3, you would do something like this, like int value numbers 1 2, as we can see on the screen. Now here 1 refers to the second row, that is because we know that the count starts from 0 1 2 in programming. So here the first refers to the second row, because in Java rows and columns start from counting from 0, that is 0 1 2. So as we similarly, the second, which is the column, here we have written 2, which refers to the third column, 0 1 2. So technically it is the third column. So now if you want to change the value of it in the array, so all you have to do is to just specify that particular position with a number. For example, here we are specifying row 1 column 2 the 7th position. So in the multi-dimensional array, in the 2D array, at this particular position, that is at position at row 1 and column 2, 7 would be specified basically. Alright, You guys will understand as we go forward. We'll do some examples if you haven't cleared it yet, but in the further tutorial when I'll be telling you the demo part, there you can clearly understand it. All right, now let's have a look at types of multidimensional array and do some examples so that you can also grab what I'm telling right now. All right, so let's have a look at types of multidimensional array in. All right, now let's talk about applications of multidimensional array. So in Java, multidimensional array are pretty handy and show up in lots of different applications. Let me explain some most common uses where you will often see them. First off, there's a matrix operations. If you have ever dealt with matrices in math, like those grids of numbers, Java uses multidimensional array to represent them. Simple as that. So if you are doing things like multiplying matrices, adding them together, or transposing them, which just means flipping the rows and columns, you can use 2D arrays for that. This kind of work is especially useful in areas like scientific computing, data analysis, and linear algebra. So another cool use is image processing. Think of an image as just a grid of tiny dots called pixels. Well, in Java, an image can be represented as a 3D array where each element represents a pixel and its color information, like RGB values. So if you are doing things like filtering an image, resizing it, or detecting edges, multidimensional arrays comes in handy to hold all that pixel data and apply these manipulators. Then there's game development. Ever played a game when there's a board, a map, or whole world to explore? All of that can be represented using multidimensional array in Java. Each spot in the array represents a specific part of the game world, like a tile on the game board. These arrays can store all sorts of things like where the player is, where obstacles are, or the terrain features. You can even use arrays to track things like collision detection and pathfinding, where the game figures out how characters move or round obstacles. Alright. Next is data storage and analysis. Especially in field like data science and machine learning, you deal with huge sets of data. Multidimensional arrays are great for organizing and analyzing this data. For example, if you have a data set with different features and samples, like let's say height, weight, and age of people, each feature and sample can be stored in a multidimensional array. Once the data is stored, you can apply algorithms or run statistics on it for analysis and modeling. Alright, and lastly is graphics and GUI application. So when it comes to rendering images for graphics on the screen, you can use arrays to store pixels information or details about graphical objects. For example, each pixel's color in an image can be stored in an array, and then Java used that too to draw the image on the screen. You can also track user interaction in graphical interfaces, like where a button is located or what its current state is using multidimensional arrays. So these were some of the applications of multidimensional arrays. Okay, so first one is multidimensional array of primitive types. So to do this example, here we will do a practical example basically. And in this particular example of a multidimensional array of primitive types, we will create a 2D array of integers called matrix with dimensions 3 cross 3. But yeah, it is 2-dimensional. Now we will then assign values to specific elements of the array using the row and column indices. Finally, we will print the values of 3 elements of the array. As simple as that. First of all, we'll assign it and then we'll print it. So I'm going to show you how to do this. So first of all, we have to mention the name and everything. So I believe you guys know about arrays, so it's quite similar to that. So let's do this. So matrix is basically the name of the array and int is basically the data type. Now there's new keyword and the data type again, int, and here first is rows and columns. All right. First one is row and second one is column. Now what we'll do is we'll basically assign some values to each of these positions. All right. So the name is matrix and here's how you can assign some values. So at 0th row and 0th column, which element should be there? So let's say I want 1 and similarly we'll just copy paste it. All right. Now at 0th position and 0th basically 0th row and 0th column we have 1. Now let's say we'll assign another variable at
1th column and at first row and first column basically. Here we'll assign 2, and then second row and second column, here we'll assign 3. So randomly we are doing this. You can try some other positions also. I'm just showing this thing to you guys. All right, now we know how to print system.out.println. now here we have to just write the position, and we know what is the position. For example, I just want to print 0. Now not 0 but 1. Now we know that it is at 0th row and 0th column. So all I have to do is to write like this, the name of the array and its position. All right, so this will give us the output as 1. All right, just mention like this. Yeah, now similarly I'll just copy paste this thing. You can write it. All right, now I just want to print these values basically. So what I'll do is, yeah, now here's second row and second column. All right, so here what I'm doing is we are basically printing these values. Simple as that. All right, now there's some error. Let's check that. Yeah. All right, now let's click on this. As you can see, 1, 2 and 3. So basically these positions are getting printed. So this is an example of array of primitive types. All right, now let's move on to the other example, which is multi-dimensional array of objects. So now we'll do the example of multi-dimensional array of objects, where we will create a 2D array of strings, and we know what strings are, called names, with dimensions 2 cross 2. Now we will then assign names to different array of elements using the row and column indices. Then we will print the values of 2 elements of the array. Like here we did for the numbers. In this particular example that I'm gonna do, we'll do for the strings. All right, so let's do an example of array, multi-dimensional array of objects. All right, let's just remove this thing. Okay, so again, the data type would be string in this case, the capital S. All right, and the name of the string is names. New keyword, and then string, which is the data type, and this is basically the syntax. And now we have to specify the size of it. So 2 cross 2 basically we want. So here it goes. Now we are storing some elements inside it like we did previously. So at 0th column and 0th row we are storing the name, let's say John. All right, at 0th row and first column we are storing, let's say, Robin. Now I'm just gonna copy these things. I'm just gonna print again. All right, now at 0th, now let's say first row and 0th column. All right, I'm doing it. Okay, Sam. Then at first row and first column, here is Smith. All right, Smith with a capital S. All right, now what we're gonna do, we're simply printing this thing now. All right, system.out.println. Okay. All right, so let's say I want to print the name of Sam. So what I'm gonna do is, Sam is at this position at first row at 0th column. I'm just gonna print that thing. And now I want to print the position of, let's say, Robin. So tell me guys, what should I print over here? 0th row and first column. Simple as that. And now let's try to run it. So this particular output should print Sam. All right, and this particular print statement should print what we call Robin. All right, let's check whether it is working or not. So as you can see, Sam and Robin is printed. So this is a fine example of multi-dimensional array of objects. And now let's move on to the next example. Now the next example we have is multi-dimensional array of arrays basically. So in this particular example, we will create a 2D array where each element is another 1D array. The matrix variable is 2D array with dimensions 3 cross 3, where each row is a 1D array of integers. Now we will access and print the values of specific elements using the row and column indexes in this particular question. So it is again simple, and let's do this. All right. So yeah, let's remove this first. First we know the data type and then the name of the array. So we can do both ways, like this also we can do, and we can just put the brackets before also, so no worries. All right, then here let me do just this thing. Just using brackets as of now. All right, now inside these brackets, as I told you that we are basically here each element is another 1D array, and where the matrix variable is a 2D array with dimensions 3 cross 3. All right, so the elements gonna be storing like this, comma 2, comma 3. All right, now so this is basically the representation of this one, comma 5, comma 6. Let's just put spaces over here as well so that you can clearly see. 7, comma 8, comma 9. All right, now forgot to do this. All right, so basically this is the array that we told you. Now what we're gonna do, simply we will print the elements. Matrix at 0 position and at 0th row and 0th column. So basically this particular thing should print, tell me, 1. So just keep in mind this is 0, this is 1, and this is 2, position wise, indexes wise. All right, so as we know that in programming the counting starts from 0, so just keep that thing in mind, so don't get confused in that. All right, I'm just copying this thing again. I'm going to show you different elements now. Let's say first column, second position. Tell me what will be the output of this particular code, the second one. So here we want to print the element which is at first row and second column. Tell me what is the output of this particular situation. So the first row it is, and second column, so 0, 1, 2. So row is like this, 1, 2, 3, and the column is like this, 1, 2, and 3. So basically, let me tell you guys, this is first row and second column. So first row is this one, this is 0th row, this is first row, this is second row, and we want to print first row, second column. Now tell me what is the position at second column at first row. This is 0, 1, and 2. So basically 6. Here 6 will be printed. All right. Now let's say I want to print second row, first column element. Second row, first column. So tell me, this is the 0th row, this is the first row, this is the second row. All right. Now here we want to print second row, first column. This is the second row, first column is 7. No, tell me what is first column. This is the 0th column. We want to print the first column. So first one is 8. So yes, 8 will be printed. 0, 1, 2. Just keep in mind, the counting starts from 0, 1, 2. All right. Now let's print it. As you can see, 1, 6, 8 is getting printed. As simple as that. So this was an example of multidimensional array of arrays. Now let's move forward and have a look at some more examples so that you guys can practice these examples and understand this concept better. All right. All right. Now let's do another example of multi-dimensional array. Now here we will be doing a different example where I just want to show you the visual thing of it, and we will access particular elements out of it. So for that, I want you to imagine a library. Now this library has floors and each floor has shelves. On each shelf, there are books placed in specific positions. Now we are using 3D array in this particular example to represent this particular setup. Now the library is a 3D array think of it as a box containing smaller boxes, which we will refer here as floors. Now, that particular floors will contain even smaller boxes known as shelves, and those have books inside. Now, each book is represented by a string like book A1, book A2, like that. For those who don't understand, just go with me. Let's go with the flow, and I'll make you guys understand. Even if you don't understand, I'll just explain the complete question after just completing it. Okay, so no need to worry. All right, so let's start with this particular question. Now let's just remove this thing first. There we go. All right, now first of all, the data type, as we know, string. Something is wrong with the keyboard. All right, yeah, now string library. All right, so to mention it clearly, I'll just keep the thing like this. I'll just comment throughout so that you guys can understand what I'm writing. First of all, as we told you, floor. So this is floor 0 basically. All right, now over here, these are shelf number 0. All right, now for this, we'll store an element known as book A1. All right, and use comma for another element and use book A2. All right, so this is basically the shelf. Now let me just comment this thing for you guys so that you can understand it better. Shelf 0, this is again. So this is basically floor 0 from here to here, and this is the shelf 0th number. Now another shelf we will create over here. Let me just copy it. Now here we will write A3, let's say, yeah, A3, and here A4. This is shelf number 1. So this is floor complete, and inside floor there are shelves, as I told you earlier. Shelf 0, shelf 1. All right, okay, we don't need to use comma over here, we'll remove it. Now here we'll use for the other element or the other floor, I can say. All right, here again I'll mention floor 1. All right, now here again we'll do the same thing. Book B1 comma book B2 and shelf 0. All right, again I'll just copy this thing. So this is for you guys so that you can understand what I'm doing right now. B3, this is B4. This is floor 1 and it has two shelves, shelf 0 and shelf 1. All right, I hope you guys understand this thing. Again we'll remove the comma. All right, here we'll do, let's just keep it for floor 1 and 2 only. All right, now okay, let me just remove this. We'll keep it like this so that you guys will not confuse if I'll just elaborate it, all the things, make floor 3 4 like that. So I just don't want to do that. I just want you guys to understand this thing. All right, here we can just skip this thing. Okay, now there is a time to access these elements. So how are we going to do that? System dot out dot println. Now here inside it we'll write, let's print it something. Let's write book at, let's say I want to print element at floor 0 and let's say shelf 0 again and position 1. All right, let's say I want to print this particular element. All right, so what I'm gonna do here, the name of the array library, and this is floor 0, right? So we are using floor 1. Wait, something is wrong. Oh, we are using floor 0, so floor 0, shelf 0, position 1. All right, yeah.
position 1. Okay, let me just copy this thing. Book at floor 1, shelf 0, position 2. So floor 1, shelf 0, position 2. Let's see what it's gonna print. But right now it is showing some errors. Let's see. Alright, so there are some errors. String cannot match. Now let's run again. As you can see, it is printing book at floor 0, shelf 0, position 1 is book A2. And why it is not printing the second thing that I'm wanting? Index to out of bounds, length 2 at. Alright, let me just remove this, comment it out. Now let's check. Book at floor 0, shelf 0, position 1. Okay, book at floor 0, shelf 0, position 1. It is supposed to be book A2 and it is book A2. Okay, now let's do in this one only. Let's change it. Let's do 1, 0 and 2. Let's print it and check again. So here it is showing some error. Exception in thread main, index to out of bounds for length 2 at test. Index out of bound expression it is showing. So basically first, alright, so we can't use 2 as of now, is it? Because 0, 1 and position is only 1, 0 and 1. So we can't use 2, my bad. We have to use 1 only. And now let's print it. So yeah, book at floor 0. So just ignore this because we haven't changed this one. So here we want to print the element at floor 1 and shelf 0 and position 1. Floor 1, this is the floor, shelf 0, this is the shelf, and position 1, that is book B2. This is 0th position, this is 1st position, and book B2 is getting printed. So this is how you can do this particular question. This is basically the visual representation that I want to show, and this is how we can access it, and then we can do operations on it. So like that you can do. All right, now for those guys who don't understand it, let me just go through it again. So shelf 0 has basically, as you can see on the screen, shelf 0 has book A1 and book A2, shelf 1 has book A3 and A4, and then comes floor 1. Floor 1 has shelf 0 that has book B1 and B2, and then shelf 1 has book B3 and book B4. All right, now here we are basically accessing the things. All right, this particular code. To find a book, you need to specify which floor you are on, which shelf you are on, and which position the book occupies. Then only you can print it or access that particular element. For example, as we printed here, as you can see, we want to print this particular element. Then we will write the floor, the shelf, the position. So basically this is a 3D array kind of situation. All right, then we will go to the floor 1, then we'll look at shelf 0, and then we'll pick the book in position 1. Like that it goes. So I hope you guys understand it. If you guys haven't understood it, you can just comment down below and we'll sort your queries. Now let's go to another question. Let's move on to another question in which we will print the multiplication results of every combination of numbers from 1 to 5. Basically you can visualize it as a 1 to 5 columns and 1 to 5 rows. All right, so 1 to 5 vertically and 1 to 5 horizontally, and each position in the table holds the product of a row number and a column number, like 1 into 1, 1 into 2, 1 into 3, 1 into 4, 1 into 5, then 2 into 1, 2 into 2, 2 into 3. Like that it will go. The output is a multiplication table, the whole table showing these results. So we will be printing the whole table basically. All right, so let's do this. I hope you guys will understand this. So first of all, let's just remove this thing. All right, so first of all, this class main. Now we'll start with the name of the table, which is table. So this is the array name, and it is 5 cross 5 grid basically we want. All right, so we will be filling it now. So this is for the rows. For int I equals 0, I less than 5 I plus plus. Now for the column, we want int j equals 0, j less than 5, j plus plus. My bad. J less than 5, j plus plus. So basically this loop will loop through the rows and this loop will loop through the columns. All right. So this is how it is going. Keep it like this. All right. Now inside it, as we can see, we have to basically multiply the rows with columns one by one. So let me just write this thing first, then I'll make you understand. Okay, I plus 1 into, this is basically a logic, j plus 1. All right, so let me tell you guys what we are doing here is the formula, as we can see, I plus 1 into j plus 1. Here the formula is calculating the product of corresponding row and column. As I told you, it will be a 5 cross 5 grid. All right, so 5 columns and 5 rows, and we will be multiplying one by one each of them. All right, so this basically will calculate the product for the corresponding rows and columns. For example, here let's dry run it like I is 0 and j is 0 first of all. Then the table would be table 0, table 0 0, basically 0th row and 0th column. All right, then 0 plus 1 into 0 plus 1, which is 1. All right, so this will go like this. Then let's say if I is 1 here and j is 3, then it will become I plus 1, then it become, I repeat, then it will become 1 plus 1 into 3 plus 1, that is 2 into 4, that becomes 8. So this is how it is going. All right, now by the end of this step, the table array contains the multiplication table for numbers 1 to 5. All right, so this is what it is. Let me just go through this. Okay, so yeah, this is, we are out of the loop now. Now all we want to do is to print the table. Here we are doing the printing thing. All right, let me just mention. For this again, we have to loop through the rows and columns. So int I equals 0, I less than 5, I plus plus. Int j equals 0, j less than 5, j plus plus. All right, now system.out.println, here we will be printing the table I and j. Just we want to put some space in the end, so for that we will be using /t. All right, now here we are basically printing and we want to move to the next line, though system.out.println, because we want to move to the next line. All right, now I hope it will work. Let's see. It should print 5 cross 5 grid. It is not printing. It is printing the correct output, but not in a particular way that I wanted. Let me just have a look at it. What's wrong? System.out.println. No. So basically /t is not working. All right. Something is wrong with the print statement that I can see. This is also inside the print. All right, something is wrong with the print statement, as I told you. And so yeah, so basically here it is shifting it to the next line, which we don't want. For this particular thing, we have to write system.out.print. All right, now let's try. It should print. Yeah, as you can see, this is a 5 cross 5 grid. 1 2 3 4 5, 1 2 3 4 5, 2 into 2 4, 2 into 3 6, 2 into 4 8, 2 into 5 10. Then it should work similarly. 3 into 2 6, 3 3 is 9, 3 4 is 12, 3 5 is 15. So yeah, this is what we wanted to print and it is correct. So this is how you can also do the same example. If you are not able to do in the first place, just see the example and do again after understanding this particular problem. But I want you guys to do this examples and some more examples in order to grasp the concept in a better way. And that's a wrap on multi-dimensional arrays in Java. These powerful data structures are indispensable when it comes to organizing and manipulating data in a tabular or multi-layered format. From gaming and graphics to complex mathematical computations, their applications are vast and impactful. By now, you should have a solid understanding of how to work with 2D and 3D arrays, their structure, and their practical use cases. Now, I want you to practice some of these questions of multi-dimensional arrays. So go ahead and put this knowledge into action. So if you found this video helpful, don't forget to like, subscribe and hit the bell icon for more updates. Imagine building a program where every task is reusable and effortlessly maintainable. Sounds like a dream, right? That's exactly what methods in Java do. They help you break down your code into smaller reusable pieces, making everything more organized. The more complex your projects get, the harder it will be to manage without methods. Now, if you want to code smarter and avoid dealing with unnecessary problems down the line, learning methods is a must. It is again a very important concept that you will be using daily in your coding journey. So what are methods in Java? So in simple terms, methods in Java are reusable blocks of code that allows you to write specific set of instructions once and use them whenever needed, without repeating the same code in multiple places. You can also pass in data to a method called parameters, which it can use to perform a task. Now, methods help your code organized and efficient. By putting certain tasks into methods, you can easily reuse the same code in different parts of your program. This makes your code easier to manage and understand. If you need to change something, you just update the method, and that change will work everywhere the method is used. Now, this way, your code has fewer mistakes and is easier to fix or improve. Alright, so this was about the methods in Java. Now, let's have a look at how to declare the method in Java. Alright, so declaring a method in Java is simply telling the program what task the method will perform. Now, how to call it and what kind of information it might return. So its syntax is something like this, as we can see on the screen. First there is a return type, then the name of the method, which is method name, and after there's a parenthesis, and inside the parenthesis we can see in the block of code there's a method body. Alright, now let me explain to you guys what is a return type, what is a method name, and what is a method body basically. So first let's understand return type. So this tells the program what type of result the method will give back after it finishes running. For example, if the method calculates a number, the return type might be int for an integer. If the method doesn't return any value, the return type is void, meaning it just performs an action without giving anything back. I hope you guys understood this. Now, next is method name. So the method name is simply the name you give to your method. It is what you use to call the method when you want to run it. It's up to you. You can name it anything. Now then there is method body. So the method body is actually a block of code inside the method. This is where you define what the method will do step by step. It's like the instructions the method follows when it's called. So you basically write the code inside it. Alright. So this was about declaring a method in Java. Now let's understand calling a method in Java. Now, calling a method in Java is simply telling the program to run specific method that has already been defined. When you call a method, you are asking the program to execute the instructions inside that method. So when you call a method, you use its name followed by the parenthesis. And if the method needs input data, that is parameters, you pass them inside the parenthesis. Now, if the method returns something, it can be stored in a variable or used directly. For example, as we can see, method name. So basically method name is the name of the function over here and we are calling this function. Method call, as we can see on the screen, is being held. So when we write the name of the function with parenthesis, we will call the block of function, the method, actual method. This is how you call it. Now let's understand this with the help of an example. Alright, now coming to method return type. So in Java, the return type of a method is the type of the value the method gives back after it completes its task. When a method finishes its job, it can return a result like a number, text, or any other data type. The return type tells Java what kind of data to expect when the method is done. So as you can see on the screen, there is a return type, method name, method body, and return value. Now, if the return type is not void, then we will use other int and all. So basically the return value, let me tell you about it. So if the method has a return type other than void, you must use the return keyword to send the result back. If the return type is void, you don't need a return statement. Alright, just keep in mind, if the return type of the method is void, you don't need to return a statement. But if the method has a return type other than void, you must use the return type to send the result back. Alright, so this was about the method return type. Now let's understand about the method parameters. So method parameters in Java are like the values that a method accepts when it is called. These parameters allow the method to work with data that you provide. Now, a method can have any number of parameters, which means you can pass in as many values as needed for the method to do its job. Now, each parameter acts like a placeholder for the data that the method will use when it's called. For example, if a method is meant to add two numbers, you would pass those two numbers as parameters to the function. Alright, so let me explain to you guys with the help of an example. But first, let's see the syntax of it. As we can see on the screen, there's a return type. After that, there's a method name, then type 1, parameter 1, then type 2, parameter 2. So basically, parameter 1 and parameter 2 are the values that is being passed from the calling function, and here we are passing it. So basically, this is the receiver part. It will receive those values, and then we will perform the addition, subtraction, multiplication, whatsoever we want with those two values in the method body. So basically this is basically the syntax of it, and type 1 and type 2 are the data type of those values that is being passed to this method. Alright, so now here we will be doing an example in which I'll showcase you how to invoke or call a function, and similarly we will understand how to make a function or a method. So method and function is one and the same thing for the guys who don't know about it. So let's start with it. First of all, here what we'll do is we'll basically make a simple example. I'll show you a basic example so that you guys can grab what I'm telling you. So static void main, show status. So basically here we are just creating the name of the function. So static void main, void is used because we are not returning any integer value. So that is why, and show status is the name of the function. And inside here, this will be the method body. For as of now, I have commented it so that you guys can understand. But later we will be writing the method body. First of all, we need to understand how to invoke it. So for that, we will be going to the main function, public static void main, we know. Now inside this function, we will be calling this particular function. As I already told you how to invoke or call a method, it is simple. Just write the name of the function, show status with this bracket, and this is how you call a function. Alright, we can also pass some values that we will cover in the further tutorial of this. But as of now, I'm just telling you, if you want to call a particular function and execute the code inside it, simply you'll have to do like this, the name of the function and this brackets, that's it. Alright, so this is basically calling this particular function. So now whatever the code we will write inside the method body, that particular code will be executed and it is printed. As simple as that. Alright, so let's display something. So here we'll write, because here is show status, so it is asking for the status. So system is up, we'll tell the status, and running. So whatsoever you want to display, we can do that. And this invocation will call this function and this function will execute it. As simple as that. So as you can see on the screen, system is up and running. So here in the main method, we have called the show status function, and inside the show status function, this particular thing we are displaying. System is up and running, so it is displayed. Simple as that. I hope you guys understood what I'm trying to say. So this is basically, you can call or invoke a function. Alright, now let's do another example. So here we will be doing an example in which we'll pass some values to a function, and that particular function will do an operation over those values. Alright, so that particular operation can be addition, subtraction, multiplication, division, anything. It's up to you. So here we'll be doing a simple addition so that you guys can understand what I'm trying to do. So as you can see on the screen, public static class main is there. Now first of all, let's start with the main function this time. After that, we'll create the method or function. Alright, so first of all, we'll be creating the main function. Now inside this main function, we will basically, first of all, we will call that particular function. So let's say I want to name that particular function as add numbers. So this is the invocation. And if I want to pass the values inside it, for example, I'm passing 55 and 75. Alright, so basically I want to add these two numbers or values. Alright, so I'll create a function or method for this. So now what I have to do is I have to store this particular thing into a variable. Why? Because then only we will be able to display that, because we want to display the output, right? So for that, system.out.println. Now inside this, first of all, we'll write, to make it look good, the sum is, and then the variable name, which is sum. So the result of this will be stored in sum, and then sum is being displayed. That's it. Alright. Now how to add it? That particular code we will write it in the method that we will create. So as we know, the name of the function is add numbers. So simply we'll do that, static. But this time we'll be using int because integer values are there. So we have to use int instead of void. Add numbers. Now int is the data type because 55 is an integer, and we'll refer here as x. So basically x and y we will refer here because these values are sent here one by one. So this will act as a container. These variables x and y will act as a container for these two values. It will store these values and then we can do the operations on them. Alright, now inside it we'll return x plus y. Alright, so now what we are doing is we have sent these two values to this particular functions, 55 to x and 75 to y, and then we are simply doing the addition of these two. After addition, we are returning this to this again, and then this thing is being stored at sum. Then what we are doing is we are simply displaying it. I hope you guys understand it. Then let's try to run it. So there's an error as we can see on the screen. We have to use semicolon. Again, let's try to run it. The sum is 130. So 55 plus 75 equals 130. So it is correct. Now again, for those who don't understand what I've just did. So basically this is the main function and this is the method. Alright. Let me just comment this thing out. This is the method. This is the function call or method call. And we are passing values 55 and 75 to the method. So here we are calling this particular method and we are also passing 55 and 75, and then we want to add them. So we have written x plus y and then we have returned it. So after doing the addition, it will return the value here, and now the value is being stored in sum. As you can see, the value is being assigned to sum, and then we simply displayed sum. So this is what it is being displayed. As simple as that. You can also do the what we call multiplication It's up to you. 55 into 75, 4125. You can also do division, everything, anything you want, you can do that. All right. Now let's do another example. So this time we'll do some other example. Now here again, first of all, public static void main function will create first. All right. Now inside this main function, first of all, we will call a particular function. So let's say I want to name a particular function as display person info. All right. So display person info. Now inside this, I'll be passing some string values this time. All right. So I'm passing Alice, and this is the city Alice is living in. And yeah, let's keep it this way only. Again, let's just copy it. For example, let's say I want to store 3 values in it. I want to pass 3 values in that particular function, and we'll name it as Sam lives in Texas and Charlie lives in Chicago. All right, so these 3 are values. These 3 values are the values that we want to pass to this particular function. And all right, static void display info. Now question must be in your mind that why we have used this void. So basically in this particular function we don't want to return anything, we simply want to display that. As you can see, we are not displaying here, we will be displaying in this particular function itself. So we don't have to use the data type. All right. Now the thing is, we are passing 2 values, that is Alice New York, Sam Texas, Charlie Chicago. So here also we have to write the parameters to itself, like the name, the data type of the parameter, that is string, and then the what we call the placeholder or the variable name, and then another one would be string and city. All right. So the first value, which is Alice, will go to the name, and New York will go to the city. Similarly, Sam, Texas, Charlie, Chicago, like that only it will go. Now inside this body, where we'll be writing the logic, we'll simply display it. All right. So what we will be doing here, so first we'll write name, and we'll write lives in, because I want to write it like Alice lives in New York, Sam lives in Texas, like that. Then city. So what we are doing is, first of all, name will be displayed, that is Alice. Then this is the thing that we want to display, lives in. Then the name of the city. All right. Now let's try to run this. All right. So we did something wrong. Yeah. Now let's try to run it. So as you can see, Alice lives in, so we must specify some space also. So let's do this. I hope this time it is clear. Yes. So as you can see, Alice lives in New York, Sam lives in Texas, Charlie lives in Chicago. So first these 2 values are being passed, Alice and New York, and we are simply displaying this. So here comes the Alice lives in, then comes the New York. Then in the second call, we are passing Sam and Texas. So the second time Sam lives in Texas will be printed. And in the third calling, Charlie and Chicago is passed. So similarly, those 2 values are being printed. So as you can see, all these 3 values are being printed like this. I hope you guys understand how to declare a function and how to do the function call. This is pretty much the basic of it, and you have to do some more examples on it. But start slow and do many examples, as many examples as you can, then only you'll be able to grasp the things. Doing a topic theoretically is a different thing, but if you'll not do any examples or questions on that, it will be waste. You have to do some practical examples, then only you'll get to know, then only your brain muscle will develop how to tackle these kind of problems.
And pretty much this was the very basic thing that I just told you. Now I want you to implement all these things and practice at least 10 to 20 questions, not in a single day, but over a span of a time. All right. So these are the two examples. I hope you guys understand it.
Alright, so now let's have a look at some of the advantages of methods in Java. Alright, so let's start with the first one, which is code reusability. Now you can write a method once and use it multiple times. This reduces the need to repeat the code. Second advantage is better organization. Methods help to break your program into smaller manageable parts. Each method can handle a specific task, making the code easier to understand. Then there is easier maintenance. If you need to change something in your program, you only need to update the relevant method. This makes fixing errors or adding new features simpler. Then there is improved readability. By giving methods clear and meaningful names, your program becomes easier to read and understand for others or for yourself later. Alright, now next advantage is avoiding redundancy. Now instead of writing the same logic multiple times, you can call the same method whenever needed. This reduces the duplication and makes the program cleaner. Alright, then there is modularity. Methods make your program modular, meaning you can focus on one part at a time without affecting the rest of the code. Now, ease of teasing. Since methods handle specific tasks, you can test each method separately to make sure it works correctly. And at last, we have encapsulation. Methods can keep certain parts of your code private, allowing you to control how other parts of the program access or modify the data. So these were the advantages of methods in Java. Now to sum up, methods in Java are like small blocks of code that helps you organize and reuse your work. They let you break your program into smaller parts, making it easier to understand and manage. We learned how to declare methods, call them, and work with return types and parameters. These are important basics that every Java programmer should know to create neat and effective programs. Now, from here, your work starts. The internet is filled with many practice questions. Pick this topic and start practicing methods in Java, and you will see how useful they are in making your coding journey smoother and more fun. Also, if you have any doubt, feel free to write in the comment section below. That's it for today's video. So keep learning and make sure to like this video and subscribe if it helps you. Ever wondered how some developers keep their code so clean and efficient even as projects get bigger? So one of the key tricks is method overloading in Java. This concept is essential because it allows you to simplify your code. Interviewers love to ask about it because it tests your understanding of how Java handles flexibility and efficiency in coding. So if you want to impress your interviewer and show that you are a good developer, you need to understand method overloading. And today we are going to help you master it. So what is method overloading? So method overloading in Java refers to defining multiple methods with same name in the same class but with different method signatures. The method signature includes the number of parameters, type of parameters, and the order of parameters. This allows you to perform similar actions using the same method name but with different inputs. Now the main advantage of method overloading is that it allows multiple versions of a method to exist under the same name, handling various input cases in a clear and organized way. The Java compiler decides which method to execute based on the method signatures, that is the method name and its parameters at compile time. Alright, as you can see on the screen, display A with a single parameter and display the function display A comma B which has the two parameters. So this is method overloading. Now we will definitely understand it in detail in the further tutorial in this one only. But before that, we need to understand why method overloading. So to understand this, imagine you are developing a shopping application for an online store where customers can add items to their shopping cart in different ways. So some customers add an item by providing just the product ID. Others specify the product ID along with the quantity. And some might even want to include details like product ID, quantity, and special instructions like color or size. Now, without method overloading, you would have to create multiple methods for each case. For example, add to cart by ID, add to cart by ID and quantity, and add to cart by ID, quantity, and details. Now, this approach makes the code more complex and harder to manage. Although the methods perform the same function, adding items to cart. They have different names, leading to redundancy and confusion. You can definitely do that, but this approach is not the best approach. With method overloading, you can define a single method, add to cart, and overload it to handle different input scenarios. Java automatically chooses the right method based on the number and type of arguments passed. For example, add to cart product ID, and then the function name would be same, but the number of parameters would be different. For example, in the first case there is product ID, in the second function it is product ID and quantity. So the difference between these two functions is the number of parameters. In the first function there is only one parameter, that is a product ID. In the second function there are two parameters, that is product ID and quantity. Alright, in the third function again the function name is same, but now product ID, quantity and special details. So this approach keeps the code clean, reduces the duplication and improves the readability. It allows you to use a single meaningful method name for various sections, making your program more efficient and easier to maintain. In essence, method overloading provides flexibility by enabling different variations of an action under common function name, while letting the code adapt to different user inputs. Here we are letting the code to adapt to different user inputs, because in the first case we use product ID, in the second case we use different parameters, that is product ID and quantity, and so for the third case. So we are making the function capable of doing that. So it is a better approach of doing that. This is called method overloading. Now, how to implement method overloading in Java? Alright, so let's understand this. Now, method overloading in Java is implemented by creating multiple methods with same name but different parameter lists. Now, the key to method overloading is that these methods must differ in the number, type or order of parameters. Here are the main ways to implement method overloading. For example, first one is by changing the number of parameters, then by changing data type of parameters, and by changing order of parameters. Alright, so let's just go ahead and understand each one of them. So basically you can achieve method overloading by all three of these steps, but it's up to you. Now we will understand each of this method overloading steps, how you can achieve that. For example, the first one is by changing the number of parameters. So method overloading by changing the number of parameters. Alright, now you can overload a method by defining multiple versions that accept a different number of arguments. For example, one version of a method might take one parameter and another might take two parameters. Alright, now as you can see on the screen is a basic syntax to make you guys understand what I'm trying to say here. So basically, first display function and the second display function. There are two display functions as you can see on the screen. So first one is taking only one input, that is only one parameter, and the second function is taking two parameters, that is int a and int b. Alright, so this is what we are trying to do. So we are basically overloading this function or a method by defining its multiple versions. So we are defining multiple versions of display and we are just changing the number of arguments here. Alright, the number of parameters or the number of arguments. Alright, so this is how you can achieve the method overloading. You can perform this, as we already discussed. This is the better approach of doing that rather than making every single function for everything. This is a better approach of it. So this is how you can achieve method overloading, by changing the number of parameters. Alright, now let's understand this part in more detail with the help of a fine example. Alright, so let's do an example of method overloading by changing the number of parameters. Alright, so first of all, as we know that we have to we'll start with creating the main function and then we'll create the different functions with the same name. Alright, so first of all, let's start with the main function, public static void main. Now inside this we have to write string, we know the drill, right? String arguments. Alright, so here first of all we'll have to create what we call an object, and from that object we will call the methods. Alright, so the name main, which is the class name, and obj, this is the object name, new keyword, then main. That's it. So this is how we create an object. Now using the object name,
we will call the functions. So whatever we will write after obj, that is, we'll write the function name and then we'll simply call them. Also, we'll pass the arguments. So before that, uh, before calling it, let's create the name of the functions, right? That is the main thing that we want to cover first. All right, so the name, let's name it public static, no, public void show. The name of the function is show, and yeah, let's keep it this way as of now. And the second function again, we'll have to create the same public void show. All right, now here, using the name of the object, we will call a function and pass an argument. So in this particular function, that is the first function, we'll be passing a single argument. So we have wrote only one parameter, that is int a variable a with an int value. All right, in the second one, we'll be passing two parameters, int a and int b. All right, now here, as you can see, let me just write it like this: obj dot show. Here we'll be passing two values. So basically, this particular call will call this particular function, and this particular call will call the second function, because here there are two parameters. All right, so this method with one parameter will be called when we will execute this particular thing. All right, and we will overload this method with two parameters when we'll call this particular function. All right, because here obviously if we'll call this particular function, this will not be executed because here is only one argument. So basically we are overloading this one method with two parameters. All right, so let me write it for you. This function calls method with one parameter, and this particular function, all right. Okay, now let's write down in between the what we call the code body. So let's do that. Sum.out.println. All right, here we'll write number. All right, we are simply printing it. So here there are two numbers. So instead of number, we'll write numbers. We want to display numbers and then the numbers we want to display. So this is how we'll do it. Okay, now let's try to run this. I hope it works. So as you can see on the screen, number 10 and numbers 10, 20. So as I already told you that this particular function, this call method is calling this particular method with one parameter, and this particular call is overloading this method with two parameters. Now if we'll, let's comment it out. All right, now if we'll execute this, what do you think what will be displayed? Obviously number 10 and 20, because we're passing this particular arguments, the number of arguments, the number of parameters. So obviously it will choose the function having two arguments or parameters. All right, so it will not choose this one because here only one parameter is there. So I hope you guys understand what I'm trying to say. This is how you can do method overloading. This is one way of doing it. All right, now let's understand the next part.
Alright, now coming to the second part, that is method overloading by changing the data type of parameters. As its name is suggesting, in this particular case, we will change the data type of parameters rather than the number of parameters. So it's another way to implement method overloading. It's like the changing the data type, that is whether it is string, int or double. So by changing the data type of parameters, Methods can be overloaded by having the same name but handling different types of inputs. All right. So as we can see on the screen, we have made another function, two functions actually, show and show, same name. But in the first case, the parameter data type is int, that is integer. So it is accepting the integer value only. And the second function is accepting the string value only. All right, although the function looks same in terms of the name of the function and the number of parameters of the function, but the data type of parameters are different. Now if we will pass, for example, let's suppose we'll call a function show. All right, we'll make a show function call. So in that particular function, if we'll pass 5, so what do you think which function will be called? You can just comment down below. But let me tell you guys, if you call the function show and pass a integer value, that is 5, then it will automatically go to the first show function, which is accepting the integer value. Similarly, if you'll call show function and pass a the name of somebody, like let's say Sam, which is a string value, if you pass that, then automatically this will go to the second function, not the first function, because now the second function is the only one which is accepting the string value. So as simple as that. So we are basically changing the data type of parameter and we are achieving the method overloading. All right. So this is how you can do that. Now let's understand it in more detail with the help of an example.
All right, public static void main. All right, so now inside this main function again, we know the drill. First of all, we'll create a object main obj new keyword main. All right, now here we'll be calling the same thing will happen here as well, but this time we'll be changing the parameters. Basically, we will overload a method with a different parameter. So as we know, in the previous example, we did it by changing the number of parameters. Here we'll do it by the changing the data type of parameters. So one function will have a different data type and another function will have a different data type. All right. So as you can see on the screen, I have written the main function. Now I'll be creating the function or method. Public void show here int a system.out.println. All right, so here we'll write this time integer, okay, and we'll display it. And another function will create. Let's just copy paste it. And this time here, instead of integer, we'll be writing it as, let's say, double. Okay, so this particular value will be of double type and this particular value will be of integer type. Okay, simple as that. So basically we will overload this method with double parameter. All right, so this method is with int parameter and we will overload this method with double parameter. Now using the name of the object obj.show, and we'll pass the arguments. So 10 is passed, then obj.show again. Now here we'll pass 10.7, let's say. So it is a double, so we can pass the decimal value. It's fine. And yeah, let's try to run this program now. No, but let's change this thing. Double. All right, now let's try to run this. All right, so as you can see, integer 10 and double 10.7 is being printed. So I hope you guys understand it. Here we are overloading this particular function by changing the double parameter. If we'll comment it out this part, then automatically it chooses this only because it is accepting the value which is of double type, and it is not, this function is not accepting the value which is of double type. So automatically this call will be received by this particular function. I can show you as well. See for yourself, 10.7 is being printed because this particular call, here we are passing a value which is of double type, and automatically this function is the one which is accepting the value of double type and not this function. So the call will go to this function itself, all right, which is basically accepting the value. All right, so I hope you guys understand this part as well. Now moving on to the next part, which is by changing the order of parameters.
All right, now third is method overloading by changing the order of parameters. All right, so we have already discussed the number of parameters by changing the number of parameters and by changing the data type of parameters. So this is the third one. Now if the methods accepts multiple parameters of different types, the order of these parameters can be changed to achieve the method overloading. Now in this particular case, we will not change the number of parameters, we will not change the data type of parameters, but only the order of parameters. For example, a function is there which is accepting an integer value, and the second one again is a string value. All we have to do is to just change their order. Like, we'll just switch it, that's it, as you can see on the screen. So it's a fine example. Calculate function, two calculate function we have. So first one is int a double b. It is accepting two values, one of integer value and another one is double value. All right, their data type basically. And the second function is accepting double value and second is integer value. All right. Now if we will make a call to a function calculate and pass 5 comma 7.8, then what do you think which function will be called? Tell me. So basically, if we'll call this calculate function and we'll pass two parameters, that is 5 and 7.8, then automatically the first function will be called, because first function is accepting the integer value at the first place and the double value at the second place. As simple as that. We will not make it complex. Similarly, if we'll call the calculate function and pass the decimal point value, like for example 35.2 and 7, all right, then it will automatically go to the second function, because in this particular case the first value is of decimal type and the second value is of integer type. I hope you guys understand. So this is how we are just changing the order of it, and still we can do the method overloading. Now let's do an example of this one as well.
All right, so we are back. Now let's do an example of by changing the order of parameters. So here, if the method accepts multiple parameters of different types, the order of these parameters can be changed. Simple as that. All right. So it is not a different thing, but I hope you guys understood with the help of example that is being showed on your screen. But let's do an example here as well. Now again, we'll create the main function. All right, public static void main. All right, now again the object will create main, that is the class name, object name, new keyword and main, like this. So we have created the object. Now using this object we'll be calling the functions, as we know, as we already did, but this time the distinction is that we'll change the order, not the number of parameters. The number of parameters will be same, the data type of the parameters will be same, only the order of parameters will be different. For example, first in a first function, first there is integer and next it is double. All right, but in the second function, first there is double and second parameter is integer. So in this way we'll do it. Let's have a look at it. So public void show. All right, now inside this we'll pass, what should we pass, like integer a and let's say string b. Okay, so these two values are being passed. Now system dot out dot print ln. Now inside it we'll pass numbers, number only, number and a text. We'll write something like that. Okay, so we'll write, yeah, here we'll write text. All right, now similarly we'll just copy this function, but this time string will be here, string b and integer a will be here. So basically what we did, we basically changed the order. Here as we can see, integer a is first and string is b, but here string b is first and integer a is at the second number. Basically we have changed the order of it, that's it, nothing else. Okay, now but here also we'll have to do the same. Here we'll write text and after text we'll write b and here we'll write number and here we'll write a. Okay, now coming to the main function where we will be calling these functions obj.show. So wait, yeah, all right, but this time we'll be calling the second function first. So we'll write b, which is a string value. So string value can be, let's say simple world, and then the integer value will be passing. Okay, so integer value can be 50. Okay, so first let's just run this program. So what do you think, guys? This particular call which function will execute by this particular call? Tell me. You can comment down below. Alright, so let's run it and figure it out. So as you can see on the screen, text world number 50. Alright, so this particular function is being executed. And why? Because this particular function is accepting string value first and then the integer value. So it's like that. But if we'll reverse it, for example, if we'll make it 50 and write world or anything, then this particular function will be executed. Why? Because here integer is first and here is also integer first and string is second and here is also string second. So it will go to the particular function which is having the same order as we are passing it. I hope you guys understand this point. So let's run this so that you can understand it better. Number 50 text world. All right, I hope you guys are understanding what I'm trying to show you. Obj dot show. Now first function will be executed and second function will be executed. As you can see, number 50 text world number 50, as simple as that. So this is how you can achieve method overloading by changing the order of parameters. All right, I hope you guys understand this.
Alright folks, that's a wrap on method overloading in Java. In this video, we have covered what is method overloading, why method overloading, and how to implement method overloading in Java with hands-on examples. Now, if you have got any questions, drop a comment and we will be happy to help. And hey, don't forget to like, share and subscribe for more career insights. If you are preparing for Java interviews or trying to level up your problem-solving skills, recursion in Java is unavoidable. It is one of those topics that interviewers love throwing at you, not just to test your knowledge but to see how you think. Whether it's working with trees, solving puzzles, or breaking down complex problems, recursion shows up everywhere, which makes it a very important concept in Java. And yeah, it can be tricky, but once you get it, it feels like magic. Trust me, if you want to ace those interviews or handle advanced coding challenges, learning recursion is very important. Alright, so let's first understand what is recursion. Recursion is when a function calls itself to solve a problem. It keeps breaking the problem into smaller parts until it reaches a point where it doesn't need to call itself anymore. This point is called the base case. Now, think of it like this. The function handles a small part of the task and asks itself to handle the next smaller part over and over until it finishes. In programming, it works the same way. Let's say you want to solve a problem like calculating the factorial of a number. Factorial of 5 is 5 into 4 into 3 into 2 into 1. We all know that. Now, instead of multiplying all the numbers at once, you break it down. You know that the factorial of 5 is just 5 times the factorial of 4. That is 5 into 4 factorial. Add the factorial of 4 is just 4 times the factorial of 3. That is 4 into 3 factorial. Then this pattern continues until you reach the base case. The factorial of 1, which is just 1. Alright, so this is how we proceed with the factorial. For those who don't understand what is factorial. Alright, so the function calls itself with smaller version of the problem until it gets to the simplest case. Alright, so this was about recursion. I hope you guys understood it. If not, then we'll definitely cover in this lecture. So you'll get to know. Alright, now time to understand how it works basically. So how recursion works. Recursion is a way in programming where a function solves a problem by calling itself. It repeats this process until it reaches a point where it doesn't need to call itself anymore, known as the base case. So as you can see on the screen, first there is a function call and then there is a recursive call that is being implemented to that particular function. And we'll definitely cover this in the coming tutorial. We'll do some examples on it as well. Alright, now let's take a Fibonacci sequence as an example to make it more clearer. The Fibonacci sequence is a series of number where f0 equal to 0. This is the first base case if we'll consider f of 0. Then f of 1 is the second base case. After that, each number is the sum of the two numbers before it. That is, fn equals to fn minus 1 plus fn minus 2. Alright, if we use recursion to calculate Fibonacci numbers, the function will keep calling itself for fn minus 1 and fn minus 2 until it gets to either f of 0 or f of 1. These two base cases stop the recursion because their answers are already known. To understand its working, better consider a scenario. Imagine you need to find your car keys because you are running late for an important meeting. Now you remember that your keys are inside one of your drawers, but when you open the drawer, you find several smaller boxes stacked inside. Now inside each of these boxes might be more boxes and one of them contains the key. Now at this point, you have two options. You could open every box at once, which is overwhelming, or you could approach it step by step, systematically open one box at a time. Now, this is where recursion comes in. To solve this problem, you decide that every time you open a box, you will check whether it contains another box or the key. If it's just the another box, you will open the one next. You keep doing this, digging deeper and deeper into the boxes until finally reach a box that has no more boxes inside, just your car key. So this is your base case, the smallest, simplest problem. Once you find the key, you don't need to keep opening the boxes. Instead, you return the key, closing each box your way back out, just like how a recursive function would return its values. The key idea here is that recursion breaks down the big problem into smaller problems, and each step takes you closer to the base case.
Alright, so this is our compiler. So let's do a simple example of recursion so that you guys can understand. Here we'll be doing an example of factorial, and so that you can also understand, because factorial is a very basic example of it and one of the best example to understand recursion. So let's start with creating a function, public static int factorial. We have named this function as factorial. It's up to you whatever you want to name it. So yeah, I have named it factorial, and this particular function will be receiving a value n. Alright, so this factorial function will be receiving a value n, and whatever the code inside it will definitely do that. But let's first do the main function also, because it is also a crucial part of this particular function. Alright, so let's remove this. Now first of all, we'll define a variable and assign a particular number to it. For example, we want to do the factorial of 5. So here 5 we have assigned to it. You can also take input from the user, but I'm just considering 5 is the number of which I want to do factorial of. Now we have specified the number directly in the code. Now we have to check if the number is non-negative, because we can't do factorial of a number which is negative. So for that we have to put in a condition. All right, now if num is less than, just a second, num is less than 0, then we have to print something. System dot out, just a second guys, system dot out dot print ln. Alright, system.out.println. Here we'll be displaying a simple message saying that factorial of a number. Factorial is not defined for negative numbers. Alright, simple as that. Okay, now if the number is non-negative, for that we'll use the else condition. Alright, system.println. So here we'll write factorial of num. Okay, so as we know that the factorial this function is there. So here we'll be calling this particular function and we'll be passing this value to it, which is num. So basically what we are doing is we are basically calling this function factorial here, and we are passing a value that is num, and this function is receiving this value over here, and then we'll perform the factorial logic over there. Alright, now we have passed this. If the number is non-negative, of course 5 is non-negative, we'll pass 5 here, and now we'll be writing the logic about it. Now if n equals 0, for this also we have to write for this particular condition. If the value which is being passed is 0, then we will simply return 1, because we know the factorial of what we call 0 is 1. So factorial of 0 is 1. So this is basically a base case. Okay, so base case for you guys, I should write base case factorial of 0 is 1. Alright, so if 0 factorial equals to 1, so if the value is 0, so we'll simply return 1. Alright, now in the else part, what we'll do is, the main game is here, we'll return n into factorial of n minus 1, because we know here n is 5 and n minus 1 is 4. Alright, so what we are doing is 5 into 4, and we know that factorial goes like 5 into 4 into 3 into 2 into 1. So one number is less. But now the question is how it is going to 5, then 4, then 3, how it is iterating. So we are basically doing the recursive call to the factorial function again and again, again and again. So as you can see, this is a factorial call to this function itself. Alright, till it will keep on calling this function till it becomes equal to 0. This is the base case. Alright, so basically this is a recursive case, and let me write so that you guys can understand. Let me comment this thing. We are basically doing here 5 into 4. Alright, then this 4 will be passed here and 4 is not equal to 0, so it will again come to the else condition. Then it becomes 4 into factorial of n minus 1, that is 4 into factorial of 4 minus 1, which is equals to 3. Then this will go here like that, then it will become 5 into 4 into 3, then 3 is not equals to 0, then again 3 will come, 3 into 3 minus 1 equals to 2, then 2 goes here, like that it will go. I hope you guys are understanding, like this. Alright, now also this is the what we call the recursive case. This is the base case where the particular recursion will stop, and this is the recursive case where it will keep on calling the same function until this particular condition is met. Simple as that. Alright, now these things we already mentioned, that if the number is less than 0, then simply we'll display a particular message that number can't be 0. You can't do a factorial of a number which is 0. Then here is the else block where we are just calling that if number is not negative, then it will simply display and call this factorial num. We are passing this num here. We have passed 5 as we know, 5, and then this whole thing works. I hope you guys are understanding what I'm trying to say. So basically the factorial of a number means multiplying that number by every number smaller than it down to 1. For example, if I'm doing the factorial of 6, then what I'm doing is I'm multiplying that number by every number that is smaller than that. For example, 6 into 5 into 4 into 3 into 2 into 1, like that. Now in this particular case we are doing the factorial of 5, so it will go 5 into 4 into 3 into 2 into 1, which is equal to 120. So I hope this particular question will give, I repeat, so I hope this particular example will give us 120. Let's check. So there is some error over here. Alright, as you can see, factorial of 5 equals to 120. So it is displaying this factorial of num is the number which we are passing, factorial of 5, and this is what we passed, and the result is coming back here. So it is displaying like this, 120 comes back here because we are returning it. And the base condition, till the base condition is met, the product of this all these are equal to 120. So it is displaying like this. I hope you guys understand this. Now I want you to try this same example on your own so that you can also understand and practice it. But do try this example because it is a very important and a basic example, and it is necessary for you to practice this particular example because it's a very important step in learning recursion.
Alright, now let's talk about the definition and characteristics of recursion in Java. So here are the key points about recursion in Java. First is self-referential. This means the method calls itself. So the method repeats the process again and again, but each time with a slightly smaller or simpler part of the problem. Second is base condition. This is super important. Every recursive method needs a point where it stops calling itself. This is called the base condition, and it prevents the method from running forever. When the method hits the condition, it returns a result instead of calling itself again. Third is divide and conquer. Now, recursion works by breaking the problem into smaller chunks. It handles each small part and then combines the solution to solve the overall problem. This makes solving complex problems easier. Then there is stack-based execution. When a method calls itself, Java keeps track of each call using something called a stack. Every time the method calls itself, a new stack layer is added. Once the method finishes or hits the base condition, the layer gets removed one by one, starting from the last one. Then there is memory sensitive. Now, since each recursive call creates a new layer on the stack, recursion can use a lot of memory. If there are many calls, that is, too many recursive calls, can even cause memory problems, which is something to watch out for. So, these were the characteristics of recursion in Java. Alright. Now, so recursion basically in Java helps to solve by breaking the problem into smaller parts, but it also requires careful control to avoid memory issues. Alright. Now, we will discuss some of the best practices for using recursion in Java programming. Now, here are some best practices for using recursion in Java. First one is define a clear base case. Make sure every recursive function has a clear base condition. This prevents the method from running forever and ensures that it eventually returns a result. Then there is progress towards a base condition. Each time the function calls itself, it should get closer to the base condition. This means that with each step, the problem becomes smaller or simpler, so the function eventually stops calling itself. Then there is avoid unnecessary recursive calls. Try not to make extra recursive calls that aren't needed, as this can slow down the program. If possible, use techniques like memoization, that is storing the results to avoid repeated calculations, or tail recursion, that we will be discussing further, to make the code faster. Alright. Then there is test and validate. Always test your recursive functions thoroughly to make sure they work as expected. Recursive code can be tricky, so testing helps catch many mistakes. Use the right data structure. Now, choosing the right data structure like arrays, lists, or trees can make your recursive algorithms more efficient and easier to manage. They help keep track of the data in a way that fits the problem you are solving. Now, by following these tips, you can write recursion that is clear, efficient, and safe from common problems. Alright, now let's understand what is the base condition in recursion. So in recursion, the base condition is what stops the function from calling itself over and over again. It is like safety switch that prevents the function from running forever. Without it, the function would keep repeating, leading to an error called stack overflow. The base condition is usually set up as an if statement in the condition. When this condition is met, the function returns a value and stops making further recursive calls. For example, in factorial function, the base condition is n == 0. When this is met, the function returns 1, halting the recursion. Without a base condition, the recursive function would keep calling itself indefinitely, resulting in a stack overflow error. So I hope you guys have understood about the base condition in recursion by looking at this example also. Now let's understand the difference between a recursion and iteration. Alright. So first of all, we will be covering each point of this based on the things. For example, the first point would be approach. So in recursion, this solves a problem by breaking it into smaller parts, and functions calls itself to solve each smaller part. Whereas in iteration, it solves a problem by using loops like for loop or while loop, which repeatedly execute a block of code until a certain condition is met. Now we will differentiate between them on the basis of code complexity. In recursion, the code is usually shorter and easier to read because it expresses the solution in a clean, natural way. But it might make more time to fully understand if you're not used to thinking recursively. Whereas in iteration, the code can be longer and requires more steps like manually updating and tracking variables. It can look more complex but is often easier for beginners to follow. Then there is performance. Recursive function can be slower because every time the function calls itself, it adds an extra overhead, like a new function calls in. If there are too many recursive calls, it can even lead to errors like stack overflow. Whereas in iteration, Iterative loops tend to run faster because they don't need to create new function calls. They are generally more efficient in terms of both time and space. Alright, now talking about recursion in terms of memory usage. Each recursive call creates a new stack frame, that is a memory slot where the function details are stored. If there are too many calls, the memory can fill up quickly. Whereas in iteration, loops are used to set amount of memory because only the loop variable need to be stored. This makes iterative solutions generally use less memory than the recursive ones. Now, talking about the tailed recursion. This is a special kind of recursion where the recursive call is the last thing the function does. And talking about iteration, some programming languages can automatically turn tail recursive functions into loops behind the scenes, which avoids the memory problem. However, Java doesn't optimize tail recursion like other languages do. So these were some of the differences between the recursion and iteration. Now let's have a look at the difference between the tailed and non-tailed recursion. So first one is tailed recursion. So in tail recursion, the last thing the function does is calling itself again. The function doesn't need to do any more work after that call. It just makes the call and returns the result right away. Because there's nothing left to do after the call, some programming languages can make this process more efficient by avoiding using extra memory. Now let's talk about non-tailed recursion. In non-tailed recursion, the function still calls itself, but it has to do something else after that call. This means the function can't return the result right away. It has to hold on to the previous steps, which uses more memory. And if the function keeps calling itself too many times, it can run out of memory and cause an error. So these were the differences between the tailed and non-tailed recursion. Now let's discuss the advantages and disadvantages of recursion. First up, we have our advantages of recursion. So recursion are easier to solve complex problems. Recursion helps break down tough problems into smaller, easier pieces, making it simpler to handle and understand. And it is reusable code. Once you write a recursive function, you can use it in different parts of your program without writing it again. This makes your code more flexible and reusable. Then cleaner and shorter code. Recursive functions often look shorter and cleaner, which makes them easier to read, understand, and maintain in the long run. Cleaner and shorter code. Recursive functions often look shorter and cleaner, which makes them easier to read, understand, and maintain in the long run. Then works well for certain problems. Some problems naturally fit with recursion, like working with things that have repeating patterns, like trees or lists. Recursion makes solving these types of problems straightforward and efficient. So these were the advantages of recursion. Now moving on to the disadvantages. First is slower performance. Recursive functions can take more time and memory compared to using loops, that is the iteration. Each time a recursive call calls itself, it uses extra resources. Alright. Second is stack overflow errors. Now if a recursive function keeps calling itself too many times, it can run out of memory, causing a stack overflow error. This happens when the program tries to store too many function calls in memory. Third point is hard to understand. For beginners, recursion can be tricky to learn and understand because it involves thinking about functions calling themselves. Fourth is less efficient. Recursive solutions often use memory and may take longer to run that using loop, which are usually more efficient. Alright, so these were the disadvantages of recursion. Now let's do a simple example of recursion so that you guys can understand.
Alright, now let's do example in which we will basically do the sum of array elements. Alright, so in this particular example, we will be calculating the sum of all the elements in an array. So we have the list of numbers. Using recursion, we'll be adding all the numbers. Alright. So first of all, we'll start with we'll create first of all the main function itself, then we'll be creating the function in which we'll be doing the logic thing. Alright, so public static void main. Now let's define array, and let's say this array has 1, 2, 3, 4, 5. Keep it like basic only so that you can understand. So basically this is an input. You can also scan it. You can take the input, but I'm just declaring it as of now. Int result, because we'll be storing the result in this particular variable. So I've declared a variable and I'm storing the function call in it, and then I'll simply display this. All right. So some function where we'll be passing some values. We'll keep it like this as of now. Now system.out.println. Now here, first of all, we'll write a message. Sum of the array elements is, and then result, in which we have stored the solution, the answer of it. All right. Now we'll create a function down. As you can see on the screen, we'll be creating a function now. So basically, the name of the function would be anything we want. Like, it's up to us. Like, we can name it sum also. So we'll make a recursive method to calculate the sum of array. So let's name it as sum only. Public static and sum. Now this particular function will be receiving an array and a variable. All right. Now basically this particular variable is the size of it, the what we call the number of elements inside it. All right. And this is the array itself. All right. Now if the size is 0, that is if size is 0, then it means there are no elements inside the array, because size is equal to number of elements. If size is 0, that means there are no elements inside the array. In that particular case, we'll simply return 0. So it is the base case here, because base case, if the condition, this particular condition is met, that means there are no elements left in the array and the code will break and the answer will be displayed. All right. So obviously we have 1 2 3 4 5 elements over here, and it is not 0. So basically this condition will not met in the first case, but yeah, when it will make the recursive calls, then after a certain period it will, this condition is met and will be less than equal to 0. So in that particular condition the answer will be displayed. All right, so this is the base case. So let me write again so that you can understand. This is the base case here. Now here we'll, in the else block, now in the else block what we'll do is we'll return another thing which is called array of n-1. I'll explain it to you guys, don't worry. Array comma n-1. Okay, so here what we are doing is this is basically the recursive call. So what we are doing is this is the number we have passed the size of the array. It is not less than equal to 0. Then less than that number, like let's say there are 5. So here array 4 plus sum of array 4. So again this is the part which is making the recursive call, and we are basically adding this particular element of the array. Now array of 4, this would be 0 1 2 3 4. All right, 0 1 2 3 4. 4, this is the 5 basically, because we are going index wise. So we'll start with 0 1 2 3 4. At index 4 we have 5. So what we are doing is 5 plus recursive call. In recursive call, we are passing the whole array and 5. Again, this will go, it will become 4. So in that particular case, at index 3 we have is 4, the element 4. So similarly, it will keep on iterating. For those who are not understanding right now, don't worry. Let me run this code and I'll explain to you guys again. So no need to worry. For as of now, you can understand this particular else has the recursive case, and this is basically the base case. All right. Now let's first of all, yeah, here we have to call this particular function also, because earlier we didn't. So what we passed here, we basically passed array and the size of array. All right. So simply the name of the array is array comma the array length, which is the size. All right, so array length and array we have passed successfully. Now we are supposed to display the answer of this particular function. So let's do that first and then I'll explain to you. So sum of array elements is 15. That is 1 plus 2 3 plus 3 6 plus 4 10 plus 5 15, which is the correct answer. Now let me again explain this particular example to you guys. Here we are basically calculating the sum of all the elements of the array. All right, using a concept called recursion. Now this array has 5 numbers. We will pass the array and its size. As you can see, we will pass the array and its size to the sum function. This is the sum function. We are basically calling the sum function and we're passing the array and its size. All right. Now the sum function is like asking you, like, what's the sum of the first n numbers in the array? Now base condition over here, it's stopping condition basically. It is if there are no more numbers left, that is if n is equal to 0, we return 0. This means we have added up everything. Alright. Now coming to the recursive step. Now it means if there are still numbers left, like if n is still greater than 0, we do two things. First, add the last number in the current part of the array, that is array n minus 1. And then we will call the sum function again, but this time for the first n minus 1 number, excluding the last one. This repeats until there are no numbers left, and then the results of all these smaller additions are combined. So basically 1 by 1, 5 plus 4 plus 3 plus 2, like 5 plus 4, then 9 plus 3, like that we are doing over here. All right. So I hope you guys understand this. If you're not, then please do try these examples on your own, because when you try, you get to know many things that theoretically you will not. So I want you to try both examples that I just did so that you can also understand. All right.
So that's recursion, powerful, challenging, and absolutely essential for every programmer. It is one of those concepts that might seem intimidating at first, but once you understand it, it opens the doors to solving wide range of problems. So in this video, we understood what is recursion in Java, how does recursion work, and definition and characteristics of recursion in Java, and the base condition in recursion. Then we understood how a particular problem is solved using recursion, and the difference between recursion and iteration, and much more things with hands-on examples. Now, if you have got any questions, drop a comment and we will be able to help you. And hey, don't forget to like, share and subscribe for more career insights. Programming is all about solving problems and building solutions. But as project grows larger and more complex, managing them can become challenging. That's where object-oriented programming comes in. OOP is a powerful paradigm that helps organize and structure code. To understand it, imagine you're designing a car. Every part is like the engine, tires, and seats has its own job but works together to make the car run smoothly. Now, if you decide to upgrade the engine or add a sunroof, you don't have to rebuild the entire car. You just focus on the part that needs changing. So that's exactly how OOPs work. It lets you split the big problem into smaller pieces so you can reuse, update, or improve your code without starting from the scratch. So in this video, we will discuss various concepts of OOPs. We will start with understanding inheritance in Java. After that, we will cover polymorphism in Java. And then we will learn about encapsulation. And at last, we will understand abstraction. Classes and objects are already covered. So we will cover all these concepts in OOPs and their types with hands-on examples. Now, before we begin, make sure to subscribe to the channel and hit the bell icon to never miss any update. So now, without any further ado, let's start with the first concept, which is object-oriented programming in Java. So OOP is based on 4 fundamental principles that form the foundation of its structure and design. These principles provide a framework for creating modular, reusable, and maintainable code. So these 4 principles are inheritance, polymorphism, encapsulation, and abstraction. Alright, now let's move on and understand these concepts one by one. So first one is inheritance. Inheritance in Java is a mechanism where a new class called the child class acquires the properties and behaviors of an existing class known as the parent class. Now in simple terms, inheritance allows one class to reuse the code from another class. The child class can also add its own unique properties and behaviors or modify the inherited ones. For example, imagine you have a class that represents a generic animal. Now, if you want to create a class for specific animals like a dog or a cat, instead of writing all the properties and methods from scratch, you can inherit those properties and methods from the generic animal class, which is the parent of both these classes.
So inheritance. Inheritance in Java is a mechanism where a new class called the child class or subclass acquires the properties and behaviors of an existing class called the parent. You can also call parent class a superclass. Now in simple terms, inheritance allows one class to reuse the code from another class. The child class can also add its own unique properties and behaviors to modify the inherited ones. You can assume it as a child which inherits properties from its parents, for example car, scooty, bikes and houses also. So that child is inheriting the property from its parent. It is similar to that. To put it in easy words, I can say imagine you have a class that represents a generic animal. Now, if you want to create a class of specific animals like dog or a cat, instead of writing all the properties and methods from scratch, you can inherit those properties and methods from the generic animal class, which is the parent class of both. All right. Now, the question is how to use inheritance in Java. So, here's how the inheritance works in Java. Firstly, you have to focus on the parent class. So, this is the class that will be inherited from. It's like a general class that has common features. All right. Then comes the child class. So this child class inherits the features of the parent class, as I told you. Now the child class can add more features or change existing ones. For example, you're a child of your parent. Now you inherit the scooty or car from your parents, right? But you can also buy your scooty or bikes or cars. So that property is yours and your parent property is also yours. So that's what we are talking about right now. So the child class is inheriting the properties of its parent class, plus the child class can add more properties and features or change the existing ones. All right. Now, to make one class inherit from another class in Java, we use the extend keyword. So, as you can see on the screen, mammal is the parent class and dog is the child class. And this extend keyword is used when we make we have to show that this is the parent class and this is inheriting the property of the parent class. For example, to make one class inherit from another, for example dog is inheriting the properties of mammal, so we use dog extends mammal, like that. All right, this is the basic syntax of it. So in this example, the dog class is created by inheriting the properties and behavior of the mammal class. Here, dog is the child class and mammal is the parent class, as I just told you. All right. Now, I hope you guys understand this. So let's do a fine example of inheritance so that you guys can understand it better. And I want you guys, after just having a look at the example, I just want you to practice it. If not along with me, then after this complete video. But it would be great if you can, practice along with it. So yeah, we will do some hands-on example now. So let's do it. All right, so now let's do a hands-on example. Here we will be doing an example of inheritance in Java. All right, so let's start with a class. We will make a class vehicle. Now in this class, we will make some, properties. For example, in properties, we can, declare some variables, right? And some functions also. So let's do that. String, let's say model. All right. So this is a variable that we declared, public void drive. All right. So, all right. This is a function basically, and we want to print something inside it. So what should we print? So I can drive. This is what we want to print. So we have created a variable model and we have defined a function drive. In that function, we are just displaying a message saying I can drive. That's it. So this is what all is inside the vehicle class. Now let's move on to the next class, which is the child class of this vehicle class, that is class car extends. This is the syntax of it. We have vehicle. So car is the child class and it is extending vehicle. So vehicle is the parent class. All right. Now inside this one, again, we will make another function. Public void, let's say we'll write it show details. All right. Now inside this function, we will display the model, right? System.out.println, right? My model is this model. So this variable is this one only. All right. So that you guys know, don't get confused. I'm just telling you right now. All right. Now this is the second class, which is the child class. All right. Now comes the main function. Sorry, the main class. Inside the main class, we will be creating the main function. Public static void main, right? String arguments. Now, first of all, here we will be creating an object of child class, and using that object, we will be assigning some values to the parent class properties. All right. So basically, this is the child class. Okay.
and this is the parent class. And just now I told you that this child class is extending the parent class, so it basically inherits all the properties of the parent class, right? So using the object of this child class, we will be accessing the properties of this one, which will show us that it inherits the properties of the parent class. All right, it will prove that thing basically. So car, let's name this is sedan, the object name. The class name is there, then the object name. So we are making an object of car class. All right, so car is the child class as I told you. Just a second. Yeah, car is the child class, and we have made an object of car class. Now using this object, sedan is the object name, we will be assigning some value to the variable model. All right, so this is how we can do it. Sedan, let's say 2000. Let's name it this. All right, now using this object only, we will be calling the function. All right, so now just keep in mind that we are not using the parent class object, we are using the child class object, and then we are changing the value of the parent class variable. Why? Because we can do that because it inherits all these things, all these variables, this function both. So then only we can do that, otherwise we can't do that, right? All right, now sedan dot drive, this is the function of the parent class, as you can see, sedan dot drive. All right, so this is the of the child class itself, so you don't need to think much about it, but this is the parent class. So I'm just showing that using the object of the child class, you can access the members of parent class. So now let's try to run this. I hope it works. There are some errors. Let's have a look at them. Yeah, the spelling mistake, static void main. Yeah, let's see. Just a second. Duplicate class. Okay, so we have to just delete these because these are having the similar examples. So maybe that's why it is showing some errors. Let me just delete them and let's have a look at it whether it will work. Now it's working fine. So it is displaying my model is sedan 2000, which we wanted. My model is, and then this model is being, we are just assigning a value over here, and this thing sedan dot show details is basically printing this thing. All right, and this sedan dot drive is printing this parent class parent function message. All right, so what we are doing is we simply made the object of child class, and using that object we assigned a value sedan 2000 to this particular variable, right? Now this variable previously we haven't assigned anything to it, so using the object of child class we assigned a value basically a name, sedan 2000. All right, the car's name. Then using this object only, we displayed this thing. See, sedan dot show details, we displayed model is, so it is displaying my model is sedan 2000. Then using this object, the child object only, we called the parent class function, which is drive. As you can see, parent class function drive, and it is displaying the message I can drive, and here you can see I can drive. So this basically shows what I'm trying to show you. All right, so yeah, this was about inheritance. I hope you guys understood it. If you have any doubt regarding this example, you can definitely let me know. So basically, this example that I just showed you highlights how inheritance allows the car class to reuse and extend the functionality of the vehicle class. All right, vehicle is the parent, car is the child, right? Now moving on to the next topic. All right, now talking about types of inheritance. So there are different types of inheritance, each serving different purposes in code reuse and organization. So let's start with the first one, which is single inheritance. Now in single inheritance, a class can inherit from only one superclass. Superclass means parent class, all right? This is the simplest form of inheritance where the child class inherits all the features, that is fields and methods, from the parent class. You can take an example, just the example that we just did, it was a single inheritance only. All right, that was a fine example of single inheritance. So it is like only one class is inheriting property from its parent class, it is known as the single inheritance. All right, now let me show you with a example. All right, so
let's do an example. So this is the example of single inheritance for those who don't understand. So basically, single inheritance inherits from only one superclass. Superclass is known as the parent class, as I just told you. So this is the superclass vehicle, and this is the car, that is the child class. And basically, it is inheriting the properties of the vehicle class. For example, as you can see, it is trying to display model, which is a variable from the parent class. So if the car class is not a child of parent class, that is, if car class is not a child of vehicle class, then it can't display model, right? But now, because of the car class is the child of parent class, that is the vehicle class, that's why only it can display that. Although we haven't assigned any value to model yet, that is why it can't display anything. But it's just an example to make you guys understand what I'm trying to say right now. All right. So this is a basic example of single inheritance. Here, car inherits from vehicle. The car class has access to the drive method and model field from the vehicle. All right. So basically, yeah, that is it. All right. Now let's move on to the next inheritance, next type of inheritance, that is multi-level inheritance. All right, now multi-level inheritance. So in multi-level inheritance, a class inherits from a subclass, which in turn inherits from another class, forming a chain. It allows multiple levels of inheritance. As you can see on the screen, class C, class B, and class A. So basically, one class is inheriting properties from another class, and that class is inheriting properties from its parent class. Like, it's like a relationship between a grandfather and a grandchild. So the, money in terms of capital, the cars, the property which a grandfather has gained throughout his life will pass down to his parent, and the parent, the properties that he has gained will pass down to its child. So basically, class C has all the excess of class B properties and class A properties as well, and class B will have all the properties of class A. I hope you guys understand, it's basic only. Now, basically, as you can see, it is forming a chain kind of a pattern. So that's what we are talking about. So let me just show you how it looks in Java code. All right. All right. So as we can see on the screen, this is it. This is basically the multi-level inheritance. Here, the vehicle class is the parent class and car is the child class. So it is inheriting the properties. Now, electric car is the child class of car class. All right. So it is inheriting the properties of this class also. Plus, it will have the access of this class as well. All right. So basically, vehicle and this electric car has the relationship as that of grandfather and the grandchild. Simple as that. All right. Basically, this electric car inherits from car, which in turn inherits from vehicle. So electric car has access to all the methods and fields from both car and vehicle. Okay. I hope you guys understand what I'm trying to say. Now let's move on to the next inheritance, which is multiple inheritance. All right. Now coming to the multiple inheritance. So in multiple inheritance, a class can inherit from more than one class. However, in many programming languages like this in Java, multiple inheritance is not directly allowed with classes due to ambiguity issues. Instead, you can achieve multiple inheritance using interfaces. All right. So let me tell you what interface is, how it would look like on the Java screen. Then I'll tell you whole thing about interface and all. All right. So this is an example of interface. As we can see on the screen, interface drivable. This is the function. Then this is a class. Again, this is class. Now the thing is, in interface we can't use extends, but we use implements. All right. So this is an example of multiple inheritance. Now we know that in Java, multiple inheritance is not directly allowed with classes due to ambiguity issues. So we use interfaces. And basically, for interfaces, we don't use extends, but implements is what we basically use. Now, here in this example, as you can see, electric car implements two interfaces, that is drivable and chargeable. So it must provide implementation for all the methods declared in both the interfaces. This allows electric car to inherit behaviors from multiple sources. All right. So basically in Java you can't do that, but some other languages you can do that. In Java you have to use interface, and for interface you use implements. And you can do like this. All right. Now, now there's a question there must be in your mind that why we can't do that in this one in Java. And what is interface basically? We have to know. So, all right. So basically, interface in Java is like a blueprint for a class. So it defines what methods a class should have, but it doesn't provide the actual code for those methods. Now, instead, the class can that uses implements the interface must provide the code. All right. Now, think of an interface as a set of rules that different classes must follow. So basically, it helps in avoiding the ambiguity in multiple inheritance. So that is why we use it. Now Java basically doesn't allow multiple inheritance. That is, class cannot inherit from two classes because it can cause confusion. Example, if two parent class have the same method, the child class wouldn't know which one to use, right? Now instead of multiple inheritance, Java allows a class to implement multiple interfaces. So this allows confusion because interfaces don't provide method implementations, just method names they provide. All right. So this is the reason why we use interface. Now coming to the next inheritance, which is hierarchical inheritance. All right. Now the hierarchical inheritance. So in this inheritance, multiple classes inherit from a single class. Now several subclasses can extend the same parent and share its properties and methods. All right. Now have let's have a look at this example of hierarchical inheritance. All right, so as you can see on the screen, this is a fine example of hierarchical inheritance. Both car and truck inherit from the same vehicle class. They both can use the drive method and model field from vehicle. All right, so as you can see on the screen, this car is extending the vehicle, which means the car is the child class and vehicle is the parent class. And further, truck is extending from the vehicle class again. That means both car and truck have the same parent class, that is vehicle. Now, to make you guys understand, they both can use the drive method and model field, that is model variable, from the vehicle. So they both have the access. It is you can take an example of a parent who has two child, right? So both have the properties of the parent class. All right. For example, you and your brother is inheriting properties from your father. It is simple as that. All right. So this was about the hierarchical inheritance. All right. Now coming to the next one, which is hybrid inheritance. So in hybrid inheritance, it occurs when a class inherits from more than one base class using a combination of multiple inheritance and multi-level inheritance, or you can say hierarchical inheritance also. This is generally more complex and can lead to ambiguity issues, especially in languages that don't directly support multiple inheritance. And that is Java, obviously. Now, I know this is a bit complex, but yeah, it is a mix of all the inheritance you can say, that is multiple, multi-level, and hierarchical. So let's understand this one with the help of a fine example. All right, so as you can see on the screen, this is a fine example. So first there is a drivable interface, then class vehicle is there, and then this car class extending the vehicle and implements the drivable. So here basically the car inherits from vehicle and implements the drivable. This can be considered a hybrid form of inheritance as it combines interfaces and inheritance and class interface. All right, so I know this is a bit complex than the other interfaces, other inheritance, but this is not usually the thing that is being asked. But yeah, you must know about it because maybe in the future you can do that, right? You have to deal with it. So let me, for those who don't understand, so basically this is the, as you can see, drivable interface requires the drive method, and the vehicle class already has a drive method. Since car inherits from vehicle, it already gets the drive method from vehicle. Now the interface drivable is not adding any extra value here. Now the car class overrides, as you can see, the car class overrides the drive method from a vehicle. Even though drivable is implemented, it doesn't change anything since drive was already present. All right, so this is there. Now drivable basically ensures that any class implementing it must define drive, making the interface useful. For those who don't understand still, you can go through the example once again. So to put it in easy words, car inherits from vehicle and implements drivable. This can be considered a hybrid form of inheritance as it combines interface, inheritance, and class inheritance. All right. So, yeah, you have to go through it again. so that you can grasp it in a better way. All right. So this was about inheritance. These were some types of inheritance that you must know, and I want you to practice the examples of it as well. Now let's move on to the next topic, which is polymorphism. All right, so polymorphism, the term polymorphism comes from the Greek word poly, which means many, and morph means form. So, in context of object oriented programming, polymorphism refers to the ability of a single method or object, or you can say operator, to take one or many different forms. To basically take different forms, right? So, in Java, polymorphisms allow objects of different classes to be treated as objects of a common superclass. It allows for a single inheritance or method to be used for different underlying forms. Now, to put it in easy words, imagine polymorphism is like giving the same command to different things. For example, you are telling different animals to make a sound. When you say to a dog, it barks like a woof. When you say to a cat, it meows, right? And when you say to a bird, it makes a sound of tweet. Now, even though you are giving the same instructions like make a sound, each animal is responding in its own unique way. So, in programming, polymorphism works the same way. You can use the same method name, like make a sound, for different objects like dog, cat, and bird, and each object knows what to do based on its type. All right, so let's understand polymorphism with a fine example. So here we will be doing a hands-on example of polymorphism so that you guys can understand it in a better way. So here, first of all, we will be creating a parent class which is vehicle, and then we will create a child class, and then we'll create another child class. All right, and then we will use the child classes to display some messages. All right, so let's do that. First of all, let's start with the parent class, which is class vehicle. All right, now inside this class we will be making a method or a function. All right, now we will be displaying a message, so we'll write system.out.println. So here, let's say I want to write displaying a vehicle. All right, so let's put some dots over here. Okay, energy saver mode. All right, displaying a vehicle, this is what we want to display inside this particular function, and this is the class vehicle, which is the parent class. All right, now let's create another class which is car, and this is the child class of vehicle class, so it will extend vehicle class. All right, this is the syntax. Now here also the same function would be there, that is public void show. Now in all the three classes we will be making the same function, okay, because I want to show something to you guys. Polymorphism. Okay, now system.out.println. Now here we'll write displaying a car. Okay, displaying a car, like that. So this is a car class. Now class bike. This will also extend the parent class, which is vehicle. So both bike and car class is the child class of vehicle class. Okay. Now here also the same function will make. Let me just copy paste it so that I'll save some time. All right, public void show. As we can see, we have wrote it, and by mistake I'm using capital P. P in public should be of lowercase. All right. So we have created three classes, and inside those three classes we have made three functions or methods, each of same name. All right. Now inside the main class, that is class main, we will call the functions basically. Okay. So we'll write, let me just create some space. Yeah. Public void main string arguments. Now inside this main class, we will create an object of car class and we'll name it my car. Okay, new car. So this is how we create an object. Now using this particular object, we will be calling a function. And as we know, all the function is same. The name of all the functions is same. So how can, which function should it pick to show, right? So that is the question right now. All right, now we will be making an object of bike class. The name of this object is my bike, new bike. All right, now using this my bike class, sorry, object, we will again call a function. Now, what do you think if we will call a function show that is common in all the three classes? Using the object of car class, which function should it display? And I'm asking this question for my bike object also. You guys can take your time for that.
Just have a look at the whole code. This is a vehicle class, this is a car class, and this is a bike class. So I want you guys to just write down the question, answer of the question that I've just asked. What do you think? So I hope you guys take your time. Now let me just tell you that here the show function, the show method or function, whatsoever it is. So here the show function is behaving differently in different classes. All right. So when we will run it, let me just show you. So there is some error. Yeah, else should be capital. Now let's try to run this. So as we can see here, main method not found. Main method not found. It is there only. Alright, so it is displaying now. So I missed the static word over here. So as you can see, displaying a car here also it is saying displaying a car because by mistake we wrote like this. Now we'll run. So we have used the object of car class and we called using the object of car class, so that is why it is displaying the car class method. All right, and when we use the object of the bike class, it is running the function of bike class. So this is basically an example you can think of polymorphism. So the thing is, polymorphism happens when you use a parent class reference to refer to child class objects. Now, same method show behaves differently depending on the object, right? When we use car, it displays something else. When we use bike, it displays something else. So the method is same, but it is behaving differently depending on the object. Now, the vehicle reference, that is vehicle class, is the parent class of both these classes. All right. Now, when with polymorphism, basically you can create a method that works for all the vehicle types without knowing whether it's a car, bike, or any future vehicle. So this is a fine example of polymorphism. All right. Now let's move on. All right. So here we go. Now let's have a look at the types of polymorphism. One is compile time polymorphism and runtime polymorphism. So compile time polymorphism occurs when the method to be called is determined at compile time. It is also known as method overloading. This happens when two or more methods in the same class have the same name but different parameter lists. The Java compiler determines which method to invoke based on different method signatures. Overloading can occur within the same class without the need for a parent-child relationship. Now, in runtime polymorphism occurs when the method to be called is determined at runtime. It is also known as a method overriding. This happens when a subclass provides a specific implementation for a method that already is defined in its superclass. So runtime polymorphism depends on the parent-child relationships. A subclass overrides a method of its superclass, and the overridden method is invoked using a superclass reference pointing to a subclass object. Now, polymorphism can be achieved through three ways basically. First is method overriding, method overloading, and then the operator overloading. So the first one is method overriding we'll start with. So method overriding occurs when a subclass provides a specific implementation for a method that is already defined in its parent class. This basically allows the subclass to define its own version of method, and the method that gets called is determined at runtime based on the object type. So the example that we did kind of similarizes with this method overriding. Now, method overriding occurs when a subclass redefines the in the parent class with the same name and return type and the parameters. Now, this is the foundation of runtime polymorphism, and the method call is resolved at the runtime. All right. Now, let's have a look at its example. So here only we'll do the example of method overriding. All right. So class animal. All right. So class animal is there. Now, inside this one, we have made an object void public sound. Now here we will be displaying a message system.out.println. Animal makes a sound. All right. Now class dog extends animal. Now here again the same method will make public void sound. Dog barks. Okay. Class main public static void main. All right. So here we are basically making an object of animal class. I hope you guys are understanding what I'm doing right now because the same thing I'm doing that I've done previously. Animal, my dog. So using the same class, we have created two different objects. All right. So sorry, my bad. Here it will come dog. All right. So Now after this, what we'll do is using this method, my animal, we will call this sound function, and my dog again we'll call the function. Now let's try to run this. Animal makes a sound, dog barks. As you can see, we have used the object name and those particular functions are only printing. So basically what I want you guys to just understand what I've just done. Just have a look at it, and if there is any doubt, you can just ping in the comment section and we'll resolve your queries. Just have a look at it once. Now I hope you guys have gone through this example. Now for those who haven't understand it yet, now basically animal class is the parent class. It has method sound that has that prints animal makes a sound. Now dog class inherits from animal using the extends animal, and it overrides the sound method. So instead of animal makes a sound, it prints dog barks. Now we have to understand the main method also. My animal is normal animal object. So calling my animal dot sound runs the animal class method. And my dog is a reference of type animal but actually holds a dog object. Alright. So wait. This thing I've done wrong. Yeah. Now as we can see, animal makes a sound, animal makes a sound. This is the correct one. So basically my animal is a normal animal object. So my animal dot sound runs the animal class method, right? Which is correct. Now my dog is a reference of type animal, but actually holds a dog object. So this is the thing, like animal, my dog is a reference of type animal, but actually holds a dog object. When calling my dog dot sound, Java dynamically determines the method from the actual dog at runtime. This is called dynamic method dispatch. All right. Now this my animal dot sound basically is an animal object, so it calls sounds from animal. So the output is animal makes a sound. Whereas my dog dot sound, even though my dog is declared as an animal, it actually points to the dog object. So since dog overrides sound, Java executes the overridden method from dog. So that is why the dog barks will be displayed. All right. So basically, dog provides its own version of sound, replacing the animal's version. All right. So yeah, that is it. Now let's have a look at the next topic, which is the next topic is method overloading. Yeah, pretty famous, right? Now, method overloading occurs when multiple methods with the same name are defined within a class, but they have different parameter lists. Now, different number of types, basically, different parameter list means different number or different types of parameters. Now, the method to be invoked is determined at compile time based on the method's signature. Now, key points to remember: method overloading allows multiple methods with the same name but different parameters. This is a form of compile time polymorphism because method resolution happens at compile time, not runtime. The method signature must differ in the number or type of parameters. Alright, so now let's understand it with the help of an example. Alright, here only we'll do the example of this one, overloading basically. Yeah, method overloading. So first of all, we'll be creating a calculator parent object, and basically we'll be creating two classes only, that is the calculator, and then we will create a main class and we'll do the method overloading. Basically we don't have to create child classes for that. Class calculator, this is a function public int add, where we want two variables or values, return its sum. Okay, now we will be creating another function and add with the same name, but this time the number of parameters would be different. So this time there are three parameters, as we can see, and here also we'll do the sum of these, plus b plus c. All right, so now again, but this time we'll do different data type. Now this time we have used the double data type. Previously we were using int data types. This time we have used double data type. Now in this add function, what we are going to do is double a comma double b, then return a plus b. All right, so this is the function calculator. Now here we can see we have inside this class calculator, we have created three functions and with different parameters, and one is having different data type. All right, now in this public main, this class main, we will first of all create the main class, main function, like static void. Alright, so inside this, first of all, we'll be creating a calculator object using the calculator class name. Calculator calc is the object name. The spelling mistake. Okay, so this is it. Now wait. Now here system.out.println. We are basically passing these two parameters, right? So now we will, understand which function will be invoked. So that is what we are going to do here. Let me just copy paste this function. Now we know double is of decimal point value, so that is why 2.5, 3.5 we are passing. So what do you think? Now you can again comment down. What do you think of this particular question? What this will display and what this will display and what this will display. You guys can take your time. These are the functions. Tell me. All right. So basically, as we can see on the screen, where we are passing two values. So this particular function call will automatically go to this particular function. All right. Why? Because we are passing two values, 2 and 3. It can't go over here. So this is decided at runtime. Sorry, it is decided at compile time. All right. So whenever we pass, you know, two parameters to a function, it will automatically decide the function which is having two parameters instead of three parameters, because we know that all the three functions have the same name, but they are having different types of parameters and number of parameters, right? So this particular function 2 and 3 will go over here. Second function will go over here and third function will go over here. So let's print it. There is some error. Calculated class one cannot be applied to given types. Okay, just a second. Oh, by mistake we have just wrote 0 in between. Yeah, let's remove it. So as you can see, 2 plus 3 5, 2 plus 3 5 plus 4 9, 2.5 plus 3.5 equals 6. So this is what we are displaying right now, but don't think that we have written it serial wise, that is why it is happening. Even if I'll just remove it and keep it here. Now also if we'll display it, then it will also give us the same output, but in a different format. As we know, 2 plus 3 equals to, it will go to this first function only. Now this function will go to third function. Don't think if we have called it here so it will go to the second function. No, 2.5 3.5 is of data type double, so it will fetch the function, it will call the function of double data type itself. Similarly, this function is having three parameters, so it will look for the function which is having three parameters and it will display there itself. All right, so this is how it goes. The method that is called is determined by the compiler, hence it is also known as compile time polymorphism. All right, so this was about method overloading. Now let's understand method over operator overloading now. So here comes the operator overloading. Operator overloading refers to the ability to redefine the behavior of operators for user-defined types, such as classes. For example, in some programming languages like C++ or Python, you can redefine how operators like plus, minus, multiplication, etc. work for objects of a class. However, Java doesn't support operator overloading. In Java, you cannot define custom behavior for operators. The operators are predefined to work only for primitive types like int, double, etc. and standard classes. So yeah, this was about operator overloading. Now let's understand Java encapsulation, which is another important concept of OOPS. So encapsulation is a way of protecting the data inside an object by hiding it from the outside world. Now, instead of allowing direct access to an object data, you use methods to read and update that data. This helps to keep the data safe and ensure it is used correctly. Now, basically, what it does is basically hides the data. The data inside an object called the fields and properties is usually kept private, meaning no one can directly change it. Then it uses methods. To interact with data, we create public methods like functions that allow controlled access to the data. These are often called getter and setter methods. So getter method retrieve or read the data. Setter method modify or write the data in a controlled way. So if you want to access the private members, basically getter and setter method is used. Getter is basically used for reading the data, and setter method is used for setting or writing the data. All right. So as the name is also suggesting. Now, the control access, by using methods, you can add checks and rules like ensuring that data is always valid. So the object behaves in a safe way.
Now, to put encapsulation in easy words, think of encapsulation like a capsule or a box that keeps things safe and organized. Now, imagine you have a box with a lock, and inside the box, you keep some important items like your money or personal documents. You control who can access the box by deciding who gets the key. Now, if someone wants to use the items inside, they have to ask you, and you decide if it's okay. Now, in programming, encapsulation works the same way. A class keeps its data safe and private. If someone wants to access or change that data, they can only do using specific methods like getter or setter.
All right. So these three things are there, like hide the data, use methods, and control access is also the third point that I want to highlight. So yeah. All right. So now let's do an example of encapsulation. So let's move on. All right. So here we will be doing an example of encapsulation now. All right. So what we'll do is basically we'll create a car class, and then inside that class we'll create some functions, and then from the main function we'll be calling those functions. Okay. So I hope you guys understand what I'm trying to say right now. And so basically I hope you know the definition of it, right? So private members, we will access some of the private members using the setter and getter methods. All right. So let's start now. First of all, let's create a class car. Now here, first of all, we'll create a variable, but that variable would be private. We'll make the access modifier as private and speed. All right, so this is a private variable. No external entity can access it. All right, now, all right, we'll create a function over here, public int get speed, because we will be accessing this function, this particular variable, eventually with the help of setter or getter methods, setter and getter methods, and for that we'll be creating a function get speed. All right, my bad. Yeah, return speed. Yeah. So basically, this is a getter method. All right. Now after this, just did. Yeah. Sorry, my bad. So this is a getter method. So now let's create another function inside this class only. So this function you can call it as a setter method also. Public void set speed. Okay. This is the name of it, and there's a parameter and speed. Now if speed is greater than equal to 0, wait, greater than equal to 0, then here we'll write this dot speed equals to speed. So ensuring that speed cannot be negative, that is why we are doing this. Okay, so speed can't be negative, so that is why we have used this if condition. Now in else block we will simply print speed can't be negative, right? Okay, now coming to the main class. So here public main function will create car, my car. Again, we are creating an object of car class. I hope these steps are just repeating, so I'm not explaining as of now, because I hope I'm considering that you guys are understanding. Okay. Now here we are basically calling the set speed, basically the setter function, which is used to set the speed. Okay. You can think of it like this. Now we'll be calling the getter function, my car dot get speed, and we have to do this my car dot set speed. This will show an error message if we'll set the, if we try setting a negative speed. For that we are doing this, we're passing the minus 10 function as well, minus 10 value as well. So this is a setter method, this is a get speed method. It will display something, it will set the speed. Okay. All right, so now let's run it. There is some error again. Okay. Yeah. Now let's try to run this. See, speed can't be negative. Obviously, speed can't be negative. We'll remove this. Now let's run. What? It is not displaying anything. I've set speed 80. My car dot set speed int speed. It is taking the speed. We are passing 80 over here, and it is greater than equal to 0.
All right, so yeah, basically we forgot to print it, the main thing. So system dot out dot print ln. So here, first of all, we'll write current speed, then using the object name mycar dot get speed, will call the function. All right, now let's try to run it. So as you can see, current speed 80 it is displaying. So this is an example of encapsulation. We're using the setter and getter method. We are setting the value and then the private value basically, and then we are also getting the value. So we are also basically displaying the value as well. So this is a example in which you can access the private, variables. So normally, without the setter and getter method, it you can't directly access the private members. I believe you know about it because their access specifier is private. You can't directly use it. But with the help of these getter and setter methods, getter will help to retrieve or read the data, whereas setter method modify and write the data. So getter method will basically display it as well. All right. So this was about this encapsulation, and I believe it is pretty much clear. I've explained it while doing it. So I hope you guys understand how we can display and we can access this speed variable that was private, and but still we are displaying it. As you can see, we are displaying it. We have assigned it a value, and then we are just printing that value. So we can, in this way, we can access that private value. All right. So this was about encapsulation. Now let's understand the other concept, which is abstraction. So let's understand about abstraction. Abstraction is a fundamental concept in object-oriented programming that focuses on hiding the implementation details of a class and exposing only the essential features to the user. This simplifies the complexity of the system by allowing users to interact with objects at a high level without worrying about their internal workings.
Now, to put it in easy words, think of abstraction like using a TV remote. When you press a button on the remote like volume up, you don't need to know how the remote sends signal to the TV or how the TV processes those signals to increase the volume. You just press the button and it works. The idea of abstraction is to hide all the complicated details and only show the important parts that you need to use. So in programming, abstraction works the same way. When you use a method or a function, you don't need to know the nitty-gritty of how it's working behind the scenes. You just use it. For example, you might have a method named sendEmail that sends the email. You don't need to know how the email server connects, formats message, or handles delivery. You just call the send email and it takes care of everything for you. Abstraction helps by keeping things simple and focusing only on what's necessary.
All right. Now, abstraction can be achieved in Java through abstract class and interfaces. An abstract class is a special type of class that you cannot create objects from. It can have two types of methods. First, abstract methods. These are like empty templates with no code inside them, and they must be filled in implemented by the subclasses. Whereas concrete methods, these are regular methods with complete code that can be used as they are. So I hope you understand abstract methods, they are empty. Nothing is there. There is no body. So in abstract functions, there is no body or no code inside them, and they must be filled in by the subclasses. Whereas concrete methods are like regular functions, regular methods with complete code that can be used like normal functions or normal methods. So this was about abstract class. Now let's have a look at interfaces as well. So yeah, this is interface. An interface is like a plan or a template for a class. It only contains the names of methods, not their actual code. A class uses an interface to promise that it will follow the behaviors defined in the interface. All right. So let's have a look at it with the help of an example. So now we'll do an example of abstraction, and in which there is a part of polymorphism also. So the code will demonstrate abstraction in Java using an abstract class shape. Now the shape class defines an abstract method draw which doesn't have the body. So in that way we'll create it. All right. So let's go to the editor and let's do it. All right. So first of all, abstract class. Abstract keyword we will use. This is the syntax. Abstract class keyword. Then the name of the class. All right. Now here the abstract function, abstract void draw. And as we know, in the abstract function, there is no body or there is no code. All right. So we'll keep it as it is, as empty. We'll keep it empty. Okay. All right. Now over here. All right. Here. So now here we will be creating a class circle, which will extends this shape class, abstract class. So basically circle class is extending the shape class. All right. Now here also we'll make a function draw. Yeah. But here there is something inside the body, which is a message that we want to display. So what do we want to display? I repeat. So what do we want to display is circle drawn. All right. So this was the second class. Now comes the third class, rectangle, which will extend the shape class again. So basically circle is also extending the shape class and rectangle is also extending the shape class. So basically abstract class shape is the parent of both these classes. All right. Now here also void draw. Here we'll write rectangle drawn. All right. So these three classes that we have just made. Now here public class main. Again and again I'm doing the same thing. All right, public static void main. All right, over here we will make an object of shape class, and using that we will be doing some things. So let me tell you. So first of all, let me just do those. Like shape is the name of the class, and shape with a lowercase s would be the object name. All right, so yeah, I'll explain to you guys. Just let me do first. All right, so now let's try to run this. Okay, there's something, yeah, by mistake we did that. Okay, void draw, where it is, void draw, cannot have a body. It is not having any body. Oh, yeah. By mistake we use this brackets. We don't have to use the brackets also, otherwise it will show an error. Okay, now, yeah, semicolon, my bad. A lot of errors we are facing right now. New rectangle. Hmm. Okay. All right. So now as we can see, it is running. Circle drawn, rectangle drawn. So now let me explain to you guys what I will do. I hope you understood that here this is the abstract class, and inside this abstract class there is an abstract function void draw, and you can't have the body of it. Neither you can have the brackets for that. All right. Now, as we can see, this is the circle class which is extending this shape class, and it also has the same function named draw, and it is printing circle drawn. Similarly, this rectangle class is printing rectangle drawn. All right. Now we have here what we can do is, as you can see, this code demonstrates abstraction in Java using an abstract class shape. All right. This is abstract class shape. Now the shape class defines an abstract method draw, which doesn't have a body. The subclasses circle and rectangle extend shape to provide their own implementation of draw methods, right? Now in the main method, an object reference of type shape is created, but it is assigned to a different concrete object, circle and rectangle at runtime. Now when shape.draw, as you can see, when shape.draw is called, the specific implementation of draw function in the respective subclass is executed, right? Now when shape is assigned to a circle object, as we can see, when shape is assigned to a when shape is assigned to a circle object, circle's draw method is called printing circle drawn. All right, this one. When shape is assigned to a rectangle object, then the method rectangle's draw method is called printing rectangle drawn. All right. So this code demonstrates polymorphism by allowing the shape reference to take different forms, circle or rectangle, and call the appropriate draw method based on the actual object type. It also shows how abstraction works by defining a common structure, shape class, while leaving the details of specific shapes like draw implementation to the subclasses. All right. So, yeah, this was a fine example of it. Now, I hope if you
I'm assuming that most of the examples that I just discussed, you guys understood. But if it is there something that you have not understood, you can just, just revert back to this video and understand it again and try that. When you'll try that, you will understand many things. Just by looking at the code, somebody is doing the code, you won't understand anything. Just understand it and then try to do it yourself as well. You will gain the knowledge by trying it yourself. That's the main thing that you should focus on right now. All right, so this was about abstraction. So yeah, we have covered inheritance, polymorphism, encapsulation to abstraction as well. Everything we just cleared. I want to practice each of these examples on your own as well.
From inheritance, polymorphism, and encapsulation to abstraction, each concept plays a critical role in improving your coding efficiency. So in this video, we have covered all of these concepts in detail with hands-on examples. Now, I want you to practice all these concepts by yourself also. Now, if you have got any questions, drop a comment and we will be happy to help. And hey, don't forget to like, share and subscribe for more career insights.
Imagine you're building a game like PUBG. You have got players, weapons and scores. But how do you store all that data efficiently? What if you need to add or remove players on the go? Or sort weapons based on the power? That's where Java Collections comes in. Collections give you the powerful tools to store, manage and manipulate data easily. So in this video, we will understand all about collections in Java, what is framework, what is collection framework, and then one by one, we will understand methods of collection framework. So what is collection in Java? In Java, a collection is like a way to organize and handle a bunch of things like a list of names, numbers, or anything else. Instead of managing each thing one by one, a collection helps you group them together and work with them easily. Here are some of the real life examples to make that thing clear. For that, let's first understand what is linked list. Think of it like your browsing history. When you visit a web page, it gets added to the list. If you go back and delete one, the rest of the list stays linked together. It's good when you want to easily add or remove things from anywhere in the list. Alright, so this was about linked list. Next we have is stack. So a stack is like a stack of plates. You always add a plate to the top and when you need one, you take the one from the top, right? This works in last in, first out way. Whatever you put in the last is the first to come out, like undoing in a game or an app. It's always the last thing you did that gets undone first, right? So this is what about stack. Next one is queue. A queue is like waiting in line at a theme park. The first person in the line gets on the ride first. It works in, first out order. So if you are dealing with things that need to be done in the order they came, like task or customer orders, a queue is perfect for you. Alright, so this was about the collections. Now let's understand what is a framework in Java. So a framework in Java is like a ready-made toolkit that helps you build stuff faster and better. Alright, think of it like building a house. Instead of starting from scratch and figuring out how to lay bricks and set up plumbing, a framework gives you the foundation, the walls and the blueprints. You just focus on decorating and making it your own. That's it. So here's the deal. A framework is pre-designed. It already has a bunch of code, rules, tools ready for you to use. It has functions, classes and libraries, fancy words for things that handle common tasks. So you don't have to write everything yourself. It saves time because you can skip the boring repetitive stuff and get to the straight cool parts of your project. Alright, now let's understand what is collection framework in Java. So the collection framework in Java is like all-in-one toolbox for working with groups of things like list, sets, etc. It's already built into Java inside the java.util package and it makes handling collections way easier and faster. Here's what it does for you. It is a set of rules and tools like a guide on how different collection types like list, queues, etc. should work together. It gives you interface and classes, basically templates and pre-made blueprints for creating and managing your data collections. It's all connected, so whether you are working with a simple list or more complex collection, they all follow the same style and structure. Now why is it useful? It makes things simple and organized. Instead of writing custom code to store and manipulate data, you can use what's already there. It has efficient algorithms, so sorting, searching, or managing large amounts of data is fast and reliable. It's flexible and powerful, whether you need a simple list of items or a complex data structure. The framework has everything for you.
Alright, so now let's talk about methods of collection framework. In methods of collection framework, we'll start with list and slowly we'll move on to other collection frameworks. So in list, so the list interface in Java is like organized shopping list. It's a part of the collection framework and it's perfect when you need to keep things in a specific order and access them by their position. A list remembers the order in which you add things, just like your shopping list. You can add, remove, or update items at any position. Some of the key methods of list interfaces add, get, remove, set, and size. So these methods are used to do the operations. Alright. Now, if you want to use the functionalities of list, we can use array list, and then we have this linked list, vector, stack, which we will be covering further in this tutorial. Alright, so now let's have a look at its code. Now, if we want to use the functionalities of list, we can use array list, linked list, vector, stack, which we will be covering further in this tutorial. Alright, so now let's have a look at its code first. Alright, so as you can see on the screen, this is the code for list. So let me tell you guys what all the things are here. So if you want to just have a look at it, you can have a look at it and then I'm going to explain it to you. So the syntax is this add function. So basically this add function uses an integer index, as you can see, integer index, and one is the element. So add int index and e element, basically that is the syntax. So basically it adds an element to the list at a specific position. Example, list add, then the position, as you can say, 0 and banana. It puts the banana at the start of the list because 0 is the index in which we want to put the banana. So it puts the banana at the 0th index, which is the start of the list. All right. Now then, get int index. Basically, this is the function that we generally use in while doing these operations. Get function, basically. Inside the get function, we basically mention the index and it fetches the element at a given index. All right. For example, list dot get one. One is the element. So one is the index. So basically, one comes in the second position because it starts from 0 and 1 na? So basically one comes in the second position, so it gets the second item. All right, then there is another function which is size. So it basically tells you how many items are in the list. Example, list dot size, it will return 2 if the list has 2 items. As simple as that. I believe you guys understand that. Now this is the basic syntax, so you can see on the screen. So this is how you can add it, and some other functions also I just discussed. So this was about the list. Now let's understand about array list. All right, an array list in Java is like a dynamic shopping cart. Unlike a regular array that has a fixed size, an array list can grow and shrink as you add or remove stuff. It's super flexible and makes managing list of things a breeze. That means it is very easy. So it implements list, that means it's part of the list family. So it keeps items in order and lets you access them by position. You can quickly get or update items using their index, just like arrays. Now, if we want to use functionalities of array list, then these are the methods like add, get, remove, size, ensure capacity. And we have also mentioned, as you can see on the screen, we have also mentioned what all these, methods do or the functionalities do. So their functionality is, as you can see on the screen, add. Adds functionality is it basically appends or adds an element to the end of the array list, or you can say inserts it at a specified index if you put the index inside it, inside the brackets. All right. Then there is get. It basically retrieves an element from the specified index if you put the index over there. So it's like that only. So you can just have a look at these. You can because ensure capacity is the new one, so you just know that increases the capacity of the array list. So you can go through all these if you want. You can just pause the video, and we'll be showing you these methods further also. So all you have to do is to I'll discuss as well, but you can also pause it if you want to just read it by yourself. So yeah, so this was about array list. Now let's have a look at its code. Alright, so now here's the code for the array list. As you can see, where we have used the list string list because it belongs to the list class. Now here
list string list new array list. So this is basically the syntax. So it basically creates a resizable list of strings. All right. Now list dot add here basically adds apple to the list, as we are just adding an apple string. Then list dot add banana basically adds the banana, and similarly then we will add the orange. Now here we are printing the list. So as you can see, system.out.println, it prints apple, banana, orange. So the array list maintains the order of items you added. So in the same order it will get added. Alright, so this was about the array list, and we also just had a look on the methods of it. Now let's understand about the linked list. Alright, so linked list. A linked list in Java is like a train with connected cars. Alright, so let me just put it in easy words for you. So each car here, car is referring to a node basically. All right. So each car or each node holds data like apple or banana and knows how to get to the next car and the one before it. This makes it super easy to add data anywhere in the list without disrupting the whole thing. Each item or node knows about the one before it and after it. So moving around or making changes is smooth. If you often need to insert or remove items from the middle, linked list is super efficient. Now, if you want to use the functionalities of linked list, then these are the methods like you can see on the screen: add, get, remove, add first, add last. And as we know that add and get, what will it give us, because it is common as of the previous one. And removes here is the new one, so we'll discuss that. As removes, this particular method will remove an element at a specified index. All right, so if you'll mention the index of that particular element that you want to remove and use this function, then it will basically remove that. All right. Similarly, add first is there. It inserts an element at the beginning of the linked list. Add last, as the name depicts, appends an element to the end of the linked list. As simple as that. So basically the linked list structure is like that, as you can see on the screen. So data is at the center, and it is link previous, previous is basically the link to the previous element, and next next is the link to the next element of it. So it is like that, data and node. So this is how nodes are basically connected in the doubly linked list, in a collection linked list in Java. All right, so this is how it is. Now let's have a look at its code. All right, so this is the linked list code again. It is quite similar. I believe you guys understand what we are doing here is because most of the operations or most of the methods are similar. In collections, you can say most of the actions are similar, most of the methods are similar, because previously also we used to add apple, because add functionality we have used before, and here also we are adding the same things. So I believe you guys understand what we are doing here. Basically we are creating a new doubly linked list with the help of this one. All right, we are basically creating the new doubly linked list of strings, and then using these we are basically adding apple, banana and orange as the string elements, as you can see. Then basically we are printing it. The linked list keeps the items in the same order you added them. So it is like that. It is the functionality of linked list, that the order in which you have added it, it will keep it in that way only. All right. Okay, so now let's move on to the next, which is vector. All right, so vector. A vector in Java is a resizable and ordered data structure that implements the list interface. It allows you to store elements in a sequential manner, maintaining the order in which they were added. All right. So, one of its key features is that it is synchronized, which means it is designed to handle multiple threads trying to use it at the same time without messing things up. Like an array list, it can grow or shrink as needed. No need to fix the size upfront. All right. So, these are the methods of it: add, and then if you want to, mention the index of it and the element, so basically it will add at the specific position, as you can see on the screen. And add all vector, basically it will append all the elements or add all the elements from the specified vector to the end of the current vector. So these were the methods of vector. And again, let's have a look at its code. All right, so its code is also the same, just we have to look at this part only. So it basically creates a new vector that can hold strings. All right, and then we are basically adding apple, banana, orange. It's up to you. We are just using these three fruits just to just show you how it goes. All right, now just like array list or linked list, the vector keeps the items in the order as we just discussed.
Here it's like the thread safe it is like, which means basically the vector is thread safe, which means it can handle multiple threads trying to access it at once without causing problems. This is great for multi-threaded programs but can make it slower than ArrayList or single threaded use. All right. So that is there. All right. So now let's understand stack. All right. Stack is there. A stack in Java is like a stack of plates or books. You always add to the top, and when you need one, you take the one from the top first. It follows the LIFO principle, that is last in first out, which means the last thing you put in is the first thing to come out. All right. For example, if I'll have to give you an example of LIFO, that is last in first out, you can take an example of bangle. So whenever girls and ladies used to put the bangles on, so the last bangle they have put in will come out the first one. Otherwise, you can't, just take off the first that you put in. In order to take off all the bangles, you have to just, remove the last added bangle. I hope you guys are understanding what I'm trying to say. All right. So in that way, we are trying to convey you that it is basically a LIFO kind of, that is last in, first out. So basically, it's built on the vector class. So, it inherits all the resizable and synchronous features of vector. It is designed for tasks like you want to add or remove things in a last in first out order. For example, as you can see on the screen, you can push it and then pop it from the last itself. You're putting it from the last, pushing it. And then if you want to remove it, it will get removed from the last place itself. All right. So, yeah. So these are some of the methods. So as you can see on the screen, push. Basically, push adds an element to the top of the stack, and pop removes and returns it all as well, the element from the top of the stack. So peek basically retrieves the element but not remove it of the top of the stack basically. So for example, let's say 1, 2, 3, 4, 5, 6. So the lowest one is having 1, then 2, then 3, then 4, then 5. So peek will retrieve that but not remove that. Whereas pop will remove that as well. Okay. So this is the difference between peep and pop. Very simple. And then there is empty. It basically checks if it is empty. This method. All right. Then search is there. It returns the one base position of an element from the top of the stack or -1. It is not that important, but you can just have a look at it if you want. All right. So now let's have a look at its code. Alright, so this is the code for stack. As you can see on the screen, stack, string, stack, new stack. This is basically the syntax of it. I believe you understood the syntax because it is almost the same and operations are also almost the same. But here, instead of add, we are using push. So basically stack, this particular syntax I'm talking about right now, this particular syntax is creating a new stack to hold the strings. All right, after that we are just using it and pushing the elements inside it. So one by one we are doing that. Stack dot push apple, it basically adds apple to the top of the stack. Then stack dot push banana, it adds banana above it. Then orange goes above it. So it is like that. Orange on banana it will go. So pop of the top item, if you want to pop it. So this is what we are doing right now over on the screen. System.out.println, we're printing it and we are popping it. So basically, as I told you, pop will remove it. Okay. So it will remove and print the top item, which is orange. After this, banana becomes the new top. You understand? It was like apple, banana, and then orange. So when we did stack.pop, it basically removes the orange, and now the topmost element which is remaining after removing orange is banana. So now banana becomes the new top. All right. Okay. So I hope you guys understood this part. It is pretty easy. Now moving on to the next, which is queue. All right. Queue is there. So a queue in Java is like waiting in line for tickets or food. The first person to get in line is the first to be served. It follows the first in, first out principle, that is also known as FIFO principle, which means the first thing you add is the first thing you take out. It's an interface, so you can use classes like linked list or priority queue to create a check. Perfect for managing things within the order that matters, where the order basically matters the most, like customer service or task scheduling. All right, so you can just have a look. Basically, the queue of, if you're going for a want to watch a movie or something, you stand in a queue one by one. And if you want to buy a popcorn or cold drink or something during the movie, you have to stand in a queue line, right? So whenever your turn will come, then only you'll be able to make a purchase out of it. So that's exactly what queue is. So whosoever goes in first
will be, will be removed first. For example, if I have to give you another example of it, then it is, you can take an example of toll barriers that we, encounters while driving. So the first car will go first, and after that the second car will pass out from that. That the last car is, passes the first. It is not like that. You can take a fine example of toll barriers here. The first car will go, then the second car, then the third car. All right. So I hope you guys are understanding. First in, first out, which means the first thing you add is the first thing you take out. It is an interface, so you use classes with linked list or priority queue, so which we'll discuss further prior to queue, to create a queue basically. Now, perfect for it is basically perfect for managing things where the order matters, like customer service or other task scheduling activities. All right, so I hope you guys understand that. All right, so these are the methods that is on your screen. This is the methods that we can use on queue. Add is there. Add is not a new one. We know poll also, we know remove also. Peak we also know. So it is same as that of the previous ones. But here the new one is offer. So as we can see, we have offer. So offer basically inserts an element into the queue, returning true if successful or false if the queue is full. All right. Simple as that. Basic English we have written. So you can also understand that thing, what I've just said. All right. To make you guys understand it in a better way, so let's have a look with the help of an example. So let's move on. All right. So as you can see, this is example of queue, and we have used queue.offer. So this is the method that we just discussed. So basically, this particular, again, I'm telling you, this particular thing that we can see, it is creating a queue using a linked list. All right. Basically, we are creating a queue using a linked list. After that, we are basically adding the items. Queue.offer apple. Now, it basically adds the apple to the queue, then adds banana to the queue, and then adds orange, like that only. Now, poll the first item if you want to, then poll is here. All right. So, poll, as we know, it removes and returns the first item. For example, in this case, the first item would be apple because we have put in the apple at the first time. All right. So, it is opposite of LIFO, LIFO. This is FIFO. The first that goes in, it will come out the first. The first that goes in, the first, and that is the one that will leave first. Okay. So apple would be the case here, you know. So in this case, apple, will be removed first. After this, banana becomes the first item in the queue. Then, yeah, so it will go like that. Then we can see another peak is there. So basically, q dot peak. So it basically looks at the first item, banana, without removing it. Okay. So if we have removed apple, then the first item will become banana, and basically it will have a look at it and it will, retrieve it or print it, but it will not remove it. Okay, so simple. All right, now moving on to priority queue. So priority queue. So priority queue in Java is like a to-do list where the most important task gets done first. Unlike a regular queue, which follows FIFO, that is first in, first out, a priority queue processes items based on their priority. Items are not processed in order they are added, but based on their natural order. You can use it like any other queue, but with priority based behavior. Some of the methods used in priority queue are as follows. Add is there, offer is there, remove is there, size is there, and clear is there. Clear is the new one, so let's have a look at it. Remove all elements from priority queue. So if you want to remove all elements from the priority queue, then you have to use clear. And I believe you guys understood about priority queue. It is a bit different from queue because it has this priority wala thing. So priority, it gives the most important task basically gets done first in priority queue. All right. I hope you guys understood this thing. Now let's have a look at it with the help of a fine example. All right. So this is the priority queue example. Okay, so as you can see, it is pretty much same as that of queue because it is actually the same. But the only difference is ki here also we are creating a queue use that prioritizes smaller numbers. All right, so we have used here the priority queue. As you can see, we are not using linked list, but priority queue here because it basically here what we are doing is we are creating a queue that prioritizes smaller numbers. So for that, it is like that. This is the syntax of it. Then q dot offer 5 to, basically we are adding 5 to 8. Now adds, basically all of these are we are adding it. All right. Now poll the highest priority item. So as you can see on the screen, the highest priority item will poll it. Basically, will remove it. So it removes and returns the smallest item, that is 2. As we know that q.poll will remove and return the smallest item, that is 2 over here. So it will do that. All right. Then peek at next priority item. As you can see, peek is there. So q.peek, look at the next smallest item, which is 5 now. After 2, there is 5 now, which is the next smallest item without removing it. So in this particular case, it will not remove it, but it will, retrieve it or access it or print it, you can say. All right, now moving on to DQ. So a DQ, short for double-ended queue in Python, is like a flexible queue where you can add or remove items from both ends. Imagine it as a train with open carriages where passengers can hop on or off at either the front or the back, depending on their convenience. It works like both a queue, that is FIFO, and stack LIFO, depending on how you use it. Alright, so these are some of the methods that we basically use. Poll first removes and returns front element, alright, and poll last removes and returns the end element. Similarly, add first adds to the front and add last add to the end, alright, and remove first also removes and returns the front element, and remove last also removes and returns the end element. I hope you guys understand this. Now let's have a look at the. Alright, so this is an example of DQ. So here, as you can see, DQ string DQ equals to new array DQ. So it creates a new DQ basically. This is the syntax of it. Now, DQ dot add first over here, we are adding apple. So it basically adds apple to the front of DQ. Then DQ dot add last, and then we are adding banana. So it adds banana to the end because here we have used add last. Then DQ dot add last orange, it adds orange to the end. Now Paul, as we know, Paul will removes and returns the first item apple. So apple will get removed, and it will also it will print that and remove that. Paul first, it removes and returns the first item. Apple will remove and it will return also. Then peak is there, as you can see, peak last is there. So dq.peak last looks at the last item, orange, without removing it. So it will not remove orange, but it will return it. Alright, so this was about DQ. Now let's understand set interface. So the set interface in Java is a part of java.util package and represents a collection that does not allow duplicate elements. It models a mathematical set abstraction, ensuring that no element is repeated within the collection. The set interface extends the collection interface and provides the foundation for various set implementations. It's the part of Java collection framework, so it works like other collections but with its unique rules. All right. So these are the methods that we use in sets, that add, remove, clear. Clear is new, so it removes all the elements from set. Then contains basically checks if the set contains a specified element. So you can put an element and then it will check if it is there, it contains that element or not. All right. Then size is there. I believe you understand what size is. Then is empty, it basically checks if the set is empty or not. All right. Now let's have a look at its code. All right, so this is the example of set interface. So as you can see on the screen, set.add will add apple. But before that, let me tell you set string set new hash set. It basically creates a set of strings. All right. Then set.add apple adds apple to the set, then adds banana, then adds orange. And as you can see here, again we have added set.add apple. It tries to add apple again, but since it's already there, the set ignores it because set doesn't take the duplicate values. All right, set only takes the unique values. So basically it is already there, so basically it will set will ignore that, this particular thing. Now, the time to print it, system.out.println set, it prints something like apple, banana, and orange, but it will not print apple again, as I just told you. It will not, print apple twice, only unique values. All right. So order may vary since hash set doesn't guarantee order, but yeah, it will guarantee unique values. Okay. So that is there. Now, come on, let's move on to the next thing, which is hash set. Alright, so hash set is there. A hash set in Java is like a magical bag that only allows unique items and doesn't care about the order. It uses a super efficient hash table under the hood, making it super quick for adding, checking, or removing items. The order of element isn't guaranteed, items are sorted based on their hash codes. All right. So this is that simple. Again, here are the methods that we generally use: add, remove, clear, contains, size, is empty. And you know all the functionalities of all these one. If you just want to learn again, have a look at it. Just you can just pause this video and have a look at the functionalities of each of these methods. Now let's have a look at its code now, hash set. So as we thought that it will be as same as that of the previous one. All right. So we are creating a hash set of strings. All right, here we are creating a hash set of strings, and then we are adding apple, banana, and orange, then we are printing it. So it prints something like banana, orange, and apple only. The order isn't predictable because hash set doesn't maintain the order, but yeah, again, all things else will be unique. So yeah, it is same as that of the previous one. Now coming to the linked hash set. The linked hash set in Java is a concrete implementation of the set interface and is a part of the java.util package. It combines the features of a hash set and linked list, ensuring that the elements are both unique and ordered based on the order in which they are added. This makes it a predictable and well organized alternative to a regular hash set. It keeps track of order in which items were added, so when you iterate over it, the items come out in the same order. All right. So these are the some methods of it. So as you can see, adds the special element to the set if it is not already present. All right, clear removes all element. Clone returns a shallow copy of the linked hash set instance. Then contains, it returns true if the set contains the specified element. Then is empty, though we know already, right? So yeah, the example part would be the same as that of the previous one, no nothing. But over here we will just use set string set new linked hash set. Like previously we were using, for the previous case we used set string set new hash set, but over here we will use set string set equals to new linked hash set because we are creating a linked hash set this time. So that only will be the change. Others, like other operation, would be same as that of the previous one, so we don't need to really worry about that. And that creates a linked hash set for strings, and then we'll simply add that, and the order is same as the order in which the items were added in this particular case. All right, the order will remain same in which we have added. The order will be is of that itself, that order itself. All right, so now let's discuss sorted set. So a sorted set in Java is like a special kind of a set that automatically sorts its elements. So not only does it keep the items unique, but also keeps them in specific order, either in natural order, ascending order, or a custom order you define. It includes methods like first to get smallest element, last to get the largest, and subsets like head set and tail set. These are some methods, and some of the other methods that are on the screen. As you can see, it is same as that of the previous one, but some of the methods, example that I just told you, that last is there, then headset is there, and tail set is there, that you can also explore those methods. It is simple as that. I mean, if you just have to try those methods on your own basis. All right, it is very simple. You don't need to worry. All you have to do is apply those methods and just read about it, because there are very long list of methods that you can't remember all those methods. You just have to go through it, and the most frequent repeating ones you will be able to remember. All right, now let's have a look at its example. All right, so as we can see on the screen, first of all, here we are creating a sorted set. So basically we are creating a what we call a tree set, you can say. We are creating a tree set which implements sorted set interface. All right, so now using set.add, we are adding apple, banana, then orange. Then while printing, the elements are automatically sorted alphabetically. So this is the case in this one. The elements are automatically sorted alphabetically. All right. Now coming to the next part, which is tree set. So tree set in Java is a part of java.util package. It is a collection of unique elements that are automatically sorted in ascending order. Unlike hash set or linked hash set, which don't sort elements, a tree set ensures that its elements are always sorted in a natural or custom defined order. It provides methods to navigate through the set, such as finding elements lower, higher, ceiling, or floor relative to the given value. And some of the other methods are just mentioned on your screen. You can have a look at it. Add all is there, clear is there, clone is there, comparator is there, contains is there. So these are the methods. Some of the more methods are there. You can just have a look at it on Google, and you know The most frequent one are the ones that I'm just showing you on the screen. Other also is there. You can just have a look at them as well. All right, so now let's have a look at this example also. So this is an example of tree set, as you can see. So this part is basically, as you can see, let me just highlight this part. So it creates a tree set to store strings, all right. And then again, we are adding apple, banana, and orange as we were doing earlier. Then we are printing it, and the elements are sorted alphabetically, all right. And when we'll print it now, so the elements will be sorted alphabetical order, all right. So basically, tree set will take care of that thing, all right.
Alright, so now let's have a look at advantages of collection framework. The collection framework in Java is like a treasure chest of developers. It gives you all the tools you need to handle data easily, efficiently, and consistently. So the first advantage is consistent API. The framework provides a standardized set of interface like collection, set, list, and map. This means every class that implements these interfaces follow a common set of methods. For example, whether you are using an array list or a linked list, you will have methods like add, remove, and size. Why it's great now? It makes your code reusable, easier to read, and simpler to work with, since you don't need to learn a new way for each collection type. Alright, the second advantage is reduce programming effort. With the collection framework, you don't have to reinvent the wheel. All the hard work like designing and implementing data structure is already done for you. You can focus on how to use the collections in your program rather than worrying about how they work internally. Alright, now why is it great? It supports the principle of abstraction in object oriented programming. Your code becomes more maintainable and easier to understand. Third advantage is improved program speed and quality. The framework includes high performance implementations of commonly used data structures and algorithms. These implementations are optimized for speed and efficiency, so you don't have to write your own algorithms to handle tasks like sorting, searching, or managing large datasets. Now, why is it great? Like, it leads to faster programs with reliable results while saving you time and effort. And that's a wrap on Java collections. Whether you need a list, a set, etc., collections make handling data super easy. In this video, we covered various methods of collection framework like linked list, vector, stack, queue interface, and much more. If you want, you can go through the video again to understand the concept again. But do try these concepts on your own. Now, if you have got any questions, drop them in the comments and we will be happy to help. Don't forget to like, share, and subscribe for more Java content. Did you know that Java powers over 9 million developers worldwide? It's the backbone of everything from Android apps to large-scale financial systems, thanks to its reliability and scalability. But here's the thing, no matter how well you code, things can go wrong, right? Maybe a file doesn't exist, the user enters invalid input, or the network decides to take a nap. So that's where Java exception handling comes to the rescue. It's like a safety net for your program, like catching errors before they cause a crash. Exception handling helps you manage these issues gracefully, keeping your application stable and ensuring a seamless experience for your users. So let's dive in and see how it all works. Now before we begin, make sure to subscribe to the channel and hit the bell icon to never miss any update. So in this video on exception handling in Java, we will understand.
So what are exceptions? Exceptions are unexpected events that disrupt the normal flow of a program. Imagine you're driving a car and suddenly you hit a pothole. That's an exception. In programming, exception occurs when something goes wrong during the execution of your code, like dividing by zero or trying to access a file that doesn't exist. Exceptions are Java's way of handling errors. Think of them as Java's way of saying, hey, something went wrong here, and I'm letting you know about it so you can fix it. Instead of letting your program crash outright when it encounters a problem, Java creates something called an exception object. This object acts like a detailed report about the error. It contains information such as what went wrong, where it happened, and the details about the error. Alright? So, to understand it in a better way, let's do a simple example. Alright, so here we will do a simple example to understand this exception. So here we will be using some try and catch block also, which we will, understand in the further tutorial. But as of now, to just let you know guys understand what is exception, let's do a simple example of it. All right. First of all, we'll have to name it. Let's change the name of this file. Let's rename it. All right. So what should we name it? Let's name it exception example. All right. Class name and the file name should be same. All right. Exception example, we'll name it. And now we will create the same only. All right. So here, let's name the class name as exception example. All right. Now there's a main function, as we can see. All right. Now inside this main function, we will be first of all declaring some variables. All right. Let's name it as numerator, and we'll assign it a value of 10. Then denominator, here we will assign it as 0 because we want to raise an exception. All right. Now we will try to divide both of these. Now we know we can't divide 10 by 0 because it will give us infinity, which is not correct. The program will show an error, right? For that only, we will be using try and catch blocks that we will be discussing further. For as of now, I can just let you know about try and catch block. So just to let you know, the try block is the one that, contains the code that might throw an exception. All right. So in try block, we will be dividing both of these. Now in the catch block, basically it handles the exception. All right. For now, just keep in mind the try block is what I just said, and catch block is just handle the exception. All right. Now let's try to make the try and catch block. So the keyword try, and inside it we will be using a variable result, and inside this variable we will be dividing numerator by denominator. Numerator is 10 and denominator is 0. All right. So we know that we can't divide 10 by 0, it will show an exception. So basically we know that this line will throw an error, right? This line will throw an error. I've just mentioned in the comment that this line will throw an error. We know it. All right. Now, after this, we will be, we want to just print something. All right. System.out.println. All right. Now, let's just write result of division. All right. So this is what we want to print. Now to catch the exception, catch catch. This is the keyword, and inside it, it is arithmetic exception. Arithmetic exception. I hope you guys are not understanding few parts over here, but this example is for you to just know what is an exception and how we can handle that. All right. So don't worry, we will cover all these things later in this tutorial. All right. So this is arithmetic exception. Here we'll mention E. This is a syntax basically. All right. Now in the catch block, as I told you, it handles the exception, right? So we'll display a message saying that, what should we display? Let's display, oops, something went wrong. All right. This is the message that we want to display whenever we encounter an exception. That will obviously arise because we are dividing 10 by 0, right? So when it will be divided by 10 by 0 over here, this catch block will catch the exception and will display this particular message. So this is how it basically works. All right. Now we'll just print something outside this also. Now we'll display, no, inside the catch block itself. If I want, let it just display afterwards. I want to display over here only. All right, so let me display another thing. Let us display, yeah, error. All right, and over here I will write e dot get message. Now I'll be explaining to you what is e dot get message, but as of now, just keep in mind this e dot get message is an important part. Now, basically, if I'll tell you, this will print the error message. All right, I'll just mention in the comment, print the error. All right, just let me explain to you guys. Just a second, print the error message. Yeah. Now, the thing is, the role of a e dot get message over here, I know you might be confused why we have wrote this. So the role of it was like when an arithmetic exception is thrown, it contains a message that describes the error, right? This is the arithmetic exception. It contains the message that describes the error. Now, the e dot get message is called on the exception object e to retrieve that object. All right. So the e dot get message, again I'm telling, the e dot get message method is called on the exception object e to retrieve this message. All right. Now I believe you guys have an idea. Now after this, we can do one more thing. Let's just print something else as well. All right. So, and after the catch block also we'll print something. System.out.println. Now here we will be displaying something. What should we display? You cannot divide by 0, right? So let's just display that thing so that a person can understand what he cannot do. What he's doing right now. You cannot divide a number by 0. All right, so this is what we want to print in the catch block whenever the program, an exception it depicts, it follows an exception, that this is what we want to display, all these things, right? Now, this particular part will handle it. It will print a message regarding that. Now, after this also, if we want to display something, then we can do that. System.out.println. Now, inside it, for example, I want to display program continues to run after handling the exception, because this line will still execute because execution was handled. All right, so this particular line that I'm gonna display, I'm gonna write, this particular line will execute because the exception was handled, right? So I just want to write program continues to run, sorry, my bad, run after handling the exception. So basically it will tell us that the error has been handled, the exception has been handled, right? So this will show us that it is being handled. All right, now I believe you guys have an idea about what exceptions are, right? All right, now let's try to run this. I hope it works. It's still compiling. What's wrong? Connection server is lost. All right, I believe there is some error. Public class exception example. So it is showing should be declared a file name exception example. And all right, so my file name is different. I believe I have reloaded, so that maybe that's why it is showing, because we named it exception example, I believe. All right, now let's try to run it. Out. All right, so at line 25 we have some error. All right, this is dot, we forgot to put dot. So all right, so as we can see, oops, something went wrong. So we are dividing 10 by 0. So obviously try will arise and or throw an error. Now this is being caught by the catch block. So the catch block displays a method saying oops, something went wrong, right? As we displayed. After that, error e.get message. So it is showing error. Now e.get message is displaying divide by 0, right? It is printing the error message. All right, that's what we want to tell them. So it basically handles it and display what we want to display. Now you cannot divide the number by 0, that we have mentioned over here, right? And after the exception is handled, the program continues to run after handling the exception. That this is what we want to display after it handles. So it is up to you if you want to display it. I have just used it because to show you guys how it works. All right, now I believe you understood what is exception, and maybe if you don't understood some terms like try and catch, so we will definitely in further in this tutorial we will cover that, so you don't need to worry about it. It is very simple, you just need to focus. All right, now let's understand why do we need exception handling, right? So this is what we did, but we now need to understand why do we really need it. Okay, all right, so why do we need exception handling? So without exception handling, any error would crash your entire program. That's frustrating for users and makes your software unreliable. So exception handling allows you to recover from errors gracefully. Instead of crashing your program, you can guide the user or retry an operation, right? The second one is debug effectively. Exceptions provide you detailed error messages, helping you identify the root cause of issue, which is very important. Third one is keep programs running. A well-handled error ensures your application doesn't stop unexpectedly. All right. So these were just the three of it that we just discussed, but there are many more. All right, but these are the main things that we why we need an exception handling. All right, now that we have understood why do we need the exception handling, so let's have a look at what are common types of exceptions. Okay, so some of the common types of exceptions include: first, arithmetic exception. Now it happens when you try something like dividing by 0. So as we have just did an example, so when we try to divide a number by 0 or something like that, the arithmetic exception occurs. Now the second one is null pointer exception. So it occurs when you try to use an object that hasn't been initialized. All right, the third one is array index out of bound exception. So this particular error will or exception is triggered when you access an index outside the boundaries of an array. All right, Now, the fourth one is class not found exception. So, this particular exception occurs when Java can't find a required class. It is pretty much clear, I believe. It is very, straight away. You can just get to know about the exception by just their name. So, these are just an example, few examples, but there are many more. Each exception has a specific purpose, making it easier to understand what went wrong. All right. Now, let's discuss the checked exceptions first. So, checked exceptions are errors that Java knows might happen and checks for at compile time. The compiler won't let your program run unless you either, right? So, it handles them using a try catch block or declare them using the throws keyword in the method. All right. Now, these exceptions usually occur when your program interacts with external resources like files, for example. A file you're trying to open might not exist. It will throw an input output exception, that is IO exception. A database, your query might fail, that SQL exception. All right. Now, Java requires you to handle checked exceptions because they represent potential issues that can be anticipated and managed. All right. So, this was about the checked exceptions. Now, let's understand unchecked exceptions. So, unchecked exceptions, on the other hand, are not checked by compiler. This means you are not required to handle them using try catch or declare them using throws. These exceptions are typically caused by programming mistakes or logical errors in your code. Things that are within your control to avoid but might still happen if you're not careful. All right. Some of the common examples include the null pointer exception. So this exception basically, is arised when you're trying to access a method or property on a null object, right? Then array index out of bound exception. You're trying to access an array element that doesn't exist. All right. Then arithmetic exception, as we discussed, dividing a number by zero. So these were the few examples of unchecked exceptions. Now the thing is that we discuss an example, and some of you guys might not understand try and catch block, although it is very easy. But just let me go through it again. So the try catch block, right? The try and catch blocks are used to handle exceptions. All right. The try block contains the code that might throw an exception. All right. So as you guys have noticed, we put the code of dividing 10 by 0 inside the try block, right? Because we know that it might throw an exception. So the code that might throw an exception, we put it inside the try block, right? Now the catch block handles the exception if it occurs. And if it is not, then no worries. Now, as in the example that we just did, in that particular example, in the catch block, we just wrote the code what to display or what to do when that particular exception occurs. All right. So catch is the one who handles it, and try is the one that contains it. Okay. Now, so that you guys understood in a better way, let me show a fine syntax of it so that you can understand and have a look at it with your own eyes. Try block is there, as you can see, int result 10 divided by 0, and we know 10 divided by 0, the program will throw an error, although we know it is an infinity. Now in the catch block, arithmetic exception is there, e is there. All right, we just did an example of it. Now you can't divide by 0. So basically, whenever this will happen, this particular message will be displayed. So it's for the syntax purposes. All right. Now, if you want to do an example, let's do another example. All right. So here we'll be using an array and we'll do something with that. All right. So let's do it. All right. So we are back on the compiler. Let's rename it again. So this time we want to name the class as, let's say, try catch, because we are just telling you about try catch block. Try catch example. All right. So let's name it this way. Now, first of all, the class name, public class try catch example. All right. Now inside it, we will be creating a main function, public static void main. All right. Now inside this main, we will be creating try and catch blocks. All right. So, all right. So for example, here we'll take an array, and that particular array has 3 or 4 elements, but we want to access the fifth or sixth or seventh element, which is not there, right? So obviously it will throw an error because those elements are not there. So to handle that exception, we'll use catch block and display something. I hope you guys understood. And if not, so let's understand it now. Int, no, first of all, we'll create a try catch block. The try block is there. Inside the try block, we will be creating an array. All right. And let's say numbers. Now, inside this array, let's name it 1, 2, and 3. Simple. All right. So these are the elements of this array 1, 2, and 3. Now, let's print something system.out.println. Here, numbers, but we want to access an element which is not over here. For example, we know that this is the 0th index, this is the first index, and this is the second index. Although the name of the digits of the elements are different, but we know the 0th index, first index, and the second index. Only 3 indexes are there, right? But let's say if I want to access the 5th or 6th index element, so we know we basically 5 here means the 5th index element, but here we have only 3 indexes, 0, 1, and 2. So how can we access that? So it will definitely throw or cause an exception. So this particular exception we'll handle now. All right. So basically, let me write it for you guys. Trying to access an index that doesn't exist in this array. All right, so that you guys can understand. Now, this is the try block, right? Now, after this try block, we'll be creating a catch block. Inside the catch block, we will, all right, so yeah, we will mention array index out of bound exception, because we know index out of bound exception from the name itself, you'll get to know array index out of bound exception. All right, so after this, we know what we usually do. Okay, yeah. Now, here we will be handling the exception. So system.out.println. So what do we want to display? A message saying error. Now inside it, you're trying to access. No, we'll just simply display it. What is happening? Yeah. You are trying to access an invalid, yeah, an invalid array index that is not there. Simple as that. So that the person can understand it. Simply we'll write it so that the person can understand it in a better way. This is the catch block. That's it. Now after this, if we want to write something, it's up to us. System.out.println. Now program continues after this also. So let's just write that program continues after handling the exception. All right then, I hope you guys understand. Now let's try to run it. Okay. So as you can see, as you are trying to access an invalid array index, don't mind the spelling, I just put wrong. Yeah. You're trying to access an invalid array index. So this is the, error that we want to display when this particular exception occurred. All right. Normally, if you'll run this program and don't use the try and catch block, it will throw an error, right? But to handle it, we use the catch block, and inside the catch block, we just display this message. So whenever this encounters, it will throw an exception over here. It will handle it and display this particular message. Simple as that. And after that, as we know that this is the code that we have wrote after the try and catch block, so it will because the exception is being handled, all right? So obviously, this particular code will run. It will not disrupt the flow. So that is why we can see program continues after handling the exception. But if the case is there that we haven't used try and catch block and then also we want to display this particular message, then it won't happen because the exception is not being handled because we haven't used try and catch block. But here we have used try and catch block, then only that is why only it is being displayed. All right. Okay, so this was about try and catch block example. Now let's move on to the next part of this tutorial, which is Java finally. Alright, the finally block is used to execute code no matter what happens. Whether or not an exception is thrown, it is typically used for cleanup operations like closing files or releasing resources. Using the finally block is considered a good practice because it allows you to include essential cleanup code. This ensures that critical code that might be unintentionally skipped due to return, continue, or break statements is executed, and resources such as files or connections are properly closed. So basically, the cleanup purposes it is used. The finally block. All right. So it's, if I have to show you a syntax of it, it's very simple. Like as you can see on the screen, try block is there, catch block is there, and finally is there. So basically, as you can see, try and catch block, you know the syntax, right? And we just did this example where we try to access the 5th index element, but only 2 indexes there. So something went wrong. As we can see on the syntax, it is being printed, and then finally is there. It is saying this will always run no matter what. which is basically what is the functionality of finally. It is used for the cleanup purposes, and no matter what, it will run. Even if the error occurs, then also the finally block runs to ensure essential actions are performed. Even if it is handled, then it will definitely do. It will definitely run. But even if the error is there, then also it will run. All right. I hope you guys understand. No syntax, different syntax is there. You just have to use the finally block, as we can see on the screen, and then whatever code or something you want to print, just type it or just do that particular code. For example, if you want to handle some something corrections or something cleanup code you want to handle, then that particular code you just type in the finally block. That for that it is used. All right. Now coming to the next topic, which is Java throw keyword. So the throw keyword is used when you want to create an exception intentionally. All right, intentionally the word is here. Now, for example, if a user enters a invalid data, you can throw an exception to indicate the issue. All right. So this is the exception that you only will arise. For example, let's say a user enters the wrong data. So to let him know, you can throw an exception and indicate that particular person key, that is, this is the error that is you're doing wrong. For example, you're typing the wrong password or you're typing something wrong. All right. And if you're not eligible, you're not 18 plus for that. All right. So sample is there, as you can see. Public void check age int age is passed, and if age is less than 18, then you can throw the error. Throw is the keyword. New, then there is illegal argument exception. This is the exception of this particular. All right. Inside this, you are raising an exception. Age must be 18 or older. So this is how you can throw an exception. For example, if I'm 17, I can't, this particular message will be displayed. Age must be 18 or older. If I'm 19 or 20, then this message will not be displayed. All right. I hope you guys are understanding what I'm trying to say. Here, if the age is less than 18 in this particular sample example, the program throws an exception with a custom message. This is the custom message that we just wrote. All right. Now, if you want to have a look at it, so let's do an example of this as well. All right. All right. So now time to rename it again. This time we'll name it through example because we are doing that particular thing only. For example, okay. Yeah. Let's just remove this code. All right. So public class through example. Just a second. All right. Static void main. As we know, inside it we can start with a static void main also, but yeah, let's write other examples first, right? Let me just remove this one. All right, so yeah, let's create some functions first. Validate age int age, where we will be passing the, here we will be passing the age from the main functions. All right, so let me just write some code inside it, and where we will be throwing the error. Throw new legal argument exception, as you can see, illegal argument exception error with a capital E. Error is saying age must be 18 or above, right? Simple as that. Age must be 18 or above. Now, this is the thing that here we want to do. Like above it, we have to use a filter, right? If age, just a second, age is less than 18, then only we want to display this particular message. Okay. So this is the condition. If age is less than 18, then only we want to display this particular message. Age must be 18 or above. All right. Now in else block, simply system dot out dot println. Here we want to display if the person is 18 or older, then we'll display welcome with an exclamation sign. You are eligible. All right. I hope you guys are understanding what we are doing over here. If age is less than 18, we'll throw this exception. But if it is, older than that, that particular person is older than 18, then this particular message will be displayed. Welcome, you are eligible. All right. Now, this was about the method or function that we just wrote. Now, coming to the main function, public static void main. Inside the main function, again, we will be using try and catch block. So let me just use it. So here we are calling that particular function, that is validate age, and we are passing the age as 15, let's say, right? Let me write passing the invalid age, all right, so that you guys can understand. Now in the catch block, first of all, we'll have to write this particular exception. Let me just copy and paste it. All right, E is there. Now system dot out dot println here e dot get message. All right. So e dot get message here basically we are handling it, handling the thrown exception. All right. Now after this catch block, what we are going to do? We are simply going to display a message. Program continues. This time we'll not type the whole. We'll just write program continues. All right. Now I hope this particular program runs. All right. So now let's try to run this. I hope it works. So it is throwing some error. Public class throwable example should be declared in a file name. Yeah. So again, we have to change. We changed actually. I don't know what's wrong. So the class name and the file name should be same. So that is why it is showing some this error. So let's change the file name as for example, which is the name of the class. All right, I hope now it will work. So as you can see, a message is showing that error age must be 18 or above to register. All right. And the second message is this one, program continues after exception handling. So we know that this is the code that will, run if the error is handled. So it is just showing, it is the, validation which tells that the exception is being handled. All right, it is just for that. Other than that, as you can see on the screen, that what we just did, we wanted to print this message when particular age of a person is less than 18. So we have put the condition if age is less than 18, and we know that in the validate age function we are passing the age as 15. All right, so age will go here, it will check if age is less than 18, and yes, the age is less than 18. So it will throw this error, age must be 18 or above to register. So and that's how all the other things will work. So for those who didn't understand, let me explain again. The validate age is a function that checks if the age is less than 18. All right, this is a function validate age. It checks if the age is less than 18, and if the age is invalid, that is less than 18, the method throws an illegal argument exception. All right, with a custom error message. This is our custom error message. All right, now in the main method, where is the main method? Here is the main method. Now in the main method we call validate age, and we are passing 15, which triggers the exception because age should be 18 or greater than 18. If age is less than 18, it will trigger it. So this when we pass 15, it triggers the exception. And the catch block here, as you can see, the catch block over here is, it basically, the catch block catches the exception and displays the error message, preventing the program from crashing. And as we know that it handles the program from crashing, that is why this particular message is being displayed. All right, so this is how it goes, and you can see the output over here. So it is working fine. All right, I hope you understand this example, and I want you to try this example so that you can also you will understand it in a better way then. All right, for now let's move on to the next topic that we want to cover, which is custom exception in Java. All right, so custom exception in Java. Sometimes the built-in exceptions provided by Java aren't enough to describe the specific errors your application might encounter, right? So in such cases, you can create your own custom exceptions, all right? So these allow you to define errors that are meaningful and specific to your program, making your code easier to debug and maintain, all right? So these custom, from the name itself, we are getting to know custom exception. So custom is that is, created by you or us. So basically they allow you to define the errors that are meaningful and, to instruct basically, so that it will be easier for you to debug in the long run. So to create a custom exception in Java, create a new class, and that extends the exception class, right? Or runtime exception if you want an unchecked exception. Now add a constructor that takes a message or other data and passes it to the parent class using super. So to create a custom exception, you have to go through this. Now to make you guys understand it in a better way, let me do a fine example in which we will be creating a custom exceptions. Now let's do it, all right, so that you can also understand in a better way. All right, so let's remove this now. Yeah, so here also we'll be naming this particular file name, and according to that only we'll be making a custom exception. or we can just let it be like this only. Let's keep it main itself. All right, we don't need to change it. Let's keep it main. All right, so yeah. All right, now first of all, we will be creating a class and which extends the exception. So basically, this program first creates a special type of error called my custom exception, which is based on Java's exception class. All right. So inside this, we will be then creating try block and then catch block, and then using this particular class that we will be creating now. So we will be creating a custom exception class, you know, and in Java, you can create your own exceptions by extending the built-in exception class that we just gonna do. Class my custom exception extends exception. All right, now as I just told you, in Java you can create your own exceptions by extending the built-in exception class. So here my custom exception, as you can see, it should be capital. So here my custom exception, this particular thing is a new type of exception that we are defining. All right, the my custom exception class has, it will have a constructor of the parent class. So let me just write it first so that then I'll be explaining to you. All right. So first of all, let's create this particular class. So inside this, what we're gonna do? Yeah. So public my custom exception string message, and then super message is a super class. Basically, it is used to pass the message to the exception class. All right. It is used to pass the message to the exception class. Let me just write it for you guys. Passing the message to the exception class. All right, I've just wrote the comment so that you can also understand. So here, public class main, the main class is here, main with a capital M. Yeah, not this one. All right, now public static void main. All right, so now inside the main, so this is a main class and this is the main function. Now inside the main function, we will be creating try and catch blocks. Now the try block, as we know, is used to enclose the code that might throw an exception, right? So here we will explicitly, throw an instance of a custom exception using the throw keyword. All right, let me just write it for you guys. Don't worry guys, if you're still not understanding it, I will again explain to you after, completing this code. But if you guys are understanding as I'm doing it, so it is well and good. All right, just a second. Yeah, so inside try we will write throw new my custom exception. Yeah, it will throw it, and the message will be this is a custom exception. So you can write whatever you want. I'm just writing this is a custom exception. All right, let's use exclamation sign. Okay, so yeah, this is the try block. After try block, we know what we usually do, that is the catch block. So here it will handle it, custom exception, my custom exception E. So here it will take it or catch it. Here we will be printing something, system.out.println. Inside it, we'll first of all display a message saying caught the exception and e dot get message. All right. So yeah, pretty much about it. So now, as you can see, this is the try block. All right. So the try block, as we know, is used to, enclose the code that we know that it might throw an error. Now here we are explicitly throwing an instance of our custom exception class. I repeat, of our custom exception using the throw keyword. The new custom exception, this, as you can see, the new custom exception, the new my custom exception here is this is a custom exception part creates this particular part I'm talking about. This particular part. So this particular part creates a new object of a custom exception and passes the message. This is a custom exception to it. All right. Then comes the catch block. So basically, the catch block, we know what it does. The catch block is used to handle the exception if it is thrown. So here we are catching exceptions of the type my custom exception. All right. The E is a variable. The E is a variable that holds the exception object. Now inside the catch block, we print the message associated with the exception using e.getMessage. This retrieves the message we passed when creating the exception. All right, this is a custom exception. This will, retrieve the message that we passed when creating the exception. When creating the exception, this is the message that we passed. So it will retrieve that. This particular thing will retrieve this particular message. All right. And talking about this part, if you're not understanding this part again, so we did nothing. This is a custom exception. This is how you create a custom exception. Now, basically, this is a custom exception class, right? Now, in Java, you can create your own exceptions by extending the built-in exception. As I already told you, this is a built-in exception class. You can create your own exception by extending the built-in exception class. So here, by my custom exception, as you can see, it is a new type of exception that we are defining. All right, this is what we are defining. So this particular class has a constructor that takes a string parameter called message. As you can see, string parameter message of the data type string, simple as that. All right, now the name of the parameter is message. Now the here we can see super message, and I just wrote passing the message to the exception class. So what it is doing, this particular thing, this particular line calls the constructor of the parent exception and passes the message to it. This allows the exception to store a custom error message. All right, I hope you guys now understand what I'm doing. Now just go through this example one more time if you're not understanding it, and then try it yourself. So this is how basically you create your own custom exceptions. And this was pretty much about the custom exception in Java. And I want you guys to practice all these examples by yourself so that you can also understand and in a practical way. If you don't do all these examples that I'm just doing on the screen, so it will be of no use. Just reading the theory will not gonna help you. You have to do examples only by your hand only, then only you will get to know. So what we are doing, so we forgot to run it. Let's run it. So as you can see, caught the exception. This is a custom exception. All right, so this is what we want to print. This is a custom exception, this particular message. All right, so caught the exception is from there, and e.get message is retrieving this particular message, so it is being printed like this. Caught the exception, and this is a custom exception. I hope you guys now understand how to create your own custom exception.
So that was about custom exception in Java. Now also, if you want to become a cloud professional and advance your career in one of the fastest growing fields, the Professional Certificate Program in Cloud Computing and DevOps is for you. This online program is designed for working professionals, providing practical skills and knowledge needed for cloud and DevOps roles. You can opt for additional AWS or Azure exam preparation for an extra fee. Whether you're starting fresh or leveling up, this program will help you take your career to the next level in cloud computing and DevOps. So don't wait, click the course link in the description to learn more. So by understanding what exceptions are and why they occur, we can write more robust and reliable code. We explore the importance of exception handling, which helps in preventing crashes and also helps in maintaining program flow and debugging errors. We also covered common types of exceptions from runtime errors to checked exceptions and how to handle them using the try and catch blocks. Additionally, we discussed the finally block, which ensures important cleanup tasks always run, even if an exception occurs. We then understood how to raise custom exceptions, all of it with hands-on example. Now, I want you to try all these examples on your own. And if you have got any questions, drop them in the comments and we will be happy to help. Don't forget to like, share and subscribe for more technical content.